Welcome to the Computer Network Security from Scratch to Advanced course. I am Dr. Muhammad Adli and I will be your instructor in this course. The objective of this course is qualifying beginners and intermediate students to be professional in computer network security. This course requires no background about either networking or security. The course material is based on the material of several security courses offered by SANS Institute. This course covers the theoretical background about computer networks and the practical tools used in network security in both essences, either academic or professional. You will be able by the end of this course to secure your network from the point of design to operation, and also monitor and perform incident handling as well as penetration testing for your network. About myself, I'm Dr. Muhammad Adli. I hold BSc in Communications and Electronics Engineering since 1998. I hold Diploma in Computer Networks in 1999. I got my Master degree in Computer Networks in 2005. I hold 4 SANS certificates in Security Essentials, Incident Handling, Firewalls, and Wireless Security from SANS. I'm PhD in Computer Networks since 2014. I'm certified instructor from Dale Carnegie. I work as professional instructor in Computer Networks and Security since 1999. Let us now move to the sections of this course. Section 1 is Introduction to Computer Networks. The first lecture answers the question of what is a computer network. The second lecture covers the topologies used in computer networks. The third lecture is about the categories of computer networks, and the fourth lecture is about the devices used in computer networks such as the switches, the routers, and the services offered by computer networks. The lecture 5 focuses on the transmission media either in the wired networks or the wireless computer networks. Section 2 is about the ISO OSI model, the 7 layers. Why do we use such a model in the computer networks? This is answered in lecture 1. Lecture 2 speaks about the application, presentation, and session layers, the upper 3 layers of the 7 layers. Lecture 3 speaks about the transport and network layers. Lecture 4 tackles and handles the data link and physical layers of the 7 layers. And Lecture 5 shows how this model works, how it is put in action, how it manipulates data and sends and receives packet between each other while sending or receiving. Section 3 is about the famous protocol, the standard protocol of the Internet, the TCP/IP protocol suite. Lecture 1 introduces this protocol and shows the meaning of the word protocol in the world of computer networks. Lecture 2 handles the IP protocol working in layer 3, the IP addressing and routing. Lecture 3 handles the TCP and UDP protocols working in layer 4 and the concept of the port number. Lecture 4 handles the application protocols working in layers 5, 6, and 7 and shows the FTP, the HTTP, the DNS protocols and how are they working inside the TCP/IP protocol suite. Lecture 5 shows the characteristics of the TCP/IP and starts by handling the commands and tools working with the TCP/IP such as ping, NSLOOKUP, and other commands using the TCP/IP protocol suite. Section 4 shows the wireless network's benefits and why do we go wireless sometimes. Lecture 2 shows the wireless network's types. Lecture 3 shows the wireless network protocol, the famous protocol of Wi-Fi. Lecture 4 shows the wireless network's devices and mainly the access point, its features, and how it is embedded inside the wired infrastructure. Lecture 5 shows the drawbacks and what are the disadvantages of going wireless inside the network. Section 5 is the introduction of computer network security, and the rest of the sections are all about the security. Lecture 1 in this section introduces the security goals. Lecture 2 shows how securing the network starts from the point of designing the network. Lecture 3 shows the security issues that can be found in the TCP/IP protocol suite and the tools that can craft some packets. Lecture 4 shows the concept of port scanning and the tools that can be used in the port scanning. Lecture 5 shows the concept of sniffing and the tools that can be used in sniffing and how sniffing can be beneficial and how it is useful for securing our network if done with permission. Section 6 is about the firewalls and the honeypots. Why do we use a firewall? This question is answered in Lecture 1. Lecture 2 shows how do we use the firewall rules. Lecture 3 manipulates the filtering and the action of the firewall for the packets. Lecture 4 shows the concept of the honeypots and how and when it is used. Lecture 5 starts to show how the firewalls can be bypassed. Section 7 inside this course shows the concept of intrusion detection and intrusion prevention systems, IDS and IPS. What is an intrusion detection system? This is covered in Lecture 1. How an IDS works inside the network and how it is performing to be a network IDS, NIDS. This is the subject of Lecture 2. What are the challenges of NIDS? NIDS stands for Network Intrusion Detection System, and how can these challenges be overcome? Lecture 4 deals with Snort software as Network Intrusion Detection System. Lecture 5 introduces the concept of Intrusion Prevention System as a mature technology used nowadays in security and that shows a very big success in the world of security. Section 8 handles the wireless network security, and Lecture 1 tackles the wireless encryption protocol WEP and its attacking and how this protocol is obsolete right now and can be used for security. Lecture 2 introduces the advantages of WPA and AES protocols, and when we speak about encryption protocols we do not handle the mathematics, but we speak about the protocols and we handle the protocols from the point of view of the usage and of the advantages and of the comparison between them. Lecture 3 handles the wireless security misconceptions and how do people think that wireless networks can perform and can offer while it really does not offer these things. Lecture 4 speaks about the wireless attacks and how it can be mitigated. Lecture 5 shows how can we secure a wireless network from the point of designing such network and how do we embed the wireless infrastructure in a secure way inside the wired infrastructure. Section 9 introduces the physical security and introduces also the incident handling. Lecture 1 is about the objectives of physical security and how the human lives are the most important object of physical security, Lecture 2 shows that physical threats and their mitigation and how the physical threats can be overcome. Lecture 3 introduces the defense in-depth concept and how to make the attacker face a problem followed by another problem and how to slow the pace of any attacker trying to perform network intrusion on your network. Lecture 4 shows what is incident handling and what is an incident and how an event can be considered as an event of interest then transformed to be an incident. Lecture 5 demonstrates the steps of incident handling in a professional way and on scientific basis and on scientific background. Section 10 is a conclusion, and we try to show and demonstrate the concept of the CIA, confidentiality, integrity, and availability. In Lecture 2, we show the meaning of assets, threats, and vulnerabilities. In Lecture 3, we define the risks and the network intrusion. In Lecture 4, we demonstrate how are the common attacks in the world of network security performed. And in Lecture 5 we offer some recommendations that can be used directly to secure your network in a professional way. The course moves to you step by step using the academic and the professional background as well as the software tools from the level of beginner to the level of professional inside network security domain. Thank you. Welcome to our course. Let's start our course by answering this question. What is a computer network? The definition of a computer network is simply as follows. It's a group of computers that are sometimes called hosts or nodes, and a group of computer peripherals that are all connected together via transmission media and some connecting devices. All of these elements form what we call a computer network. The types of computers have changed. Nowadays we have laptops, tablets, smart mobile phones. We used to have only personal computers or PCs that were also called desktop computers. Nowadays we have others that are mobile and that can transfer and send and receive information over the network. Every single human can now be connected to a computer network through PCs, through laptops, tablets, smart mobile phones, and through what is called embedded systems inside some of the electrical or mechanical machines. Yes, some of these machines can send and transfer and exchange data and information between each other transparently without the interference or the interaction of the human user in order to offer a certain service for him with his minimal or with the least interaction from his side. This concept is known as Internet of Things. Internet of Things allows things, machines, to exchange information between each other in order to offer a certain service required by human users. The peripherals that can be connected to a computer are simply the hardware, the printers, the scanners, the storage media. All of these are called peripherals. These peripherals can also be connected to a computer network as senders and as receivers of information and orders from the computer users to execute something that he wants to be done. Printers, scanners, and storage media can be directly connected to the computer network and be part of it to act as sources and destinations of data being transferred. If we have a look inside a cloud computing or a data center, we can see some servers, some storage devices, and some terminals that are used for managing and configuration of the devices inside this cloud computing or data center. All of these can be seen as connected through transmission media in a local network inside the center to offer a certain type of service required by the computer user, either infrastructure as a service or platform as a service or software as a service. This newly introduced concept is known as the cloud computing concept, and that is mainly depending on computer networks. The transmission media. The transmission media used by a computer network can be the wired media, the cables, or the wireless media using air as the transmission media. The wired media, the cables, can be made of copper or can be made of fiber optic. Copper cables can either be coaxial cables or twisted pair cables, and in turn the twisted pair cables can either be shielded cables or unshielded cables, either STP shielded twisted pair or UTP cables unshielded twisted pair. The fiber optic cables does not transmit electricity, it transmits light. Light moves in the fiber optic cables in the form of single mode light or multi-mode light. The difference between single mode and multi-mode is in the capacity and the speed of this cable. The wireless transmission media using air depends mainly on a specified frequency band and a certain area or distance of coverage. Every wireless technology differs from the other in the utilized frequency band and the utilized area of coverage or the distance between the sender and the receiver covered by this wireless network. Every wireless technology has a named band and a limited and known area of coverage to transfer data across. The benefit of connecting computers through a network mainly lies in resources sharing. Resources, either hardware or software. Hardware resources like the computer peripherals, printers, scanners, and other peripherals that can be connected to computers can also be shared through a computer network. One copy of a printer can serve 10 users instead of buying 10 copies of printers to serve these 10 users. We here save money, save cost, save effort, and also save time through one copy of the hardware that can be shared to many users. The storage media can act in the same way. One storage media can store for several users. The processing power. One supercomputing multiprocessor server can help in the processing of several computers if shared through the network. The software resources that can be shared through the network can be a file that can be copied and pasted over the network, that can be shared between two devices over the network. It can be a database of students that can be shared through professors, database of employees shared through the company accounting department to calculate their salaries and their bonuses. Applications also can be shared over the network. They are also software resources. An example of an application, the simplest example, is a game that can be played by several users over the network. This is an application that is used over the network by several users and in real time. Services. Services that can be offered over the network can be the browsing service, searching for information over the network, and exchanging email messages across the users of the network. These are the most commonly used services. Also, establishing voice calls and video conferences over the network are one of the common uses of a computer network inside an enterprise. The basic network elements are mainly the end devices. These are the communicating devices, the senders and the receivers, the sources and the destinations of information. These are the target of the network to communicate with each other. Other devices exist inside the network as intermediate devices, as connecting devices, such as the switches, the routers, and the access points. Such devices are not meant to be sources or destinations of information, but they are acting as transferring entities for the information to help or facilitate the moving process of these information across the network. The medium used through the information network specifies how these devices are connected. Are they connected in a wired way or in a wireless way? Are they going to use the cables or the air as the media of connection? Messages. The messages are the information that are needed to be traveling through the network, needed to be transferred, needed to be communicated from the sender to the receiver. Messages are also the target of the existence of computer network. We establish computer network to transfer messages across the end devices through human users. The protocols of a computer network rules and governs how the information is transferred. The protocols are the agreements and are the standards that every device, either connecting or end device, should follow and should take care of when dealing with information inside the computer network. Hopefully we have now answered what a computer network is. Thank you. Now let us explore the computer network's topologies. What is a computer network topology? What is meant by the word topology? The word topology means the arrangement, the structure of the various elements of a computer network, which depicts both physically and logically. The physical topology is the physical way the network is wired, how the computers are connected to each other. The logical topology identifies the way messages are sent, how to send a message, and how a message moves from one machine to another. The topology can be explained in a physical and logical essences. The basic network topologies, the most common, the most well-known topologies are the point-to-point topology, the bus topology, the ring topology, the star topology, and the mesh topology. Now we will explore one by one of them. The point-to-point topology is just a link, a physical link, either a cable or a wireless link that is connecting two points, or it can be a logical link, logical point-to-point connection, that is passing through an ISP, Internet Service Provider, connecting a source node to a destination node. It's a dedicated link, a dedicated media to connect these two nodes only. The bus topology is a single cable that functions as a bus, as a shared media, as a backbone. Computers attach or tap with an interface connector to this bus. This bus, this shared media, is terminated by terminators, and the computers are connected through connectors either in T-piece or in Y-piece. We can see here the topology of the connection and the connectors, the T-piece, the Y-piece, and the terminator that resides at the end of the bus cable. The advantages of the bus topology is that it is simple to design, very simple to design and very easy to install. It is also inexpensive due to using the coaxial cables as the shared media and using the B and C connectors, BOINET, nil concealment connectors. These type of connectors are very cheap, inexpensive, and very efficient in working. The disadvantages of this bus topology is the security. This topology allows for sniffing. Every message passing from one machine to another can be sniffed by any other machine on the same bus. This means that the privacy of the message, the confidentiality of the message can be tackled anytime it's passing the media. The bus topology is slow during high traffic. If high traffic is introduced to this topology, the speed of the whole network goes down, leading to poor performance. The bus topology allows for collisions. Collisions means that assume that two machines are sending their messages at the same second. Both of messages will exist on the shared media at the same second as well. So both messages will collide with each other. Here is how collision happens. Zeros and ones of both messages will no longer be zeros and ones. They will be something else that is called jam signal. Something that has no meaning, that is meaningless, which means that we have to retransmit both messages again, which means poor performance and slower network and many times of retransmission. The third topology is the ring topology. The ring topology basically is a cable in the form of a ring as shown that connects one node to another to form a ring. The ends are attached to each other in the form of a ring. Messages travel through this ring always in the same direction, always in one direction, either clockwise or anti-clockwise. The messages are transmitted in frames that circulates all the machines, which allows for sniffing, obviously. The ring topology allows for acknowledgement. The sent frame circulates back to the source of the message to acknowledge that transmission has been done and to set the frame free for another machine to put its message on the same frame to be sent as well. The advantages of the ring topology is that it is simple also to design, easy to install. It's very inexpensive due to using the coaxial cables and the BNC connectors. It looks like the bus topology in this side. The disadvantages of the ring topology is that the entire network fails if only one machine fails because it breaks the ring. It stops the messages from circulation. So the whole network fails if only one machine member of this network fails to connect. The expansion of this network or reconfiguration affects operation. Imagine that you want to expand this network. You have to stop one of the machines, add another machine. You will have to break the ring and the circulation of messages will stop for some time until you finish the expansion or reconfiguration. Then the operation is restored. The ring topology is also slow for big numbers of machines. If a big number of machines is installed in ring topology, this leads to slow network and poor performance also. The star topology. This is the most well-known, the most common topology that is used nowadays in networks. The star topology depends on connecting each station directly to a central device as seen in the image. The connection is like a number of point-to-point links. Each machine looks like being connected in a point-to-point link to this central device. This central device can be a hub or a switch. Nowadays, switches are more commonly used than hubs. The switch is a more recent technology and more secure device. The switch allows for no sniffing to be done, while the hub allows for sniffing to be done on the network. The switch allows for no collision to take place, while the hub allows for collisions to take place. So, the switch is now the most used technologies in connecting a number of machines to each other in a local area network or a LAN. The advantages of the star topology is that the network is not affected if one machine fails or if the network is reconfigured. The network expansion is very simple. You just add the new machine to the switch or the hub without affecting the performance or the operation of the whole network. Troubleshooting is easy. You can easily identify the failing machine from the switch. You can easily identify where the problem or where the broken cable exists. The disadvantages of the star topology is that if the central device fails, all the network fails. And this is very rare to happen. This is not common to happen. Central devices are so far reliable. The mesh topology means that every device is connected to the other devices through a separate link. It connects all devices with multiple paths. So, between each device and another, you can find multiple paths that can connect such device to the other one. It offers a very high redundancy in connection, which means very high reliability, which is part of the security of the network. The number of cables equals to the number of connected nodes multiplied by the same number minus 1 and then divided by 2. This equation is used to calculate the number of cables used in any mesh topology, knowing the number of connected nodes. The advantages of the mesh topology is that it is very high fault tolerant. It allows for broken cables to exist because any broken cable can be substituted with another path for a good cable to exist. It's very secure since it has high availability, and availability is part of the security. So it is very secure from this point of view. The disadvantages of the mesh topology is that it is expensive due to using big number of cables, and due to offering high redundancy, this leads to very high cost sometimes. By this we come to the end of the computer networks topologies, and we hope that we clarified the most known and common basic computer network topologies. Thank you. Let's now categorize computer networks and know the categories of a computer networks. What could it be? Categorizing computer networks can be according to the transmission mode of this network, the geographical area covered by this network, or the administration type applied to this network. The transmission mode can either be simplex, half duplex, or full duplex. In a simplex network, the data always flow from the same source to the same destination over the media of this network. The source of data is always the same, and the destination is always the same as well. The direction of data is always from the same source to the same destination in a simplex network. In a half-duplex network, the source can be a destination, and the destination can be the source of data. Both can send to each other, but at different time intervals, which means the source can send to the destination at time t1, and after a certain period of time, at time t2, the destination can send to the source back. In a full duplex network, each station can be the source and the destination at any time. The direction of data all the time is bidirectional. The source and the destination can be any machine at any time in a full duplex network. The signaling mode of the network is also one of the terminologies we need to know in our course. What is the meaning of baseband and broadband? Baseband is one signal that flows at a certain time on the network media in a digital form. It is a digital local signal flowing, for example, as in this image, from the workstation to the modem, inside the room or inside the building or inside the local area network. This baseband signal gets to be modulated. After modulation, this baseband signal becomes a broadband signal that can travel a long distance from the modem till the central office of the PSTN, or the public service telephone network. In broadband, divides the network media into multiple channels. This allows for several signals to exist. The broadband signal is analog modulated signal, while the baseband is digital. Categorizing networks according to geographical area can lead to having local area network or LAN or wide area network or WAN. As you can see in the image, a WAN or wide area network can be formed of different LANs connected through WAN link. Simply, a WAN can be two connected LANs through a large geographical area. The LAN is a group of computers connected in small geographical area. Small means less than 3 kilometers, or just only group of computers connected inside one building, one company, one entity, having a group of computers, telephones, televisions, network printers, and others connected through one switch. This is a very simple LAN. LANs are used to share files and services inside this company or building. It's a communication of high speed, which means that the speed of this LAN can be 1 gigabit per second or even more, according to the speed of the switch. The LAN is always under the administrative control of its owner, its designer. The LAN is under the user administrative control. Technologies used to establish a LAN can be Ethernet or token ring. The wide area network or WAN is a group of computers connected in large geographical area. Large means more than 3 kilometers. Compared to a LAN, the WAN is low speed. It is in the range of megabit per second speed. The WAN is under the administration of the ISP, Internet Service Provider, since the links connecting the WAN belongs to this ISP. The technologies used to establish a WAN can be the dial-up, the ISDN or the Integrated Services Digital Network, the DSL or the Digital Subscriber Line, X25, Frame Relay, or the most recent, which is the ATM, the Asynchronous Transfer Mode. These are all technologies that are used to connect computers through a WAN. The most common used now for connecting computers to the internet are of course the DSL technology, either synchronous or asynchronous DSL. Categorizing a network according to administration type leads to having peer-to-peer network or client-server network. In a peer-to-peer network, each host provides and consumes network services. Each host has the same administrative privileges. Each user sitting on a machine is the administrator of this machine and shares whatever services he likes and also receives whatever requests he likes and access any file he would like to access according to the permissions of this peer-to-peer network, of course. In a client-server network, some hosts are assigned server roles. What is the meaning of a server? The server is a superior computer, superior in hardware and software. The hardware of a server is big. Big means big storage, big network connection, big memory, and also powerful processing. The software of this server is a server operating system, which is powerful enough to run such hardware. Servers provide network resources to hosts. Each server exists on the network for the purpose of a certain service. A server can be web server, mail server, DNS server, or other server, which means that this machine server dedicated for a certain service. Other hosts that are not servers are assigned client roles. Clients consume the network resources. Clients send requests to servers and receives the reply of such requests from the servers, so they are recipients, so they are consumers on the network. According to administration type, from the point of view of centralization, in the peer-to-peer network, no central server exists. In a client server, all client machines connect to a central server and sends requests to it. From the storage point of view, each machine shares files equally with each other. But in the client-server network, all files and folders are stored on dedicated storage on the server. Clients only access such files. From the cost point of view, peer-to-peer networks are inexpensive, while the client-server networks are expensive because of the cost of the server, the cost of the hardware, and the cost of the license of the software required for the server to run. The peer-to-peer network is scalable in the range of home or small office, while the client-server scale is in a medium or large enterprise scale. The operating systems existing on a peer-to-peer network is the client operating systems only. The operating systems existing on a client server are the server operating system, such as Linux or Microsoft Windows Server, to handle multiple requests from the clients. Hopefully, we have now introduced the different categories of computer networks. Thank you. This lecture is about the computer networks devices and the computer networks services. The networks devices can be the network interface card, the NIC card, the hub, the switch, the access point, or the router. The network interface card is the card connected to the motherboard from one side and connected to the network cable from the other side. It's the network adapter. It's an interface between the PC and the network cable. It resides inside the motherboard of a PC. It establishes the communication with the PC through the device driver. Any hardware connected to the motherboard must have a software driver to facilitate the management, the configuration, and the performance of this piece of hardware. This NIC card contains transmitter and contains a receiver at the same time. It's called a transceiver, which is a mixture between the transmitter and the receiver. The network interface card can be wired, which means that can be connected to a cable, or wireless with an antenna connected to the air interface, and can be both wired and wireless at the same time. The hub. The hub shares the frames between machines. A frame of data that is sent by machine A to machine B is shared among machines C, D, and E and all the other machines inside the hub to reach its destination from A to B. This means that the hub is a very good chance for sniffing. The hub is composed of a number of ports to connect several machines. Each machine is connected to the hub through a port inside this hub. The hub works with full duplex communication. Each machine can send or receive at the same time and at any time on the hub. The hub can connect machines with mixture of speeds, ranging from 10 mega, 100 mega, 1 giga, and even more inside the hub. The hub allows for collisions. A sender can send, meanwhile another sender wants to send, which means that both signals from sender A and sender B can meet at the same time inside the hub, forming a jam signal that has no meaning. And at this point of time, sender A and sender B has to resend their messages. Collisions mean hub is one collision domain. The hub is one broadcast domain. Collisions make the network slow and congested. Collisions happen when two senders want to send at the same time and their signals add as zeros and ones on the media to form something that is neither zero nor one, that is a jam signal, and then both machines have to resend their messages. To avoid collisions, machines connected through a hub follows an algorithm that is called SYSMA-CD. SYSMA-CD stands for Carrier Sense Multiple Access Collision Detection. If a machine wants to send a message over the media, that is the hub, it first must sense the carrier. Is there another carrier on the media? If there is another carrier on the media, then this machine that wants to send has to wait for some time. If unfortunately two machines, like here in the image, such as A and D, want to send at the same time, they both sense the media, they both find the media empty at the same time, they both tend to send at the same time. This is the point of time that collision happens. This is the point of time where both signals meet on the media, forming something that is meaningless. What happens when collision happens? Collision detection takes place, and then a backup algorithm makes A wait for a certain time before resending its message that has collided with another message, and D waits for another period of time to resend its message that has collided with another message. This, of course, makes all the machines lose some time and makes the network slower and leads to poor performance for this network. Collision is something that we do not like to happen on the network. The switch. The switch is one of the network devices that is a more recent technology than the hub. It forwards and filters frames. The switch forwards frames among the ports that want to send to the ports that want to receive only. So the switch allows for no collision, and the switch allows for no sniffing. The switch is better in performance, and the switch is a more secure technology than the hub. The switch works, of course, with full duplex communication. Each machine can send and receive at the same time. The switch can work with mixture of speeds, ranging from hundreds of megabits per second to gigabits per second. The switch is one broadcast domain, but each port inside the switch is a separate collision domain. That's why, once more, the switch allows for no collisions and allows for no sniffing. The access point. This is a wireless device that connects machines wirelessly inside a LAN, a local area network. It transmits frames in the air media and also receives frames in the air media. It links the wireless part of the network to the wired infrastructure. The antenna send and receive wirelessly. Meanwhile, the access point itself is connected to an Ethernet cable, a wired interface that connects the wireless part of the network to the wired infrastructure of the network. The access point is one broadcast domain. The access point, of course, is one collision domain and allows for collision. Meanwhile, there is an algorithm that can be followed to avoid collisions in the air media, which is called SYSMA-CA, Carrier Sense Multiple Access Collision Avoidance. The router. The router is the device that redirects packets between networks. It works based on a routing table that is stored inside it or built inside it, either static or dynamic. The router divides the network into several broadcast domains. Each port in the router is a separate broadcast domain. The router divides the network also into several collision domains. Each port in the router is a separate collision domain. The services that can be offered inside a LAN can be file sharing, database sharing, or application sharing. This is a form of software resources centralization that can be offered through a LAN. A LAN can share files, databases, and any applications among the users of the LAN. Applications can be games that can be played by the users existing on this LAN. Also, the LAN can share several hardware peripherals, like the printer, the scanner. Even the processor of a certain machine can be shared to another machine to use. Even the storage inside the LAN can be shared through a storage server that every other machine can access as a client. The WAN services differ from the LAN services. The WAN services can be web service, which can allow for web browsing, web searching, or accessing the social media. The WAN services can offer email services that can be exchanged among the users over a WAN. And let's recall here that the Internet is a WAN, is the largest WAN over the Internet. The Internet is the network of networks. It's comprising all the LANs in the world. The Internet is a very big, wide area network. The Internet offers the service of file transfer through sharing or file transfer protocols. The Internet can offer voice calls and can offer video conferencing. Also, any small WAN connecting two LANs can offer the same services, voice calls and video conferencing among the users existing on this network. Now we have explored the devices, the services of a computer network. Thank you. Now it's time to know more about the transmission media that are used in computer networks. The media can be wired media using cables or wireless media using air. The network, a single network as you can see in this image, can be composed of a wired part and a wireless part, both of them in the same network and connected to each other. The wired media uses cables either made of copper or made of fiber optic. Copper cables can be coaxial or twisted pair cables. The twisted pair cables themselves can be shielded or unshielded. Shielded twisted pair STP or unshielded twisted pair UTP cables. The fiber optic cables can use the light signals in single mode, such as the laser mode, or in multi-mode. The wireless media once more uses the air interface to transmit and receive signals. The coaxial cables, as you can see in the image, is composed of several parts that is ended with an outer jacket. It's high capacity cables used for video transfer. There are two types of coaxial cables: thick coaxial cables or thick net and thin coaxial cables or thin net. The thick ones are half-inch diameter and their code is 10 base 5, which means, for example, the speed is 10 megabit per second and the maximum distance that can be covered is 500 meters. The thin coaxial cable code is 10 base 2, which means the speed is 10 megabit per second and the maximum distance covered is 200 meters. The diameter of the thin coaxial cable is quarter inch, while the diameter of the thick coaxial cable is half inch. Both cables use the B and C connectors. The shielded twisted pair STP cables are protected through this shield against the electromagnetic interference with other electrical signals. The STP cables are hard to install due to the existence of this shielding. STP cables use the registration jack RJ45, which is in the middle of this image. The crimper tool used on the bottom left is used to connect such cables to the registration jack by pressing on the cable to enter inside this registration jack and be connected to the networks afterwards. The UTP cables, or the unshielded twisted pair cables, are the most commonly used types. They are easy to install, less expensive due to the absence of shielding, but they are susceptible to electromagnetic interference with other electrical signals, also due to the absence of shielding. UTP uses the registration jack 45 connector, RJ45, and uses the same crimper tool to connect the registration jack to the cables. The twisting of the UTP cable determines its capacity. For example, in this image, cable A has less twisting than cable B. This makes cable A of less capacity than cable B. Cable A is Cat3 UTP cable, while cable B is Cat5 UTP cable, and both are made of the same material, only differs in the number of twists per meter. Cable A can hold up to 10 megabit per second. Meanwhile, cable B can hold up to 100 megabit per second due to the extra number of twisting for this type of cable. The categories of UTP cables are in this table. Cat1, or category 1, is for voice only, telephone wires. Cat5 speed reaches up to 100 megabit per second, which is the fast Ethernet. Cat5e reaches up to 1 gigabit per second. Category 6 ranges from 1 gigabit to 10 gigabit per second, which is the gigabit Ethernet. The pins, the terminals of the UTP cables, are in the colors shown in the image at the right: brown, orange, white, blue, white, orange, green, white, green. They range from 1 to 8 from bottom to top. Terminal number 1 and terminal number 2, as shown on the image on the left, are used for transmission. Terminal number 3 and terminal number 6 are used for receiving. This is the standard of the UTP cable. The fiber optic cables transmit light, not electricity. It's faster than the twisted pair and the coaxial, and faster than the copper cables in general. It sends data as light pulses over glass medium. It is free of electromagnetic interference since the pulses are light, not electricity. It's expensive and it is hard to install. This type of cables can be used in the submarine connections, connecting continents to each other and countries to each other over the internet. Fiber optic cables are more secure. They are less susceptible to sniffing over such type of cables. The fiber optic cables are composed of core carriers for the signals. This core is made of plastic or glass. Cladding surrounding the core maintains the signal in the center of the core, even if the cable bends. Sheathing that is surrounding the cladding protects the cladding and the core both through the outer jacket also. The fiber optic cables modes are the single mode or multi-mode. Single mode transfer data through the core using a single light ray. The core diameter is around 9 microns. Supports a large amount of data, larger than the multi-mode cable. The cable length can extend a greater distance than the multi-mode. The multi-mode cable transfers the data through the core using multiple light rays. The core diameter is about 50 microns. The cable length is limited in distance compared to single mode, which means that the single mode cable is a more recent technology and a more expensive technology than the multi-mode. The advantages of the fiber optic cable is it is totally immune to the EMI, electromagnetic interference, highly resistant to sniffing or eavesdropping, support extremely high data transfer rate. This makes it suitable for submarine cables. It allows greater cable distance without the need to repeaters. The disadvantages: it is very expensive. It is very difficult to work with and needs very talented technicians to deal with. Let's talk about the wireless media using the air interface. The Wi-Fi, which is the abbreviation of the wireless fidelity. It uses the frequencies of 2.4 GHz or 5 GHz. The standards of the Wi-Fi are A, B, G, or N. The Wi-Fi uses the access point previously demonstrated in this course to connect the devices wirelessly and to connect the wireless part of the network to the wired part. When you go wireless, you gain more mobility. You gain more flexibility for the devices connected wirelessly. But you lose security. Wireless networks are less secure than the wired networks. They are susceptible to sniffing, since the media used is merely the air, which is exposed to all the users of the network. By this, we have demonstrated the computer networks transmission media. Thank you. Welcome to the second section of our course, the section addressing the ISO OSI model, the very famous 7 layers. This section is demonstrating these 7 layers and their functionalities. The ISO OSI model, as we can see, is an output of the ISO, International Standardization Organization. This output is named the OSI model, Open System Interconnection Model. It's a primary architectural model for networks. It was developed in 1983. It's only a group of concepts. This means that the model does not specify a certain hardware or software to exist. It is a group of concepts. It's a conceptual model that specifies the functionalities that are needed to be done to transmit data from a certain source to a certain destination over the internet. It specifies how data can be sent or received either hop to hop, which means either from the machine to the switch to the router and so forth, step by step, or sending and receiving data end to end, which means sending and receiving data between a source that is in Malaysia and a destination that is in Egypt, which means that both are trying to send correct data, reliable data from a certain source on the internet to a certain destination over the internet worldwide. The benefits of dividing this model into layers are a lot. Dividing the network communication process into layers allows for easier troubleshooting, allows for easier design, and easier specification for each layer to be set inside this model. It allows for multiple vendors to build their products, either software or hardware products, based on the same standard model that is called the OSI. Many vendors, giant companies, can establish hardware components or software components based on this ISO OSI model, and these components can interact and can send and receive data to each other since they are based on the same model, the OSI model, the Open System Interconnection Model, designed by the ISO, International Standardization Organization. Various types of networks with various types of hardware and software can communicate, which means, for example, that Windows machines can communicate with Linux machines. IBM machines can communicate with Apple machines. Machines on copper cables can communicate with machines on fiber optic cables. All of these, since based on the same model, can communicate with each other and can send and transmit data with each other built on the same standard model, that is the OSI model developed by the ISO. The layer separation makes it easier to change the design of one layer without affecting the other layers, without affecting the upper or the lower layer. The design, the functionality of each layer can be made better, can be changed without affecting the 7 layers as a whole. We just take into consideration what each layer can take from the upper and deliver to the lower when changing the design of this layer. Layers interact with each other. While sending, each layer passes the data downwards from the 7th to the 1st. While receiving, data is passed upwards from the 1st to the 7th. And the headers of each layer is added while you are sending, and it is removed while you are receiving. This is the interaction with the layers that allows and that gives us at the end better communication between hosts and destinations over the internet. This is the diagram showing the 7 layers. We should know by heart these names, and we should know by heart that we are counting from bottom to up. The first layer is the physical. It's always layer number 1. The second is the data link. The third is the network. The fourth is the transport. The fifth is the session. The sixth is the presentation, and the seventh is the application layer. We always count from down to up. Each layer is summarized in one sentence in this slide. The application is responsible for communication between the application itself as a software and the network processes lying in the layers down. The presentation is responsible of data representation. The session is responsible for managing the session in the inter-host communication process, starting, ending, and managing the session while communication. The transport is responsible of end-to-end connections, either reliable or best effort delivery. The network is responsible for addressing and routing, finding the best path for the data to go through based on the address of each machine. The data link is responsible for accessing the media and avoiding collisions. The physical is responsible for the binary transmission of ones and zeros, representing the data in electrical form or in light form if we are going to use the fiber optic cables. Network protocols that were based upon the ISO OSI model are a lot, but we are here focusing on 4 protocols that were used and were common and were extensively known to be protocols based on the ISO OSI model. The NET-BEWI protocol, the IPX-SPX protocol, the AppleTalk protocol, and we end by the TCP/IP protocol, the standard protocol of the internet that will be addressed the next section in details. The NET-BEWI protocol, NET-BEWI stands for Net BIOS Extended User Interface. It was a LAN protocol that work only over LAN and do not work over wide area networks. It has limited performance, not a good performance, and it's now almost obsolete protocol. It does not exist a lot or not common to be existing over the world. But this was a LAN protocol based on the ISO OSI model. The second protocol is the IPX-SPX that was vendor-oriented, that was designed by one of the companies working in hardware and software. It was standard based on the ISO OSI, and it supported transmission of data over WAN. But it also had a disadvantage, a drawback, that it was oriented too much towards its vendor. It had poor performance if used with other vendors. If you use this protocol with another vendor, not with the vendor that made this protocol and designed it, you will have a very poor performance on your network and your machines. AppleTalk is a standard protocol based on the ISO OSI. It supports WAN and it supports data transmission over routers, but it is very oriented towards its vendor, and it also has the same drawback and the same disadvantage of poor performance if used with other vendors. It worked greatly with the same vendor that made this protocol and made the machines using it, but it had a very poor performance if you changed the machines to be made with other vendor using this protocol. The TCP IP. The word TCP IP stands for Transmission Control Protocol Internet Protocol. It's a standard protocol. It supports WAN and supports to be transmitting data over routers. It is not vendor oriented, and this is a very big advantage in TCP IP that makes it growing and developed and always the standard protocol for transmission over the internet. Nowadays, the TCP IP is the most widely used protocol over the internet. The TCP IP is completely and entirely mapped to the OSI layers. The OSI 7 layers are completely mapped to the TCP IP protocols, as you can see in this diagram. It is not a one-to-one mapping. It's a group-to-one mapping between the OSI layers and the TCP IP protocol. Now we had a good idea about the ISO OSI model in this lecture. Thank you. This lecture covers the top 3 layers of the ISO OSI model: the application, the presentation, and the session layers. Layer 7, Layer 6, and Layer 5. The application layer. It is the interface between the user, the human user, and the rest of the 7 layers. It's an interface between the user and the lower layers of the ISO OSI model that translates and tries to make it easier for the lower layers to execute the orders and the requirements given by the user to the network. The application layer is responsible for the preparation of data for each service. Each service on the internet requires data to be prepared in a certain format, to appear in a certain way. For example, the web browser lets the data appear in the form of text, images, and hyperlinks. Another service, like the file transfer service, the FTP, requires data to appear in the form of solid files. Another service, like the email service, requires data to appear in the form of messages. The preparation of data for each of these services is responsibility of the application layer. The application layer is the goal of the 7 layers: to perform end-to-end communication on both sides between the application layer at the sender and the application layer at the receiver. This is the logical connection that needs to be established between the sender and the receiver, as if the application layer here is talking directly to the application layer there, as if there were no other layers interfering. The end-to-end communication on both sides of the sender and the receiver is the goal of the 7 layers. Providing end-to-end communication between the application layer here and the application layer there is the reason for the existence of these 7 layers. The application layer, the 7th layer in the ISO OSI model, is the layer where the software application resides, where the program you are dealing with as a user exists and takes from you the data that needs to be sent over the network and passes to the lower 6 layers, starting from presentation and ending to the physical. The application layer is the actual layer that sends the requests at the sending process, and the actual layer that receives the reply at the receiving process. It's the layer that takes the request from the user, passes to the lower layers, and receives the reply arriving from the lower layers and presenting it to the user in a readable and understandable form. Example protocols that work at the application layer are the following. HTTP, Hypertext Transfer Protocol. This is for web services. FTP, File Transfer Protocol. This is for transferring files between sources and destinations over the net. SMTP, the Simple Mail Transfer Protocol. This is for the mail exchange over the internet. POP3 is the Post Office Protocol. SMTP is for exchanging email messages among the mail servers. POP3 is for exchanging email between the client and the mail server. IMAP is Instant Message Access Protocol, is also for exchanging email messages between the client and the mail server. POP3 allows for downloading email messages. IMAP is only for accessing and reading email messages. Telnet and SSH protocols are for allowing for remote administration between a client that exists in a certain machine over the internet and a server that exists maybe 2 or 3 countries away on the internet, and the user sitting on the client software acts as if sitting on the keyboard and the mouse connected directly to the server machine and can do whatever he likes on the server machine through this telnet application. The domain name system, or the domain name server, the DNS, is the protocol responsible for resolving the domain names into IP addresses and vice versa. It's the protocol that allows for writing www.yahoo.com and then connecting to a certain machine with the IP address corresponding to this domain name server. The RTP protocol, the real-time protocol, is responsible for transferring data that are real-time data, such as the audio and the video. Real-time transfer of data has certain requirements for certain data that are delay sensitive and not sensitive to losses in the same way that they are sensitive to delay. So the real-time protocol, which is somehow a new protocol, is responsible for transferring data of such kind. The presentation layer, or layer number 6, is responsible for the common representation of data between any source and any destination. It is responsible of presenting the data to the application when receiving, and receiving the data from the application when sending, in a certain form that can be understandable by both the source and the destination. It provides the transformation of data. It supports a standardized application interface at the source side and at the destination side. It is responsible of coding the data syntax. It's responsible of coding the data according to a certain syntax that is understandable by both the source and the destination. It is responsible for the encryption at the sender side and the decryption at the receiver side of the data being transmitted. It is responsible of the compression at the sender side and the decompression at the receiver side of the data being transmitted between the source and the destination. The session layer, or layer number 5, is all about managing the session, starting by establishing the session in itself, managing the session while it is running and up, controlling the session while it is transferring data, and at the end of the session it is responsible of how the session can be terminated safely. If we look at this diagram, we can see that the session layer sends some data that is like some data or like some sentences we use between each others as human to start conversation. If you say to someone, I'd like to send you something, and he says, sounds good, this is a request that is replied by an acknowledgement. This is an establishing to a connection. These two messages are the responsibility of the session layer to transmit and to acknowledge at the beginning of the session. At the end of the session, when you send your data completely and entirely, you say to the receiver, thank you, and he acknowledges you by the sentence, you are welcome. This is closing the session safely and closing the connection safely. Of course, in between these two messages, in between these two diagrams, the session can be stopped and can be restarted and can be resumed at a certain point of time. The flow of data can be controlled and can be slowed down and can be set to a faster speed. All of these functionalities are the responsibility of the session layer. It is responsible of managing the session as a whole, from the establishment by some handshaking between the sender and the receiver till the termination by some handshaking and acknowledgement between the same sender and the receiver, and through controlling the session in between while the data is being transferred between the sender and the receiver of the data. The session layer makes sure the connection is active during the session and makes sure that it is not falling down. It is responsible of securing the connection. It is responsible of the synchronization of the dialogue, the synchronization of the sending and the receiving of data. It is responsible of checking for the connection failure if existing during the session, which leads to losing data and which leads to slowing down the data transfer process. It's responsible for reconnection if there is a cutoff during the sending of the data or during the data transmission. Reconnection or resuming the session is the responsibility of the session layer. It's responsible of terminating the communication at the end of the session after all the data has been received by the receiver. The session layer defines the node communication order and timing. Order and timing are the core of the synchronization of the data sending. This is the responsibility of the session layer as well. The three layers, the application, the presentation, and the session, are very closely connected. They are very related in function to each other. That's why they form the application layer in the TCP/IP. If we have a look at the TCP/IP protocol suite, we can see that the application layer, the presentation layer, the session layer in the ISO OSI model are all compact and linked together in one layer in the TCP/IP that is called the application layer in the TCP/IP. This makes the TCP/IP only 4 layers, not 7 layers. Those 3 layers are responsible of content formatting, are responsible of formatting and representing and preparing the data being sent from the sender to the receiver. It's preparing for the network process, preparing for addressing, preparing for routing, and preparing for establishing the connection for the data to be transmitted through the network layers that lies down, starting from layer 4 until the physical layer in the ISO OSI model. By this, we have introduced those important 3 layers. Thank you. This lecture handles the transport and network layers. These are the 2 main layers that concern the network specialist, the network engineer. The transport layer, layer number 4. It organizes data into segments. The word segment is the unit of data at the transport layer, at layer number 4, where it is a packet at layer number 3 and a frame at layer number 2 and bits and bytes at the physical layer, layer number 1. The transport layer is responsible for the end-to-end delivery in either reliable form or just best effort delivery. When we try to explain the word reliable, we refer to loss recovery, which means that data transmitted arrives at the receiver side with no losses. We also refer to the flow control, the adjustment of the flow between the sender and the receiver according to the network conditions and according to the requirements of data. We refer also to data ordering. Sometimes data arrive at the receiver side out of order, arrive data number 2 before data number 1. Data number 1 is late due to taking a congested path over the network. That's why data number 2 arrived earlier. I mean the piece of data. This piece of data number 2 needs to be reordered in a reassembly process to be put in the right place after data number 1. One of the responsibilities of the transport layer is the data deduplication. Sometimes data is sent twice and received twice, the same piece of data. So we need a form or an identifier that says that this data is a duplicate. This data is another copy of a certain data that has been received. So we need a deduplication process to eliminate the extra copy. Once more, you either send and receive in a reliable communication or in best effort delivery. It's the two modes where the transport layer works. The functionalities of the transport layer are: number 1, the segmentation. The segmentation means dividing data into small fragments called segments that can be transmitted over the network. Different networks have different maximum transmission unit, different MTU. The MTU defines the maximum size of one data piece carried through the network. This is the definition of the MTU. Data is being divided and transmitted to the recipient via the transport layer. The MTU size is agreed upon between the sender and the receiver while establishing the connection and during the routine discovery. The MTU size is one of the parameters of the network that must be agreed upon between the sender, the receiver, and the communication devices. The second functionality of the transport layer is the reassembly. Reassembly means assembling the pieces of data arriving at the receiver side to the same form or the same initial form that has been sent from the sender. This reassembly is done at the receiving end. The transport layer protocols reconstruct data into its initial form. Data can be received in different order, different than the form that has been sending it. So it is the responsibility of the transport layer to rearrange those pieces of data into the correct order, the original order, the order by which it has been sent. The third functionality of the transport layer is sequencing, using the sequencing identifier or sequencing number. To avoid the loss and avoid the duplication, each piece of data is noted by a sequence number or sequence identifier. This sequencing fixes the issue of following data different paths, so you know from the sequencing identifier the correct sequence of data. This sequencing helps in organizing data in groups of subdivided data segments and in identifying the order of groups of data sending and interpretation. The communication in the transport layer is either connection-oriented. This type of communication that is called connection-oriented is reliable and more secure. It is based upon establishing two-way connection between the nodes, I mean the sending and the receiving nodes, before data transmission. For example, when a browser is trying to open a web page, the transport layer would send synchronization packet to the web server from the browser. The browser then expects synchronization acknowledgement response. When it receives this response from the server, it sends its own response to the server back. After this process is done, the data can be transmitted. We can here see that no data has been transmitted before the connection establishment is complete. The transport layer can establish a connection in another mode that is called connection-less oriented. This is a non-reliable connection. This connection depends on the best effort delivery between the sender and the receiver. No connection establishment prior to data transmission. It is less in security because it does not guarantee the loss recovery or the reordering of the data if received out of order. It allows sometimes for data flooding, for sending big chunks of data over the network, causing it to flood, to be saturated with unwanted traffic. But this type of connectionless oriented communication is essential in some types of communication where data is real time, data is delay sensitive, such as the audio data in the audio calls or the video data in the video streaming sessions. Now let's move to the third layer, layer number 3, the network layer. Remember that we count layers from down to up. This layer organizes data into packets. Now remember that data in the fourth layer is called segment, and here it is called packets. Responsible, this layer, of end-to-end addressing and routing. And let's know by heart these two words, addressing and routing. These are the main functions of the network layer. The network layer identifies unique logical address for each machine over the network. The address is unique. The address cannot be repeated. The address is logical and related to the geographical location of the machine. It is not a physical address. It's something logical that can be changed according to the change of the geographical location of the machine. This network layer selects the best path for destination. This is what we call the routing process. Routers, the devices that are called routers, work in this network layer, reads and understands data up to this third layer, layer 3, the network layer. This layer performs fragmentation. If segmentation was not enough to divide the data to be suitable for sending and receiving, we add another process, that is fragmentation, to the data to divide data into smaller chunks. Network layer at the receiver side receives the segments of data from the transport layer, converts segments into packets by adding the addressing information, the sources, the destination, and then finds route for data to be delivered to the receiver. Routes that are designed to any group of data may differ because it is being determined based on the following. It is either the least network overloaded route, or the best route from the point of view of the quality of service, or it is the least route in cost, or according to some delivery priorities, which means that the data has a priority more than other data, so it should take a path that is faster than other data would take. These are the most common criteria for route definition. When we say that the network layer is responsible for identifying logical address, we must give some details about the logical address. It's a unique identifier. It is bound to geographical location of the machine. It is used for end-to-end routing, since bound to the geographical location. It can be changed according to the change of the geographical location of the machine. It is not vendor-oriented, as we will see in the next lectures that the physical address is vendor-oriented. The common example for this type of address is the IP address in the TCP IP protocol suite. Let's sum up both layers, the network and transport layer. The network layer identifies the source machine and the destination machine in any session, while the transport layer guarantees either end-to-end reliable delivery or end-to-end best ever delivery for data across the same machines. These are the main functions of the network and transport layers in the ISO OSI 7 layers. Thank you. Now let's talk about the lowest two layers, the data link layer, layer number 2, and the physical layer, layer number 1. They are important layers as well as the third and the fourth for the network specialists and engineers. The data link layer, layer number 2, it's a reliable layer for the data transfer across the physical link. It is responsible for the reliability on the level of hop-to-hop transfer. Across the physical link means that it is responsible for the reliability of data transfer from the machine to the switch, and from the switch to the router, and from the router to the next router across the LAN domain. It is responsible of physical addressing. Physical addressing is different than logical addressing. The physical address is not bounded to geographical location and cannot be changed. The logical address is bound to the geographical location and can be changed according to the geographical location of the machine or of the network interface card inside this machine. But remember that both addresses are unique and cannot be repeated. The data link layer organizes the data into frames. The frame is the data unit at this layer, at the data link layer. At layer 2 we call data frames, at layer 3 we call data packets, and at layer 4 we call data segments, and at layer 1 we will call data bits or bytes. The data link layer puts the frames onto the physical medium, checks for frames errors, and this checking does not include correction. It is just error detection only. It is responsible for hop-to-hop addressing on the range of LAN domain, addressing with the physical address. The physical address is a unique identifier that cannot be repeated. It is not logical, it is not bound to the geographical location. It is only used for hop-to-hop addressing to identify the machine on the LAN domain. The physical address is burned on the network interface card and it cannot be changed. It is vendor-oriented. Every specific port of the physical address tells that this network interface card belongs to this vendor, which means network interface card from a certain vendor should have a physical address that is related to this vendor. A very common example of the physical address is the MAC address, the medium access control address. Sometimes the physical address is called the hardware address. The data link layer receives data packages from the network layer when sending and convert this data into frames including the following: the data itself, the data package, the sender and the receiver physical addresses, error checking and control information, a field that helps for error checking for this frame. Checking and control ensures the frame has been delivered without troubles. This is the functionality of such field for error checking and control. If part of the frame is lost during transmission, then the data link layer protocols of the receiver would see that. Data link layer at the receiver request data retransmit from the sender. As you can see, this is just a retransmission request, not a correction action that can correct the data that is corrupted at the frame. It is just a retransmission for the corrupted frame or for the frame that contains wrong information. The switches and the bridges are devices that work in the data link layer, work in both layers, physical and data link. Switch and bridge work in layer 2. The frame check sequence, FCS, is the error checking mechanism that is created at the data link layer. The FCS is a number based on the values of all the preceding fields in the frame. The receiver receives data with the FCS value. The receiver compares the FCS to the data field in the frame to check if this FCS is consistent with the data or not. If in an unlucky scenario of failed comparison, the following is done. If this FCS is saying that the data is not consistent with the field of FCS, the data is assumed to be corrupted. Then the receiver requests data resending from the sender. The FCS is also beneficial if the comparison is successful. The receiver sends a message of successful data transmission back to the sender. If the receiver did not receive the success message during specific period of time, automatically the sender resends the data frames. The data link layer is divided into two sublayers, the LLC, which is the logical link control layer, and the MAC layer, the medium access control layer. Another function of data link layer is it controls the flow when many different nodes are sending data at the same time. This is the layer where collision is detected and avoided. This is the layer where the SYSMA CD and the SYSMA CA, if you remember, collision, carrier sense multiple access, collision detection, or carrier sense multiple access, collision avoidance take place and are implemented. The data link layer has been divided into two sublayers by the IEEE, which are the logical link control, the LLC, and the medium access control. The LLC is responsible for the hop-to-hop reliability and hop-to-hop flow control. Reliability means that the data must reach each destination with no errors, and the flow control is the synchronization between the speeds of the sender and the speed of the receiver. The MAC layer adds the physical addresses to the frames of the sender and of the receiver. It is responsible of communication with the physical layer. Let's talk about the physical layer. The physical layer transmits bit streams over the physical link. Data at the physical layer are either bits or bytes. It sends data signals to media and receives it. The physical connection that really exists among the 7 layers is between the two physical layers of the sender and of the receiver. Other links that exist between the data link here and there are just logical links. The physical layer adapts to the transmission media. Either it is cables or wireless media. Either it is copper or fiber optic. Either it is coaxial or twisted pair if copper, or single mode or multi-mode if fiber optic. It is responsible for the representation of the ones and zeros, responsible for the digital representation. Is it plus 5 volt or plus 3 volt or plus 0 volt? The voltage and the electrical representation is the responsibility of the physical layer. Devices that work in the physical layer are the NIC, the network interface card, the hub, the repeater. All of these are devices that work in the physical layer only. As we can see, here are two stacks of 7 layers for the sender and for the receiver. We can imagine a logical link between the application layer here and the application layer there. But the physical link that really exists and that is not imaginary inside this diagram is really between the physical link at the sender side and the physical link at the receiver side. It is either through optical fiber or copper wire or electromagnetic waves in the wireless media that transmits a stream of bits and bytes from the physical layer here to the physical layer there to represent the data of zeros and ones being sent from the sender to the receiver. By this we come to the end of the data link layer and physical layer explanation. Thank you. Now let's summarize the OSI model in action and have some review questions for section 1 and section 2 of this course. The OSI model is a conceptual model. It's a group of concepts that characterizes and standardizes the communication functions of a telecommunication or computing system. The OSI model is just concepts. You can build upon these concepts any hardware or software system that can communicate with each other. This conceptual model is regardless of underlying internal structure and technology. The goal of this model is to provide interoperability of diverse communication systems with standard protocols, which means Windows systems can communicate with Linux systems. Any vendor can manufacture or implement a hardware or software system that communicate with another hardware or software system implemented by another vendor, since they are using the same protocol. This is the only condition or criteria, that they must use the same communication protocol. The OSI model partitions a communication system into abstraction layers. The functionality of each layer is contained into itself. The functionality of each layer is done through interoperability with the upper layer and the lower layer as well. The original version of the model defined 7 layers. It's very important to know these layers: application, presentation, session, transport, network, data link, and physical layers. Each layer serves the layer above, and it is served by the layer below it. Or vice versa, each layer can be served by the above and serve the lower layer. It depends whether you are sending or receiving data. When sending data, the data is going downwards. When receiving data, the data is going upwards through the 7 layers. Remember always that layer 1 is at the bottom and layer 7 is at the top. A layer that provides error-free communications across a network provides the path needed by applications above it. This is an example. This layer calls the next layer, which means the lower layer, to it after providing the path to send and receive packets that compromise the contents of that path. From where did it get that path? From the above layer. So this lower layer got the path from the above layer, and then it does the functionality of sending. Two instances at the same layer are visualized as connected by a horizontal connection in that layer. Remember that the only physical connection is between the two physical layers only, and there is a logical layer that is between the application layer here and the application layer there. The application layer here at the sending side and the application layer there at the receiving side. There is a logical connection. Also between the presentation and the presentation, the session and the session, the network, the data link, and each of the 7 layers is connected virtually, but one of them is connected physically, which is the physical layer here and the physical layer there. Let's have a look at this diagram. This is an important diagram. Let's look at sending at the left side. The layer 7, L7, sends data. This data is added to the header H6 at layer 6. Now see that both L7 and H6 are considered as L6 data, where at the layer 5 H5 is added. And now see the same thing happens one time again. L6 plus H5 are both considered as L5 data, where at the transport layer H4 is added. H6, H5, H4 are all headers added by layer 6, layer 5 and layer 4 consequently. Both L5 and H4 are considered as L4 data, where H3 is added. Now the only layer that adds header and trailer, which means that is something before the data, and header that is something after the data. The only layer that adds header and trailer is the data link layer. And the physical layer considers all the data as zeros and ones. Then it is passed to the transmission medium. You can see at the right side that the reverse thing is happening. It's vice versa. It's the reverse action of things that happened at the left layer. You can see that each layer added, each header or trailer added by a layer at the left side is read and removed by the same layer, by the corresponding layer at the right side. So H2, T2 are read and removed by the data link layer at the receiving side. H3 is read and removed by the network layer at the receiving side. So at the receiving side, at layer 7 of the receiving side, you can only see L7 data that was originally sent by the application layer at the sending side. That's why we say that there is a logical communication between the application at the sending side and the application at the receiving side, because they are sending the same data and receiving the same data that has been sent. Let's summarize and say that the Open System Interconnection, the OSI model, defines a networking framework to implement protocols in the 7 layers. Now let's have some review questions about section 1 and section 2. The first question says, the computer network is composed of computers, dots and dots connected through transmission media. What are the other components of computer network? Peripherals. Remember, peripherals, any hardware piece that can be connected to a computer. Connecting devices. This is the other component of a computer network. So the complete sentence would be, the computer network is composed of computers, peripherals, and connecting devices connected through transmission media. The second question, transmission media can either be made of or it can be using the as a transmission media. Transmission media can either be wired, made of copper or fiber optic as materials, or it can be wireless using the air as a transmission medium or as a media of transmission. This would be the complete sentence. The most commonly used network topology nowadays is the star topology, where the computers are connected to a central device, which is the switch. Of course, it can be a hub, but we are talking here about the most commonly used. And here I've chosen it to be the switch to let you be familiar with the most commonly used device. Based on the covered geographical area, the network can either be A or A. It can either be a LAN or a WAN, of course. While according to the transmission type, it can either be peer-to-peer or client-server network. Now let's move to section 2. The most commonly used types of copper cables is the twisted pair, which is divided into STP, which means shielded twisted pair, and UTP, which means unshielded twisted pair cables, according to the type of shielding. The advantages of fiber optic cables over copper cables are that it is faster and can afford higher capacity and more immune to EMI, electromagnetic interference, and more secure than the copper cables, of course, since it is not susceptible to sniffing. The term OSI stands for Open System Interconnection. The most commonly used protocol over the internet is the TCP IP protocol. Among the protocols that work in the application layer are the HTTP, FTP, DNS, SMTP, and others, of course. The transport layer can work in either or modes of delivery, in either reliable or best effort modes of delivery. The main functionalities of the network layer are the addressing and routing functionalities. And of course, the routing is based on the addressing. Of course, the type of addressing at the network layer is the logical addressing. The network layer is responsible of what type of addressing? Very easy question, of course. Logical addressing. While the data link layer is responsible of what type of addressing? Physical addressing. Thank you. Welcome to the third section of our course. It's about the computer network protocols and the meaning of the word protocol in the world of computer networks. What is a protocol in the world of computer networks? It's a set of rules and agreements that governs the communication process, the process of sending and receiving. It includes these rules and agreements, the addressing, the routing, the session management, and the error recovery processes if needed. How to address the machines, how to route messages between the machines, how to start and stop any session between any two machines, how to recover the loss or the duplication of any data between two machines. The mail network, the post network, the courier network, the traditional mail network is an example of a network with a protocol. Imagine that you need to send a mail, a certain mail that is written on a paper and included inside an envelope. You should write on the face of the envelope the address of the man you are going to send the mail to. And you will also have to write on the back of the envelope the address of yourself. This is a protocol that dictates on you some rules and agreements on how to write the address, where to write the address, and on which piece would you write the address, which is the envelope here. The envelope here includes the headers of the data, and the message itself written in a paper inside the envelope is the data itself that needs to be sent between the sender and the receiver. The PSTN, the public switched telephone network, is another network that is running through a protocol. Every telephone has a unique number that is worldwide, not repeated, and that is worldwide connected to the geographical location of this telephone. The mobile phone network is a network that has also a protocol. Each mobile phone number is unique. Each mobile phone number has a route to another mobile phone number in the world. Each mobile phone number can start a session, end a session, stop and resume a session with any mobile phone network over the world. The layered model that appeared with the ISO OSI model has so many benefits in this subject, because this layered model allowed of separation of functions between the layers of the protocols. So a layer can be responsible of addressing, another layer can be responsible of the error recovery, another layer can be responsible of the session management. This is the session layer, this is the transport layer, this is the network layer. Another layer is responsible for the network access, which is called the data link layer. Every layer in the 7 layers has its own responsibility and is served by the upper and the lower layers to it to act as a sender and receiver for data according to the process being done. The most well-known computer network protocols that appeared over history was the NetBEWI, IPX, SPX, AppleTalk, and the well-known and very famous standard protocol TCP/IP. The TCP/IP is the standard protocol over Internet. TCP/IP stands for Transmission Control Protocol Internet Protocol. It's compatible with the ISO OSI model. It provides interoperability between different hardware and software systems. Since it is standard, since it is compatible with the ISO OSI model, it can be implemented by any of the hardware or software manufacturers over the world. It's open for development. It is not owned by a certain vendor, so it is open for development by researchers over the world. It provides reliability. It provides some sort of connection orientation. It provides some sort of error recovery and reliability in data transfer, as well as best effort delivery if this is the feature that is needed. And sometimes we need the best effort delivery feature when we are caring about the speed more than the reliability of the communication. This is very obvious in the real-time data, in the audio and video data. It is composed of a number of protocols. That's why we call it the TCP/IP protocol suite. It is composed of a number of protocols in the application layer, in the transport layer, in the network layer that are built over each other to form the TCP/IP protocol suite. It offers web browsing, file transfer, and email exchange. This means that it offers the most famous and the most demanded and the most wanted services over the internet. TCP/IP has produced version 4 and has produced version 6, and both are running. Version 4 is more common, version 6 is the next version, and it is the current version in some countries over the world for communication over the internet. This is the TCP/IP protocol suite. Let's have a look. Let's have a look at the upper layer that is composed of HTTP, FTP, Telnet, SMTP, DNS, TFTP, RPC, SNMP. These are all protocols in the application layer, in layer 7 of the ISO OSI, or let's say that it is in layer 7 and 6 and 5 in the ISO OSI model, and it is in the upper layer in the TCP/IP. The transport layer, which is the layer 4 in the ISO OSI model, includes here in TCP/IP 2 protocols. One of them is reliable, that is the TCP protocol. The other is unreliable, which is the UDP protocol. The network layer, the third layer in the ISO OSI model, is translated here into one layer that is called also the network layer, including the IP protocol as the main protocol and other protocols such as the ICMP, the ARP, the RARP, and the dynamic routing protocols. Here, this layer is responsible for addressing and routing. The lower two layers, the data link and the physical layer, includes some of the protocols responsible for accessing the network, for data representation and the functionality of the physical and data link layer, such as the Ethernet, the token ring, the FDDI, the ATM. ATM here means asynchronous transfer mode, and ISDN, other protocols that are responsible of transferring data, representing ones and zeros, accessing the media, avoiding collisions, and such functionalities of the data link and physical layer of the ISO OSI model. Let's here have a look more in depth about the mapping between the TCP IP and the ISO OSI model. The TCP IP is 7 layers, we all know this, but the TCP IP model is only 4 layers. You can see that the upper 3 layers has been merged together to form the application layer in the TCP IP. The transport is still the transport. The network has been translated as it is with the name internet and sometimes called the transport as well. The lower 2 layers are the data link and physical and are called the network access layer in this TCP IP. So let's say this again. This mapping between the ISO OSI and the TCP IP has done through merging of some layers to be 4 in the TCP IP model instead of 7 in the ISO OSI model. This has done through merging the physical and data link, keeping both the network and transport layer, merging the upper 3 layers into one layer called the application layer. The TCP IP is now the default protocol that is implemented inside any Microsoft Linux or any other operating system that needs to be standard, that needs to connect machines over the internet. TCP IP is now standard, is now built inside Microsoft operating systems, Linux operating systems, and other operating systems that are produced on machines needs to connect over internet. Let's now have a look at the mapping between TCP IP, the ISO OSI. 3 layers has become 1 layer. Application, presentation, session has become the application. And example protocols that are running in the application layer of the TCP IP are the HTTP, Telnet, FTP, SMTP, DNS, RIP, which means Routing Information Protocol, SNMP, which is Simple Network Management Protocol, DNS, the Domain Name System or Server, SMTP, Simple Mail Transfer Protocol, FTP, File Transfer Protocol, and Telnet is used for remote administration. The transport layer is mapped in the TCP IP into host-to-host transport layer. This is mapped into either TCP in the reliable communications or UDP in the unreliable communications. The network layer is mapped to the internet layer. The IP layer is the main layer, that is the main protocol or the main layer working in the network layer. Upper to it we can find ICMP, Internet Control Messaging Protocol, or IGMP, Internet Group Management Protocol, and the ARP, which is the Address Resolution Protocol, which is responsible between the resolution between the 2 types of addresses, the MAC address, the IP address, the physical address, and the logical address, as we will see later. The data link and physical layers are mapped here into one layer that is called network interface layer and is implemented in several protocols in the TCP IP, such as the Ethernet, which is the most commonly used over today's networks, the token ring, the frame relay networks, and the ATM. This is the core of the TCP IP. This is the main mapping between the ISO OSI model and the TCP IP protocol. Thank you. Now it's time to talk about the IP protocol, the network layer protocol in the TCP IP protocol suite. The IP protocol is the principal communication protocol in the TCP IP protocol suite. It's the protocol responsible for the 2 functionalities of the network layer, the addressing and the routing. It defines the addressing to label the datagram or the packet with source and destination addresses, source and destination logical addresses that are called the IP addresses. It relays the datagrams or packets across the network boundaries from the source to the destination depending on the route, which is established according to the source and the destination IP addresses. This routing function enables internetworking and essentially establishes the internet. Without routing, it's hard to imagine that there is internet here. This routing delivers packets solely based on the IP address in the packet header, solely based on the source and destination IP addresses that are added at the network layer in the form of a header to the data in this layer. The IP protocol structures packets and encapsulates the data with the source and destination IP addresses to be routed and delivered over the network. What is the IP address? The IP address is the logical address that is depending on the geographical location of the machine. It's unique. It cannot be repeated over the internet. Each single machine over the internet should have only one IP address that is unique. It's logical and not physical, which means that it can be changed according to the geographical location of the machine. The length of the IP address is 32 bits or 4 bytes or octets if you call it like this. It's version 4 of the IP address that is 32 bits. Version 6 of the IP address is 128 bits. Each byte or each octet ranges from 0 to 255. This means that each byte is representing 8 bits, and each byte can take the number from 0 to 255. The IP addresses are categorized into classes. We can see class A or class B or class C or class D or class E IP address. Each IP address identifies single machine, and each IP address, if added as a destination to a packet, is used for routing from the source of the packet to the destination by the routers. It is read and interpreted by the routers, which read layer 3 information. The classes of the IP address, and let's focus on the main 3 classes A, B, and C, has the ranges according to the number in the first byte, the first octet. If the number in the first byte ranges from 1 to 126, then it is class A. If it ranges from 128 to 191, then it is class B. If it ranges from 192 to 223, then it is class C IP address. According to this classification, there are possible numbers of hosts for each class. Class A supports up to 16,777,214 machines. Each Class B category can support to 65,534 machines. Each Class C can take 254 machines only. The public IP addresses that can be given to machines to exist over the internet. In Class A, it can be from 1.000 to 9.2555 and 2.255.255. It is read like this: 1.0.0.0 to 9.255.255.255. Then we skip the number 10 and move to the number 11 to the number 126. Note here that from class A to class B we have skipped the number 127, and class B ranges from 128 to 172, and the range inside 172 is also have some numbers skipped. You cannot see 172.16, for example, 172.15, then 172.32 till 191.255. Then we start from 192.0.0.0 to 192.167. Then we skip 192.168 and start again from 192.169 to 223.255.255.255, and here ends the class C, where starting from 224 starts the class D, and the class D is for the multicasting addressing. The private IP addresses that cannot exist over the internet as real IP addresses, as public IP addresses, and can exist only inside local area networks are these ranges. In class A, every IP address starting with the number 10. In class B, it's every IP address having from 172.16 till 172.31. In class C, it's any IP address starting with 192.168 to 192.168.255. Any IP address starting with 192.168. These are the ranges of private IP addresses that can be given to machines inside a LAN and then connected to the internet through some technology that is called the network address translation or netting, to give many machines having such IP addresses, such private IP addresses, one real IP address to be contacted through over the internet. This is to save the IP version 4 addresses that has become scarce resource over the internet and allow for more security during the communication with the machines having private IP addresses over the internet. There are some reserved IP addresses. You can note now that the IP address is divided into two parts. The left part defines the network. The right part defines the host. So if the network address is a specific number and all the host address is zeros, then this is the network address itself. And this IP address cannot be given to a single machine. It defines the network itself. It's an entry inside the routing table that we are going to talk about lately. The broadcast addresses is composed of network address that is specific, and the host is composed of all ones. This is used for broadcasting and cannot be also given to a specific machine. It is reserved for broadcasting. So if we see an IP address that has the network address with a specific number and all the host address zeros, then it is a network address. Or if all the host address is ones, then it is a broadcast address and cannot be given to a single machine. Devices working on layer 3, devices working on the IP layer are the router and layer 3 switch. The router and layer 3 switch are the devices that redirects packets between networks. They forward packets based on the destination IP address and according to the routing table stored inside the router or layer 3 switch. According to this routing table, the packet is investigated and is searched for the path that it should take based on its destination IP address. The router looks at the destination IP address, searches the routing table for the right path, then forwards the packet according to this path found in the routing table. Let's have a rule here. The network ID equals the IP address ended with the subnet mask. If we have a given IP address and a given subnet mask, the subnet mask is something that masks the IP to get the network ID. If we AND them together, this is a logical operation that is done between ones and zeros and called ANDing. If we AND them together, we can get the network ID of this IP address. Routers are protocol dependent. They depend on layer 3 protocol. Layer 3 switch differs from a router that it is super fast than the router. It is completely hardware and uses hardware in routing. Meanwhile, routers can use software such as the routing tables to be used in the routing process. What is a routing table? It's a table that is stored inside the router or layer 3 switch. If inside the router, then it is software. If it is inside the layer 3 switch, then it can be stored in a hardware form or a firmware. It is composed of rows that are read sequentially. Each row is composed of several columns. A column for destination network, a column for subnet mask, a column for the interface that is connected to the router and that is used for forwarding the packet, a column for the gateway. The gateway is the next router. It is the next hop for the packet to go through. A column for the cost or the metric of the path, and it is used if there is a certain path that is an alternative path to the main path of this packet. So they are compared to each other in the point of view of cost or metric, and the less cost, the less metric is chosen for this packet. The routing table can be built statically through the network administrator, which store this routing table inside the router, or can be built dynamically through some dynamic routing protocols such as the RIP Routing Information Protocol or the OSPF Open Shortest Path First Dynamic Routing Protocol. The destination network can be dedicated or deducted from the destination IP address through ending with the subnet mask. According to this, we can know the interface that the router is going to choose for forwarding the packet and the gateway that will be the next hop for such packet to go to. If we want to see routing in action, we can look at this diagram. We can see the host source and the destination host separated by 3 networks and 2 routers. Each source connects to its specific router through indirect delivery, then the router connects to the next router through indirect delivery, and then the last router connects to the host through direct delivery. We can see that each 2 machines connected through the same network uses direct delivery. Routers contact each other through indirect delivery because they are not connected directly through the same network. This is routing in action. We can imagine that this host machine is in a country and this destination machine is in another country where an ocean can separate them, but packets can go through these routers from the host to the destination according to the routing table, according to the path chosen by the routers to be delivered from the source to the destination based on the destination IP address. Thank you. Now we will talk about the 2 main transport layer protocols in the TCP IP protocol. The TCP Transmission Control Protocol and UDP User Datagram Protocol. The transport layer in the OSI model, of course, is layer 4, and in the TCP IP implementation it is implemented in 2 protocols, the TCP and the UDP. You either use this or use that. You use the TCP for reliable communication if needed, or you use the UDP for unreliable communication if this is the needed mode. The transport layer is responsible of session multiplexing. Multiplexing means that several inputs leads only to one output. This is the responsibility of the transport layer, to let every service at the source talk specifically to the corresponding service at the destination side. It's responsible of flow control if needed. It's responsible of adjusting the flow of the data according to the slowest side, either the sender or the receiver. It lets the faster side slows down to be suitable for the slower side. It's responsible for reliability if needed, for loss detection, for error recovery end to end. It's responsible for dividing data into segments, adding the port number, and the port number is a very important identifier to identify the type of service requested from the client to the server or from the source to the destination. It is responsible for the communication socket to socket. And let's see what is a socket. The socket is a combination, as we can see in the diagram, is a combination between the IP address that we have talked about and the port number that we need to talk about now. What is a port number? It's the identifier for the service. Each port number is associated with a certain service over the internet, especially the port numbers ranging from 0 to 1024. The length of this port number is 16 bits. That's why we can say that the port number can range from 0 to 65,535. Among these port numbers, the port numbers ranging from 0 to 124 are the well-known ports. For example, port number 80 is for the HTTP, port number 21 is for FTP, 53 for DNS, 25 for SMTP, Simple Mail Transfer Protocols. Port numbers larger than 1024 is called ephemeral ports. Ephemeral ports means that they are not the well-known ports, not associated to very well-known services, but can be used for the communication from the client side to the server side, while the well-known ports are dedicated on the server side for each of the services such as HTTP, FTP, DNS, or SMTP. Here is the socket communication. Here we can see the socket address, IP address, and port number forming a socket address. This socket address is at the source, and a corresponding one is formed at the destination from the IP address of the destination and the port number at the destination. Here is a socket at the source, another one at the destination. They are communicating with each other in socket-to-socket communication. This is the responsibility of the transport layer. Layer 4, the responsibility of the TCP protocol or the UDP protocol. Let's compare between the reliable communication and the best effort communication. The reliable communication is connection oriented. No data transfer before connection establishment. But in the best effort communication, it is connectionless. Data can be transmitted without establishing a complete connection or a complete session, complete circuit from the source to the destination. The protocol used for reliable communication is the TCP. The protocol used for the best effort delivery is the UDP protocol. The reliable communication provides a means of sequencing, the sequence number in the TCP protocol. In the best effort delivery, you cannot specify the sequence of the data, which is before which or which is after which. The uses of the reliable protocol are for transferring email, file sharing, downloading files. The best effort delivery is for transferring voice or video. In general, it is for real-time data. It's for data that is delay sensitive and not loss sensitive, such as the voice streaming or the video streaming, where UDP is much more efficient than TCP. The UDP protocol as the first protocol in the transport layer. It is used in the best effort delivery. It is unreliable, but it provides application with access to the network layer. It saves the overhead of reliability mechanisms. It saves the acknowledgement, saves the sequencing of the data. Each of the acknowledgement and sequencing needs adding headers, and the UDP protocol saves this header and saves bandwidth for the data itself, the voice or the video being transmitted. It's connectionless protocol. No connection establishment before sending data. You send data and you are not sure that the recipient is there. The recipient is up and running. The recipient will receive the data in sequence. It has a very limited error checking, and this checking does not include recovery of errors if existing. It is not resilient to data loss, and data losses can be due to routing errors or duplication. The UDP protocol provides no data recovery features for such losses, so it is completely unreliable, and therefore it is used with the delay sensitive data and not for the loss sensitive data. The UDP header is simple and it does not provide any form of error recovery, so it is simply composed of the source port, the destination port, the UDP length, and the UDP checksum that checks on the header only. It does not provide error recovery, does not provide acknowledgement sequence number, as we will see later in the TCP protocol. The TCP protocol is the reliable protocol. It's the reliable version of the protocols that are acting on the transport layer. It provides access to the network layer for applications, just like the UDP, but it is different. Different in the way that it is connection-oriented protocol. Before data transmission, there should be an establishment of connection, complete circuit between the source and the destination. It provides error checking. It provides data recovery features end to end. If there is data loss, data duplication, or any change in the data from the source to the destination, the TCP protocol can detect this, can detect the loss and the duplication in the data, and can recover this by resending the data itself. It provides sequencing of data through the sequence number header that existing in the header of the TCP. So if the arriving data is in a wrong order, the sequence number helps the receiver to reorder the data to the right order. It provides acknowledgement of receipt, so by this it can face the losses on the network and can detect that some data are lost and can be resent by the source. The TCP protocol, for the sake of such features, the features of data recovery, sequencing, and acknowledgement, is more commonly used than UDP because it is reliable, because it is more error resilient. So it is more commonly used than UDP, especially for web transfer, mail transfer, and file transfer. The TCP header is of course more complex than the UDP header. We can see the source port, the destination port. We can see the sequence number used for sequencing data. We can use the 32-bit acknowledgement number, which is used for acknowledging data being sent. We can see the 16-bit window size used for flow control. We can see the checksum, which is the checksum anywhere used for checking errors across the header and the data. We can see the 16-bit urgent pointer, which points on the urgent data inside the data field. If this field, for example, contains the number 2000, this means that the byte 2000 in the data field is urgent and needs to be processed before its turn comes. So this is the TCP header. We have some flags for the urgent field, for example, for the acknowledgement, for the push, for the SYN, for the FIN, that are used for the three-way handshaking used at the beginning of the session of TCP communication, and the four-way handshaking used at the end of the session of TCP communication. If we try to map layer 4 protocols to applications, layer 4 protocols and the port number to the application protocols, we can see that the FTP protocol uses port number 21 and uses the TCP as the transport layer communication protocol. Telnet uses 23 as port number. Telnet is used for remote administration. It is used by a client to administrate a server remotely and act as if sitting on it, copying and pasting and formatting the machine from another remote machine, and this is done through the port number 23. The HTTP, the Hypertext Transfer Protocol, uses port number 80 and it uses the TCP protocol. So it is reliable, so it can correct some errors. It is resilient to data losses. The DNS is a special case. It can use the TCP and can use the UDP. In both cases, it uses the port number 53. It can act in a reliable form using the TCP protocol. It can act as unreliable form using the UDP protocol if speed is more important than reliability. The TFTP, or the Trivial File Transfer Protocol, uses port number 69. It is just file transfer without any username or password or something like this. It is faster file transfer than the normal FTP. The SNMP, or the Simple Network Management Protocol, which is used for managing the network. It's used for communication between the routers. It is a protocol that is used to manage the network and make it faster and more robust. It uses the UDP protocol for the sake of the speed and the sake of being faster, and it works on the port number 161. By this we come to the clear demonstration of both the TCP and the UDP protocols acting in the transport layer of the OSI model and the transport layer of the TCP IP protocol as well. Thank you. Now let's talk about the application protocols, the protocols that work in the session, presentation, and application layers of the OSI model and in the application layer of the TCP IP protocol. These protocols are such as the HTTP or HTTPS that offers the web services. The HTTPS is the secure version of HTTP. This S is for security. Or like the file sharing services, FTP or TFTP, file transfer protocol or trivial file transfer protocol, or the mail services, simple mail transfer protocol, SMTP, POP3 or IMAP, Post Office Protocol version 3 or Internet Message Access Protocol, or the DNS services, the Domain Name System Services. These are the protocols or example protocols that work in the application layer of the TCP IP. Each of them has a dedicated port number. Each of them offers a certain service between the source and the destination, between the client and the server over the internet, to offer a certain service to the user of such protocols. Let's start by the HTTP. HTTP stands for Hypertext Transfer Protocol. It supports the web services. It supports the transmission of images, texts, and hyperlinks between the web server and the web client through the web browser. It supports all the www pages that can be transferred between the server and the client. It uses port number 80. The secure version of HTTP is HTTPS. S here is for security, and HTTPS uses the port number 443. HTTP is one of the application layer protocols in TCP IP. FTP, or the File Transfer Protocol, uses port number 21. It has a built-in application in the MS Windows operating systems, Microsoft Windows operating systems. Many third-party programs can act as FTP server and client as well to transfer files between the FTP server to the FTP client. The web browser, any web browser, can work as an FTP client if you replace the HTTP suffix at the start of the URL with the word FTP. Then it will work as FTP client and can be able to transfer files. The email protocols. We can see in the diagram that the email client is contacting the email server through two protocols. One of them is for sending, which is the SMTP, and the other is for receiving emails or downloading email messages from the email server to the email client, which is the POP3. The communication between mail server X and mail server Y is done via the SMTP protocol, Simple Mail Transfer Protocol. The SMTP is the common language between the majority of the mail servers around the internet. Once more, at the client Y, the SMTP is used for sending emails from the client to the server, client Y to server Y, and the POP3 is used to download messages of client Y from the server Y. The POP3 or the IMAP, it depends whether you want to download the message through POP3 or to just access the message through the IMAP. The SMTP is the common language used by the majority of the mail servers, as we have said. It sends messages back and forth to other mail servers, and it is used to sending message between the mail client and to the mail server. The Post Office Protocol is for receiving and collecting email messages from the mail server to the client. It downloads the messages on the machine, so the user can work offline, can download the message at the beginning of the session, and then if the internet cuts, it can work offline. This saves quota on the server since the messages are downloaded from the server to the client, so the quota of the user can be emptied for other messages to arrive. Internet Message Access Protocol is another message to access the messages by the client on the server. It is just for accessing the messages, reading them. It does not download the message. It does not save the quota. It retrieves only the message header, allows the user to read the message, but the body of the message itself is at the server side. So this is more commonly used if you are accessing your email from a machine that is not yours, from a machine that you do not want to download your messages on. The DNS protocol, one of the application protocols working in the TCP/IP. DNS stands for Domain Name System or Domain Name Servers in some written texts. The DNS resolves the domain name into IP address. For example, www.cisco.com is a domain name. This is a name that can be understood by the human, but the machine needs numbers, needs addresses to work with. So this resolution between names that are understood by human into addresses that are understood by machines is done via the DNS, the domain name system. The DNS server here matches the human address with the numeric address. The device uses numbers, understands only ones and zeros and numbers. So www.cisco.com is mapped into the address 198.133.219.215. Humans can easily understand names, machines can easily understand addresses, and the DNS acts as the resolution machine for resolving names into addresses. This is the DNS tree around the world. We can see that we have websites or domain names ending in .org, .com, .de, .is, .uk, and .anything. We have each country in the world have two letters suffix, like .uk, United Kingdom, .de is for Germany, and we have .org for organizations, com commercial, edu for educational, mil for military, and net for networking organizations. And we have some organization names that are governing the internet, like the IETF, Internet Engineering Task Force, and the other organizations that can work and manage the internet as examples of the domain names that can exist over the internet. We have here the www as the machine name that can be connected to IETF as the parent domain name, then .org. This forms the fully qualified domain name of www.ietf.org as a website. If we can see DNS in action, here we have a DNS client that contacts its local DNS server asking for what is the IP of cisco.com. This local DNS server does not have the answers, but can ask a parent DNS about things that ends in .com. What is the IP of cisco.com? And the parent can answer it with the IP address of cisco.com, then the answer is transferred to the DNS client. Sometimes this local DNS server caches the answer for the sake of not asking once more for the previously asked domain names, and can answer about www.cisco.com from its cache in the second time it is asked about from any other client than the first client. We have also a very well-known and famous protocol working in the application layer that is called the DHCP, Dynamic Host Configuration Protocol. It's an important protocol in the configuration of the TCP/IP parameters inside any machine. If a client on a certain network boots and moves to be up on the network, it sends a DHCP client broadcast, a discover message that is read by several servers over the network that he is connected to, several DHCP servers. One of the servers sends the DHCP server broadcast offer message, which means that he offers the client some of the TCP/IP parameters that he can take to start and work over the internet. What are these parameters? These parameters are the IP address, the subnet mask, the default gateway, and the DNS mainly. the DNS server that he can contact to communicate over the internet. Then the client responds with the request message for leasing and asking for these parameters. The offer message says that I'm a server, I'm a DHCP server, I can offer you these parameters. Then the DHCP server finalizes the exchange with acknowledgement message. Finalizes that this client has reserved this IP address, this subnet mask, this default gateway, and this DNS, so that he cannot repeat leasing the same IP address to other machines. Otherwise, there will be a conflict of IP addresses between two machines, and this is forbidden. No two machines can have the same IP address over the same network. So, what is the main benefit of this DHCP? It saves the efforts of the network administrator that is used in configuring several machines with IP addresses, subnet mask, default gateway, DNS servers. It saves this effort and makes a machine does this task. Of course, the machine does not make the mistake of the IP conflict, does not make the mistake of assigning the same IP address to two machines. The DHCP as a protocol is very commonly widely used over the networks to lease IP address, to distribute IP addresses over several machines on the same network, and to save the effort and to save the mistakes that humans can do by conflicting IP addresses. By this, we have searched some of the application protocols working on the application layer of the TCP IP protocol suite. Thank you. Now let's practice. Let's recognize some of the TCP IP tools, some of the TCP IP commands that helps in troubleshooting the network and in determining the IP addresses of the machines and the domain names of the websites and so on. Let's start by this command. It's ipconfig. Let's try this command now. How do we try this command ipconfig, and what could be its output? ipconfig is used, if we type it here on the command prompt, is used to determine the IP address, the physical address, the gateway address, the subnet mask, and other addresses, all the TCP IP configuration of the machine. If we type ipconfig/all, we get more configuration in details about the TCP IP configuration of all the Ethernet cards and the Wi-Fi cards existing on a certain machine, laptop or PC or any other machine that we need to know its IP address, its gateway, or its DNS that is resolving the domain names for it, or its gateway, the router that is connected to this machine to connect it to the internet. The second command that we need to know about is the ping command. Ping stands for Packet Internet Grouper. We can access the help of this command, the manual of this command, by typing ping -?. Here is the help, here is the manual of this command. For example, if I type now ping www.yahoo.com, I'm testing the connectivity between my machine and yahoo.com. Either I get a reply, which means that I am connected, or I get a request timed out, which means that I am not connected to such machine. So I can type ping followed by an IP address and ping followed by a domain name. I can type ping for a domain name followed by the switch -t, which means that I need to execute an uninterrupted ping that goes on a number of packets and sends to me the reply until I press Ctrl C to stop this operation. Here I am connected to google.com, and the request, the ICMP request packet sent by this command, is replied by the ICMP reply that is appearing on the CMD screen. I can specify the number of packets sent by my machine to the destination machine I need to ping. For example, I can type ping -n6 www.google.com, which means I need only to send 6 packets and see the reply only. Here are 2, 3, 4, 5, 6, and then it stops. Ping has so many switches. If I need to know all the switches of the ping command and need to know more about them, I can type ping -? and go on and see these switches and its usage and try to use them one by one. The other command that I want you to know about is the ARP command. ARP stands for Address Resolution Protocol, and as we have said before, ARP is the resolution protocol resolving the logical address into physical address, resolving the IP address into MAC address. If I type ARP -? I get the help or the manual of this command and can read the usage of this command. The most popular usage is using ARP -A to display the ARP cache of a certain machine. Here we can have the internet address and the physical address corresponding to it that are stored inside the ARP cache of this machine and used for the resolution between the IP and the physical address. This is a MAC address, this is an IP address. Both are used for the resolution between logical and physical, and both are stored in the ARP cache of this machine. ARP command, once more, can be used by several switches. You can have a look at ARP -? to know the usages of such switches. You can make your machine act as an FTP client. If you type the command FTP, then you can type open, for example, ftp.microsoft.com, and then waits for the connection between your client machine and ftp.microsoft.com. It may ask you about username and password. If you supply them in a correct way, then you log in into the ftp.microsoft.com. To do what? To download files from this FTP server to your client machine. To get some files through the command get, and then type the file name. And you can upload some files through the command put, and then type the file names, and by this you can upload some files from your machine to the server machine. And you can type ls, which means that you want to list the contents of the FTP server that you are connected to. To end this FTP session, you just type bye and then end this FTP session. Another command that we need to know about is nslookup. nslookup is a very useful command in determining the IP address corresponding to a certain domain name. For example, if I type here www.google.com, I can get the IP addresses corresponding to google.com and connecting them to my machine. If I can type any domain name, I can get the corresponding IP address, and vice versa. If I can type an IP address, I can get the fully qualified domain name for this IP address. To exit from this command, I simply type exit. Another command that we need to know about is netstate. Netstate -? shows the manual and the help of this command with many switches that can be used. Netstate is used to display the current connections of any machine. For example, if I type netstate -n, I can see the machines that I am connected to currently through the IP address of my machine, the IP address of the foreign machine, the connection protocol, and the status of this connection. I can also type netstate -a to display the same connections in the form of IP address of my machine, domain name of the connected machine, and the status of the connection. Netstate is very useful in determining and in specifying the connections that are connected to my machine in a certain moment of time. After this commands has been listed, we can go through them. Here is the ping -t -n -r -w, -t for uninterrupted ping, -n for specifying certain number of packets, ping -r for the route count, and ping -w for the timeout, specifying the timeout. Here is the output of an ARP cache of a certain machine using the ARP -a command. Here is using the FTP command to connect to an FTP server. You can use open, ls, cd, bin, get, mget, put, by. These commands can be tried on the FTP session. And slookup to resolve the DNS into the domain name into IP address using the DNS system. Route, this command is used to print the routing table for a certain machine. Route print, for example, displays the routing table for any machine that I am connected to. Displays the routing table of the machine that this command is typed on. The routing table and its components has been previously explained, and this is a simple routing table that you can have a look on. This is the destination network, this is the subnet mask, the gateway, the interface, and the metric or the cost. Just review the section speaking about the routing table, and you can see these columns as the components of the routing table. Finally, we come to the netstate once more. Netstate -a, netstate -n, and netstate -p shows the connections with the name of the protocols. Netstate -p, for example, and then space TCP shows the connections made through the TCP protocol only through this machine where you type this command. Thank you. Welcome to the wireless section. Let's start by exploring the benefits of a wireless network over a wired network. The benefit of a wired network is mobility, flexibility, scalability. The wireless networks enables that you can bring your own device. The wireless network sometimes is more cost effective than the wired one. When we say mobility, it is the biggest attraction towards going to wireless, because in most of the times we need to be mobile inside the place, and at the same time we need to access the network. We need to be online. We have so many mobile devices nowadays, such as the laptops, mobile phones, and the tablets. These devices can access the network through the wireless connection while you are moving. Mobility enables access anywhere, in the corners, in the corridors, in the meeting rooms. Any of these devices can access the network through wireless connection from the corners, from the corridors, from the meeting rooms. And as well, you can have mobile voice over IP phones. You can have mobile sets for the voice over IP phones that can be handled anywhere inside the building. The flexibility is another attraction in the wireless network. It enables the ease of setup and change. You do not need to fix wires inside the place. You do not need to change the infrastructure. I mean the civil infrastructure of the place. You do not need to dig inside the wall to fix cables. You do not need wiring hassle. You can enable the guest access inside the place. The guest that is temporary inside the place and passing some time inside the place can be enabled through the wireless network. You can allow to work remotely. You can allow to access any server remotely from another place where the server room is away from. You allow for freedom of operations. You can separate the persons working in different departments in different rooms, and they can still connect to each other wirelessly and connect to the network wirelessly. It allows freedom, which is some sort of mobility and some sort of flexibility in changing the place, in the setup of the place, in the movement of persons using the network. Wireless networks allows for scalability. You can expand the network easily. A machine can enter or leave the network easily, much more easier than the wired infrastructure. You have saved cables. You saved connecting devices such as the switches and the routers. You saved them and replaced them by a wireless access point. You saved the outlets that exist in the wall to connect the cables to the wired infrastructure. There are no outlets here in the wireless network. It is just the access point that connects wirelessly to the other devices. You can easily add a machine to the wireless network. You do not need to add an outlet in the wall for this extra machine, or to remove an outlet in the wall if this machine leaves. This machine can be handled by a person who can enter the place and add it to the network so easily, and can leave the place and remove it from the network with the same easiness. Scalability also means that you have the capability of relocation inside the building. You can change the functionality of any room from a meeting room to an office or vice versa. You can have less planning overhead. You do not need to plan the room from the beginning till the end to be a meeting room. It can be a meeting room for some time and then an office, an ordinary office for the rest of the day. So it does not need to be planned to be something that is fixed. Scalable speed of connection. The speed of connection for this network is scalable. It can be adapted to the variety of devices connecting. It can be adapted to the fast mobile phone if it is smart, and to the slow mobile phone or laptop if it is something old model. You can connect the hard to reach areas, the areas that can be hardly connected through the wired infrastructure can be easily reached through the wireless network and through the access point. You can enable here the concept of bring your own device with you to the place. We have variety of devices, laptops, mobile phones, tablets that can be brought to the place to connect to the wireless network, and you have ease of network establishment inside a meeting room, inside a training center, inside an office, inside a canteen. Just connect the wireless access point to the ceiling of this room, and it is now a separate network and also a connected network to the wired infrastructure through one access point that connects these devices to the wired infrastructure and enables these devices to move and receives the wireless signals emitted from these devices to the access point and to the wired infrastructure and so forth. Wireless networks are cost effective. You save the cost of cables, you save the cost of connecting devices, you save the cost of outlets, you save the cost of so many switches with somehow cheaper access points and somehow less in number access points. You save the labor costs that are involved in wiring. You save the labor costs that are involved in digging the wall and spreading the wired infrastructure inside the walls of the building. You save some civil work that is needed to allow for the cables to pass inside the building, to cut the walls and the floors and the ceilings, to allow or to establish a path for the cables to pass through inside the building. You save all of this, and you save the cost, of course, of the devices, the end devices as well, since your guests or your trainees or your conference attendees can bring their own devices their own mobile devices into your premises, connect to your network, and then take their devices back. So you do not have to buy them any devices and to offer them any devices on your own. If we have a very small comparison between the wired and the wireless infrastructure, we can say that the wireless has many advantages, but it is not a perfect solution. We must mix both technologies in the network, wired and wireless. The access point just connects the wireless devices to the wired infrastructure. You must have a wired core network and a wireless access network connecting the communicating devices to the wired core infrastructure. A wired infrastructure must exist at most of the cases to be the infrastructure of the place and to be routed and to be connected to the internet, and then it can end with wireless terminals that can be mobile and can be moving inside the place. Wireless has advantages in offering a healthy environment inside the place. It avoids the electromagnetic interference. It avoids being shocked by the electrical signals traveling inside a wire. It saves all of this and offers somehow a healthier environment inside the place. It offers a safe premises for working because no falling over cables inside the place will take place or will occur, and you will have less cables mixing with water in the cleaning process. In the water flooding process, you will have less dangerous situations since cables are less. So if there is water existing inside the place, you will find that less cables are susceptible to mix with them, and less people are falling over the cables existing in the place. Thank you. Now let's take a look on the wireless networks types. We have several types of wireless networks that are used in communications. So our course will focus on the Wi-Fi network, but we can explore some types of the wireless networks that can be used in connecting devices and communicating them to the internet. The difference between each of the wireless networks mainly lies in two features. It's the frequency range that is used by this wireless network and the covered area that is used by this wireless network. The frequency range used by this wireless technology and the covered area by this technology. The bandwidth, the distance, the speed are the main features that differs one wireless technology than another. We have a variety of wireless technologies that are used in our daily life, such as the radio and television, either terrestrial or satellite. Radios can be terrestrial and can be from the satellite. The same is the television, so both can be emitted from terrestrial stations or from the satellite in the sky. We have the GMDSS, which are used by ships to transmit their information and even their signals of emergency from the oceans to the land. We have in each country the police and army walkie-talkies and wireless network to communicate through each other as persons from the police or the army in a safe and on a separate network. We have the aeroplanes that uses their networks to transmit signals between the civil aeroplane and the airport, or the military aeroplane and the airport. We have the GSM, the Global System Mobile, for the mobile phones and the smart mobile phones we hold in our hands. We have the Bluetooth technology that is used for transferring data in small geographical areas. We have the infrared that are used by the remote controls. We have the WiMAX, which is a WAN technology for transferring data. And finally, we have the Wi-Fi, which is a LAN technology for transferring data. And the Wi-Fi is the core of our section here. Let's talk about the frequency ranges. We have a licensed band and an ISM band. A licensed band means that you need a license to use this band for your communication. A license from the regulatory authority existing inside your country to be able to transmit and receive signals over this band. And you have the ISM band that can be used for industrial, scientific, medical. That's what ISM stands for. Industrial, scientific, and medical applications without the need for obtaining license. The Wi-Fi lies in the ISM band. Many wireless technologies are inside the ISM band that can be used in transmission and receiving signals without the need of licensing from the regulatory authority. Any regulatory authority inside a country is responsible of the spectrum management of this country, is responsible of dividing the frequency range inside this country among the authorities that has been mentioned in the last slide, among the military and civil, among the satellite and terrestrial radio and television, to avoid interference and to save some guard band between the frequency ranges used for the different applications existing inside the country. Also, the regulatory authority is responsible for quality monitoring of mobile phone calls, of satellite communication and satellite television and satellite radio. It has the authority of requesting from the mobile operators to handle the phone calls in a better way, or to offer better voice quality for their mobile phone calls. It is responsible for the rules and regulations to offer a fair play game between the mobile operators, for example, or between the video services companies that are offering video services over wireless networks. Each regulatory authority inside any country should have the research and development department that are responsible for funding and directing the research and development inside this country in the wireless communications domain, and ask them for the up-to-date technologies and the most recent researches that has been done over this type of communication. Let's have a look at the global system mobile, and the GSM is a very important component of the internet nowadays. So many mobile devices connect to the internet through the GSM network. So we need to know more about this GSM network. Let's have a look at this diagram and see that the laptop or the mobile phone is connected wirelessly to the BTS. The BTS is something like a tower that exists in the street, and it is fixed, but it is covering its surrounding area to allow the mobile phones and the laptops to connect wirelessly through it to the wired infrastructure that is behind it. So the BTS is a very important component to be spreading over the whole area that needs to be covered by the wireless network. It allows for the mobile devices, the moving devices inside the place, to connect through it to the wired infrastructure. We have the PSTN network, which is the public switched telephone network. That is the wired network connecting the land phones, the fixed phone lines, and we have the internet that may use the infrastructure of the mobile network and the PSTN network to connect mobile devices and fixed devices to the internet, to the servers of the internet, to the World Wide Web. So we have the internet as the largest network in the world, and the network of networks that can allows the access to mobile devices through the mobile network, or to fixed devices through the PSTN to the World Wide Web network. The GSM has passed through several generations. We have the first generation, second generation, third, fourth, and fifth. And we have the LTE, which is the long-term evolution. The main difference between each generation and the other lies in the bandwidth, the speed of connection. Each generation is better in its speed and allows for more applications and more security features from a generation to another. In the fourth generation, we can have a look at some video communication that can exist and that was not there in the third or the second generation of mobiles. We can see in the fourth generation more security features, and as well we can see the fifth generation that is still coming and in progress, having more bandwidth and more availability for video communication and more security features than the fourth and the third and the second generations. The Bluetooth is a very common way to connect some mobile devices that are not so remote in distance. It's a standard for short distances that can reach 10 meters or something like this. It uses short wavelengths that lies in the ISM band, Industrial Scientific Medical Band, which means that using Bluetooth needs no license. You can establish a personal area network using the Bluetooth. Personal area between 2 or 3 or more mobile devices, smartphones that are equipped with Bluetooth cards to communicate with each other using this technology in a limited area. The Bluetooth is managed by the Special Interest Group (SIG) of Bluetooth. It has the standard number 802.15 from the IEEE. Bluetooth is susceptible to barriers and walls, which means that if two devices needs to connect to each other using the Bluetooth, there should be no walls or barriers between them if they will connect through Bluetooth. Otherwise, the connection will fail. The infrared is a very known way for wireless communication. It uses the electromagnetic radiation. It uses longer wavelengths than the visible light. It is a short-range communication. It is most commonly used by remote controls to switch between channels and things like this for any device, any electrical device or any device that needs to be controlled remotely. The infrared is just like the Bluetooth, is susceptible to barriers and walls, and if there is a barrier or wall between the remote control and the device needs to be controlled, the communication fails. The WiMAX, which is another form of wireless communication, it is a WAN technology. It is invented and it is managed by the WiMAX Forum. It has the standard number 802.16 from the IEEE. WiMAX stands for Worldwide Interoperability for Microwave Access. It is competing now with the LTE or the long-term evolution as a WAN technology. They are both competing now as WAN technologies connecting devices with better speed, with higher capabilities, with more security features. The WiMAX can provide the triple play communication, and let's explain what is triple play. The triple play is allowing for data, voice and video to exist over the same connection, over the same wire, over the same outlet inside the building, which means that you receive the three of these information streams through one outlet, and this outlet is then spreading to several devices. One outlet for the fixed phone for the voice, another outlet for the laptop for the internet, and a third outlet for your television for streaming video on demand, for example, to your television. So the WiMAX can enable this triple play communication. Triple play communication is one of the trends in communication to enable all of the communication channels to coexist with each other inside one channel and with one outlet to the user. Thank you. Now let's talk about the wireless networks protocol, the Wi-Fi. The Wi-Fi stands for wireless fidelity. It's a LAN protocol. It is used to connect devices in a limited geographical area wirelessly. It has the standard of 802.11 from the IEEE. we have several standards for the Wi-Fi. A, B, G, and N are the names of these standards. They differ in the frequency used and the speed achieved for the wireless communication. The Wi-Fi generally works in the ISM band, so it needs no license from the regulatory authority. It uses the frequencies of 2.4 GHz and 5 GHz. According to the standard, either it is A, B, G, or N. This frequency band is divided into a number of channels with a guard frequency or a guard band between each channel and the other. These channels are used for the communication of access points that are near to each other without allowing for interference between their frequency ranges. Wi-Fi is governed by the Wi-Fi Alliance. The 802.11 standard is the wireless LAN standard. It uses air as the transmission media, such as the rest of the wireless standards. It is concerned with the two lower layers of the OSI model, the physical and the data link layers. In the data link layer, it divides the data link layer into two sublayers. One of them is the logical link control layer, and the other is the medium access control layer. And the physical layer is also divided into two sublayers. One of them is called the physical layer convergence procedure, PLCP. The other is the physical medium dependent, PMD layer. So we have in this diagram this division to the data link and physical layer according to the Wi-Fi standard. We can establish two types of wireless networks based on the Wi-Fi standard, either an infrastructure network or ad hoc network. The infrastructure network uses the access point to communicate two devices to each other. It is a star topology. It is more commonly used to establish a wireless network inside an office, a meeting room, or a corridor, or something like this. The access point is used to connect the wireless devices to the wired infrastructure. Sometimes you need to establish an ad hoc network wirelessly. You need to establish direct communication between two laptops or two mobile phones that happen to exist in the same place. This ad hoc network is established for short period inside, for example, a meeting inside a meeting room between two persons that need to communicate their business cards or to exchange some information between their laptops. They can do this using the ad hoc network. It's suitable for meetings and conferences. It is more flexible in setup. It can be set up for some short period of time and then dissolves if these two laptops or mobile phones are away from each other. It uses the point-to-point communication topology. Meanwhile, the infrastructure wireless network uses the star topology since there is a connecting device which is the access point. The SSID, which is the service set identifier. This is the name of the network. This is the name that you can see when you scan the surrounding area for wireless networks. It is used to identify the wireless LAN. It is the name of the wireless LAN that you choose to connect to. It can be broadcasted name or hidden name according to the configuration of the access point and the wireless LAN. The configuration says that this wireless LAN is broadcasted. Anyone that scans the network using the mobile device or the laptop can see the name of this network, or it can be hidden, so scanning the network does not show this name. If you will connect to a hidden network, you need to know two pieces of information: the name of the network and the password. Meanwhile, if you will connect to a broadcasted SSID, you need only to know the password and you will find the name broadcasted and you just click on it to be connected. The length of the SSID can reach to 32 alphanumeric characters. This is the name of the network, can reach 32 alphanumeric characters. It can be composed of several access points. Several access points can serve the same SSID, can connect devices to the same SSID. Single access point as well can connect to several SSIDs. According to the configuration of this access point, it can connect devices to many SSIDs, many names of networks through the same access point. In Wi-Fi, collisions are avoided through another technology that is different from the SISMA CD. It is called the SISMA CA, Carrier Sense Multiple Access Collision Avoidance. It uses two types of messages that are called RTS, which is request to send, and another signal that is C2S. What happens is that the sending device sends an RTS signal. It does not start sending until receiving CTS signal from the receiving device. That's the way it avoids collisions. But the possibility of collisions still exists. There can be some collisions, and as you know, collisions are something that we do not like over our networks, either wired or wireless. So collisions leads to poor performance, slower performance, and leads to resending several times for the same type of information. Recovery of collisions is done just simply by resending the information that has collided with each other. Resending means slower. Resending means poor performance. But this is the way that the SISMA CA depends on to avoid collisions or to recover from collisions that already has happened. By now we have introduced the Wi-Fi protocol briefly. Thank you. Let's now talk about the wireless networks devices. What are the devices that can communicate wirelessly? Let's start by the wireless access point. The wireless access point is a networking hardware device as shown in the picture. It connects the mobile devices to the wired infrastructure. From one side it is connected to the registration jack 45, and to the other side it is connected to an antenna. So this antenna is used for wireless communication, and the RJ45 is used as an Ethernet interface for the wired infrastructure. So it has the interfacing between the wired infrastructure and the wireless network through the antenna and the RJ45 existing in the same device. The access point is a layer 2 device. It works in the physical and data link layers. The coverage area depends on the antenna, on the number of antenna existing in this wireless access point, and the strength of each of its antenna. Of course, wireless access point with one antenna covers less area than wireless access point with two, and 2 is less than 4, and 4 is less than 6. And of course each antenna has its strength and its coverage area. So the antenna, its number and its strength determines to a great extent the coverage area of this wireless access point. We have several access points manufactured by several known vendors for networking devices. Cisco and other companies has produced very well-known names for access points, such as Huawei and other networking companies. It may contain a DSL and a router in the same box. This is a wireless point for home connections, the one that contains DSL and a router. It is a variety of devices that are contained inside one box. So this DSL is connected to the telephone line, and the router is connected to the splitter, and then each of these devices interact to get the wireless device inside your home connected to the internet. The wireless access point can support several standards of the Wi-Fi, A, B, G, and N standards. It can be divided into several radio channels to avoid interference between the channels it is communicating with each other. This access point can act on channel 5, and the adjacent access point can act on channel 7. So we leave channel 6 in between unused so as to avoid interference between the communication channels. One access point can hold several SSIDs, either broadcasted or hidden. The speed and coverage of the access point depends on the brand and model of the manufacturer. A good one can cover bigger area and can have a higher speed. The access point signals can be obstructed by walls and can be stopped by long distances. This wireless signals can be reflected by walls and cannot bypass walls, and it is susceptible to being weakened through long distances. It can be configured through its firmware directly through Telnet, for example, or any other communication that can directly sets the configuration and saves the configuration over the firmware, or the configuration can be web-based. The access point can show a web interface that can be used by the user to configure it, to determine the channel, to determine the encryption protocol that will be used by this access point, and other settings for this access point. The access point can receive its power over the Ethernet connection. It can use the power over Ethernet concept to be powered if it is in the ceiling or in some place that is hard to connect power to it. The security features inside a wireless access point are many. The SSID itself can be hidden, so it is not exposed to the attacker. Access points used filtering based on several parameters. It can filter the traffic based on MAC addresses, or based on IP addresses, or based on port numbers, which means that it can filter the HTTP service based on port number 80. It can filter some domain names to access the network from inside to outside, or vice versa. Access points use encryption techniques to communicate between the device and the access point. The mobile device and the access point can transmit and receive signals using the WEP, wireless encryption protocol, the WPA, or the AES protocols. Those three are encryption protocols that are used to encrypt the traffic between the wireless access point and between the communicating mobile device wirelessly. The AES is the most recent encryption protocol among these three. Let's have a look at the configuration of a wireless access point. This is the configuration page. This is the page that appears when configuring the access point through web interface. As you can see, you can enable VLAN, you can determine the SSID, you can determine the operation mode, you can determine the channel of communication, and you can, from the menu on the left, determine the security features that you want to apply over this wireless access point. Namely, you can determine the MAC filtering, which MAC addresses to filter and which MAC addresses to pass, which IP addresses to filter and which IP addresses to pass, and which domain names to filter and which domain names to pass. You can monitor the throughput, you can have statistics about the wireless communications, and you can have several features to configure through this access point using the web interface page. Let's have another device that can connect your network wirelessly, which is the USB modem. It connects PCs, laptops to the GSM network via mobile operator. So it is inserted inside the PC or the laptop to connect this PC or laptop to the mobile operator company through the GSM network. It depends on the network generation, so the speed can either be 3G or can be faster using the 4G or LTE network. It needs no wired infrastructure. It can be inserted inside the laptop with no wired infrastructure to connect this laptop to the internet directly through the wireless infrastructure. Of course, this USB modem has charging fees according to your subscription to your mobile subscriber and your mobile network. You should pay for this traffic passing through the GSM network you are subscribed to, so it is costly than the Wi-Fi network. It has less network speed than the Wi-Fi, and it uses more power of the mobile device, such as the laptop or smartphone, more power than the Wi-Fi. It allows more flexibility and mobility since it can be connected anywhere covered by the mobile network and the mobile operator, so it allows more flexibility and mobility, and it can be connected through streets and through remote areas just covered by the mobile network operator. Smartphones are the terminals that are most commonly connecting to the wireless network. Smartphones and laptops are the end terminals in a wireless network. It's spreading fast over the world. We have so many statistics that says that smartphones are penetrating the markets of several countries, and it is increasingly spreading over the world in number and in the type and number of users. It can be connected to the internet through Wi-Fi. It can be connected through the GSM network. It can be connected to other mobile devices through the Bluetooth. It can also act as hotspot that can connect other devices through it to the internet. It can act as the access point for other devices to the internet, and this access point can connect them through the GSM network. Wi-Fi is less battery consuming than GSM in smartphones. If you connect through your smartphone to Wi-Fi and connect to the internet, you will consume less battery than connecting to the internet using the GSM network. Charges for GSM depends on your subscription. You either pay a monthly subscription and uses the internet according to this subscription, or you can either pay as you go, pay as you download, pay as you use for the GSM operator you are subscribed to, and use whatever services you can use offered by this mobile operator. Thank you. Now let's know some of the drawbacks of the wireless networks and answer some of the review questions over these two sections. The wireless network's drawbacks lies in the limitations in the coverage. The areas covered by the wireless network is obstructed by walls and long distances, and sometimes weather conditions such as in satellite communications and things like this. So walls can obstruct the signals and can cause attenuation and can cause reflection and refraction for the wireless signals. Long distances can cause very strong attenuation for the wireless signal and may make it very weak to be heard correctly and to be utilized at the end device. The weather conditions can act as weakening for the wireless signal as well, and reflection, and such conditions can be obvious in the satellite communication. The wireless network generally has a high bit error rate, higher than the corresponding wire network. Wireless is in general less in the security features. This is because the communication media is the air. It is open for sniffing. It is susceptible to any listening device that can catch the signal intended from a certain sending device to a certain receiving device and interpret it and know its content, because it is just in the air which is open for everyone. So sniffing is probable, very highly probable. Sometimes the wireless network is very costly in charging, like the GSM, like the USB modem, which uses the GSM network. So it depends on your subscription. Either you are monthly subscribed or you pay as you go, so it can be costly than the wired network. It cannot fully replace the wired infrastructure. The wireless network is to serve the mobility and the flexibility goals only, but it is hard and very rare to find a network that is completely wireless. Even the mobile network, the mobile operator network, is wireless only in the access network, but it is wired in the core. Many networks act like this. It is wireless at the access sides to offer mobility and flexibility, but it is wired in the core to connect and to communicate between the fixed devices, the fixed connecting devices forming this network. Now let's have some review questions. What is the standard protocol over the internet? It's the TCP/IP protocol. What does TCP/IP stand for? TCP/IP stands for Transmission Control Protocol, Internet Protocol. Many people studies this protocol and ignores knowing the meaning and knowing what does it stand for. And let's figure out here that the TCP/IP, the word of the protocol suite, is composed of the two most important protocols forming it, the TCP protocol in layer 4 and the IP protocol in layer 3, the network layer. What are the layers of the TCP/IP? It's application, transport, internet or networking, and network access. As you can see, only 4 layers. It is not like the OSI composed of 7 layers. Some names are common like the application, transport, internet or network, and some names are not common like the network access. Let's recall here that the network access is formed of the physical and data link layers of the ISO OSI. The internet is the same as the network layer. The transport is the same as the transport layer in both in the OSI model. The application here in the TCP/IP is corresponding to 3 layers in the OSI model: the application, the presentation, and the session. Layer 7 and layer 6 and layer 5 in the ISO OSI model are here corresponding to 1 layer in the TCP/IP, which is called the application layer. This is very important to recall. Name some of the application layer protocols in TCP/IP. We can name several protocols working in the application layer of the TCP/IP, such as the HTTP, Hypertext Transfer Protocol, the FTP, the File Transfer Protocol, the DNS, the Domain Name System Protocol, and the SMTP, the Simple Mail Transfer Protocols. All of these are working in the application layer of the TCP/IP. Let's here recall that the application layer of the TCP/IP is corresponding to 3 layers of the ISO OSI model, which are application, presentation, and session. What are the port numbers used by each of the above protocols respectively? Let's recall here that HTTP uses port number 80, FTP uses port number 21, DNS uses port number 53, and it can act either TCP or UDP. SMTP uses port number 25. These port numbers are identifiers that exist in the transport layer that identifies the type of service requested from the client to the server to identify the type of data that needs to be transmitted between both machines. HTTP transfers text, images, and hypertext. FTP transfers files. DNS transfers domain name queries and reply to resolve between IP addresses and domain names. SMTP is for the exchange of emails between the mail servers and between the mail servers and email clients. What is the length of the IP address in bits? What is the length of the IP addresses? It's 32 bits in version 4 and 128 bits in version 6. This is the length of the IP address. Let's recall here that the IP address is a unique identifier, logical identifier, bound to the geographical location of the machine. What are the devices working in layer 3, or what could be the devices working in layer 3? The router is the most common device working in layer 3, and layer 3 switches are another type of devices working in layer 3. Layer 3 switches are somehow faster. It uses the hardware to perform the routing function. How can the routing table build inside the router? It can be built either statically by the admin, entered by the admin of the network into the router, or the router can build it dynamically through some routing protocols that acts dynamically, through some dynamic routing protocols such as the Routing Information Protocol RIP or Open Shortest Path First protocol, which is OSPF, and other protocols that can act dynamically to build the routing table inside the router. What are the main advantages of a wireless network? Many advantages of wireless: flexibility, mobility, scalability, and other advantages for the wireless network over the wired. But let's remember here that the network can be composed of mixed technologies, wired and wireless. Wireless to offer flexibility, mobility, and scalability, and wired to connect this wireless network to the wired infrastructure. In which layer does the WAP work? The WAP is the wireless access point. It works in layer 2, the data link layer. It works in both layers, the physical and the data link, but it is a layer 2 device. What are the main drawbacks of wireless networks? We had some drawbacks. Its limitations in the coverage area due to the obstacles of walls or weather conditions, or sometimes the long distances that can attenuate the signal being transmitted. The sniffing, it's a security vulnerability in the wireless networks. It allows for sniffing of the data being sent from the sender to the receiver, because the transmission media is open for everyone. It is simply the air that can be sniffed by anyone, and the message that is intended to a certain recipient can be interpreted and received by another recipient that was not intended. This is of course a security hole or a vulnerability. The wireless networks in general have higher bit error rate than the wired ones. And by this we come to the end of our wireless section. Hopefully we have briefed many of the wireless concepts. Thank you. Welcome to the Security Goals and Concepts lecture. In the first security section, let's discuss this balance between access and security. Let's imagine that someone has $10 to save. Let's imagine that this person has bought a safe that costs $1,000 to keep these $10 safe. Of course, he would look insane if he does so. This is the balance between access and security. This is the balance between what are the efforts you are exerting to keep your assets secure and how much does it cost if you lose these assets. Balance between access and security should be kept in mind for every security specialist, because sometimes the security specialist makes the security very complicated so that the legitimate users themselves suffer to reach the resources they need to do their work. Sometimes the security is so much costly for the legitimate access to be done. So you must keep balance between security and access to be a good security specialist. What are the goals of the security? The goals of the security is to keep three important things: confidentiality, availability, and integrity of the resources you are securing. Confidentiality, integrity, availability, CIA. It is not the American intelligence, it is the security goals. Confidentiality is keeping information and resources away from being read or being known by illegitimate users. Integrity is keeping it away from change and modification. Availability is keeping it alive, keeping it valid, keeping it there for the legitimate users to access. So when these three circles meet, the point of intersection is the point of security. The point of intersection is where security exists. The confidentiality is ensuring that information is not revealed to unauthorized persons. Data, while being transmitted or while being stored, should only be revealed to intended audience. This is keeping confidentiality. Integrity is ensuring consistency of data, ensuring that data has not been changed or modified, either while stored or transmitted. Integrity is making it possible to detect any modification of data. Availability is ensuring that legitimate users are not denied of access to information and resources. To protect from the DOS attacks, the denial of service attacks. Availability is ensuring that the service is there and the service is existing for legitimate users to access. The assets. The assets is a very important concept that we should know about as security specialists. Everything that has value for an organization or that has impact on the business continuity is an asset. People, data, hardware, software, physical devices, and documents. All of these are assets for the organization. And assets differs from an organization to another. For example, a bank, the most precious assets for it is the client accounts. A hospital, the most precious assets for it is the medical records of the patients. Software house, the most precious assets are the patents and source codes. For a university, for example, teaching materials and grades of the students are the most important assets to protect and to keep safe. Assets should be identified to create information security system. You should know what you are protecting as security specialist. You should know what is the most precious thing for this organization to protect most. Security specialist, good one, must be fully aware of the assets he or she is protecting inside the organization. What is a threat? A threat can be a person or a thing or an event or an idea which poses danger to an asset. The threat is a possible breach to the following: to confidentiality, to integrity, to availability of resources, or even to the legitimate use of these resources. It's a possible means of breaching a security policy, and we will talk much more about policy in the coming sections. It's exploiting a vulnerability intentionally or accidentally. It's obtaining or damaging or destroying an asset. This is a threat, or possibly doing so. A threat is what we are trying to protect assets against. What is a vulnerability? A vulnerability is the backdoor, is the weakness, is the workaround, is the absence of safeguards. Holes or gaps in a security system or security program is a vulnerability. It can be exploited by threats to gain unauthorized access to an asset. A vulnerability is a backdoor in our protection efforts. Exploit. Exploit is a program or script or code that is targeting a vulnerability. It aims to perform unauthorized operation. An example of an exploit is a backdoor Trojan used to grant unauthorized access to a machine. An exploit is the way or a tool by which an attacker uses a vulnerability to damage the target system. What is a risk? The risk is a measure of the cost of a realized vulnerability. It is the potential for loss or damaging or destroying an asset inside the organization. The risk is a result of a threat exploiting a vulnerability. Risks exist when our system have a vulnerability that a given threat can attack. Security mainly deals with managing risk to your critical assets. Security basically is an exercise in loss reduction and risk reduction. It's impossible to eliminate risk totally. I cannot say whatever happens inside this organization, risk is 0%. This is not existing. This is impossible. But risk is the probability of a threat crossing or touching a vulnerability. Your target is to minimize risk, to make it as minimum as possible, to diminish its effect, to minimize its existence, but you can never eliminate the risk totally. The impact. The impact is a result of an exploited vulnerability, is the effect. The impact can be deleted files, loss of information, loss of the company image, loss of privacy of the clients, loss of any of the CIA is the impact. It is the effect. It is the possible damage for the assets that being protected. The risk assessment depends on a very well-known formula. The risk is the quotient of the multiplication of threat times vulnerability times impact. Sometimes it is threat times vulnerability only without multiplying impact, but we here introduce the more complete formula. The vulnerability could be the password that is vulnerable for dictionary or exhaustive key attacks or guessing. The weak password is a vulnerability. The threat is the intruder or the attacker who is trying to guess this password, to brute force this password, to try to know what this password is. If it is weak and the threat exists, then the risk is very high. The risk resources within the system are prone for illegal access, modification, or damage by the intruder. This is the risk. If the threat is high, the vulnerability is high, the impact is high, so you have a very high risk. Sometimes you have a very high vulnerability but a low threat, so you have a low risk. Sometimes you have a very high threat, very high vulnerability but a very low impact. Nothing will happen if this password has been guessed, so the risk here is low. Risk is high when the three parameters are high: threat, vulnerability, and impact. By this, we hope that we have introduced some of the security goals and concepts. Thank you. Now let's explore together how to secure the network from the point of design, how to design a secure network from the beginning. As we can see in this design, and when we say the word design, it is a point of choice. It's something that is optional. I mean that this design we are viewing right now and we are demonstrating right now is not an obligatory design. It's an example design of a secure network. Let's explore it and let's demonstrate the things that makes it secure point by point. Let's see here that we are dividing the network here into some sections. A section that is called the internet, a section on the left that is composed of the servers of the company or the organization that needs to be protected the most, a section on the right that is called DMZ, demilitarized zone servers. This section is a problem for every security specialist because it needs two things that seems to be contradictory. It needs to be published to the internet and it needs to be protected at the same time from the internet. So this is the headache of every security specialist. This section, the DMZ section, it is usually composed of the web, the mail, and the DNS servers and other servers that needs to be published to the internet. Of course, we can see here the router that is connected the whole network to the internet and switches that are composing the local area network of the organization, and the firewall. The firewall is the only security device we have here. We do not yet understand the composition of the firewall and we do not need this at this point, but we will view here the firewall as a security device securing the communication between these sections. That's all, and that's enough for right now. And let's see how this firewall is protecting each of the sections from each other and protecting the whole organization from the internet. The goals of the network design is to publish separate mail, web, and DNS servers to the internet, to allow these servers to be published and to be viewed by the internet. These servers to work needs to be viewed by the internet, otherwise it will be useless. So you cannot claim that you have a mail or a web or a DNS server that is completely isolated from the internet through the firewall. It should be published. And another goal is to provide appropriate access for the internal network for your employees, for your internal servers to the internet. And the word appropriate here is the key word. What is the meaning of appropriate? Appropriate means that you can access the resources of the internet and you are not vulnerable to attacks. You are not susceptible to attacks from the wicked people over the internet. You should protect the internal network from external attacks. External attacks can be from the internet, and the attacks also can be internal from other people inside your network that are accidentally, intentionally, or that are wicked enough to attack your resources over the network. Let's see here that we have divided our network into three sections. The public section, which is the internet, which does not lie under my control as a security specialist. The internet is the vector of all the wicked people on the world, and it is the source of all the attacks. I have the semi-public zone, the demilitarized zone, DMZ, which contains the web server, the mail server, the DNS server, and any other server that needs to be published to the internet and at the same time to be protected from the internet attacks. And we have the third section, which is the private internal system, which is composed of the HR servers, the R&D servers, the employees, the people working in the organization, the data, the assets of the company, the workstations, the machines that needs to be connected to the internet, to surfing the internet, to send and receive email, to search the internet on Google or something, and at the same time it is the assets that needs to be preserved and kept and protected from the internet attacks. They need to be exposed to the internet, but not with the same level as the DMZ servers. HR servers and R&D servers needs to be connecting to the internet as surfing or as searching the internet, but not as servers available for the internet, such as the web and the DNS and the mail servers existing in the demilitarized zone. Let's have a look here at the placement of the firewall. The firewall here is placed to protect the sections of the network from each other. It is placed between the internal and the other networks. Let's remember that the internal is the section at the left. The other networks are the section up like the internet and the section right like the DMZ servers. So it is placed between the semi-public, which is the DMZ zone, and the private network, which is the HR and R&D servers. It protects from internet the private systems. It protects the semi-public servers from the private systems. It protects from the semi-public servers to the internet. It protects the internet from the semi-public servers. It protects the communication between each of these sections from the other sections. It protects the traffic from private systems to the internet, the traffic from private systems to the semi-public servers, the traffic from semi-public servers to the internet, and the traffic from the internet to semi-public servers. It protects each of these passes and each of these ways by inspecting the traffic going from here to there and going from here to there, from being malicious or from being a traffic from an attacker. We should here know a concept that is called defense in depth. Defense in depth means that you do not put all your eggs in one basket. You do not diminish or you do not reduce all your protecting devices into one device that is called a firewall, for example. No, you should protect the firewall itself by placing a border router with an access control list. This access control list protects the firewall from the traffic coming from the internet to the internal network. You should limit the visibility of traffic between systems. If one of our systems is compromised, and this is more probable for the systems in the DMZ zone, so you should minimize the consequences as much as possible. You should not allow the compromisation to enter your internal network. It should be blocked by the firewall protecting the traffic coming from the DMZ to the internal network. You should minimize the consequences. You should stop the propagation effect of this attack from being propagated from one of the sections to another, and this is done mainly through the firewall. Let's have a look here at a concept that is the virtual LANs, dividing one physical switch into two or more virtual switches through dividing it into virtual LANs. The VLAN is composed of one or more port inside the switch that is composing VLAN 1, and for VLAN 1 to communicate with VLAN 2, this needs a router to be inside or a layer 3 switch to be between them. So VLANs need some form of routing to tie them together for connectivity. This routing can be done via router or via layer 3 switch. VLANs can span multiple switches. One VLAN can exist on switch 1 and switch 2 and switch 3. And by the same concept, switch 1 can be composed of VLAN 1, VLAN 2, and VLAN 3. Sometimes this is limited by vendor specific switches, so all the switches needs to be Cisco switches or Huawei switches to be composed or to span multiple VLANs across, and sometimes this is not a restriction. Let's have a look at this design. We have here three switches, three physical switches at the left. Each of these switches is composed of three VLANs. One is the marketing VLAN, the other is the sales VLAN, the third is the support VLAN. And at the same time, each of these VLANs exists on the three switches. So If one of the switches is compromised, the VLAN still exists on the other switches, and at the same time, each switch is composed of 3 VLANs. So we here divided the VLANs according to the functionality of the employees. Marketing employees needs to communicate with each other much more than other employees, so they are placed inside one VLAN, and sales employees the same way, and support employees the same way. Each VLAN is a broadcast domain, so people needs to communicate much with each other are placed on the same VLAN, and people that needs to communicate less with each other are on separate VLANs that must pass through the router to be transferred from a VLAN to another. By this, we have introduced the secure design of a network. Thank you. Now let's know about the TCP/IP security and the tools used for TCP/IP security. Let's have a look again at the header of the IP protocol. This is simply the header of the IP protocol. Let's focus on the field that is called protocol inside this header. This field can take the values either 1 or 6 or 17. If the protocol field is 1, then the protocol forming this packet is the ICMP protocol. If it is 6, then the protocol forming this packet at the upper layer is the TCP protocol. If it is 7, then the protocol forming this packet at the upper layer is the UDP protocol. So you can either have in your network 1, 6 or 17 for ICMP, TCP or UDP consequently. So you have some fields to suspect inside this header. The version field. Why would you have on your network a packet that has in the version field of the IP header the number that is not equal to 4? Any number that is not equal to 4. This means that this header is not IP version 4. Why would you have it on your network? You may think of IP version 6, but IP version 6 is a completely different version of and completely different header. So it would be 128 bits IP address, for example. So if it is not equal to 4, discard this packet. If the length field is more than 5, and there are no options in this header, so this length field is not representing the actual size of this packet header, so it should be discarded. The TTL, the time to live, if it is something like 10 or less, so this packet has been passing so long time over the internet. Why would you have such packet on your network? It may be a lost packet. It has been alive for a long time over the internet without reaching the destination. Maybe it is malicious. Maybe it is an attack. Again, why would you have a packet that is not TCP or UDP or ICMP according to the protocol field in the IP header? Why would you have it on your network? If it is not 1 or 6 or 17, then discard this packet from the protocol field of it. Now think stateful. Think about fragmentation. Why do we need fragmentation? Because sometimes the MTU, the maximum transmission unit, of the sending network is greater than the MTU of the receiving network. So we need to fragment the packet, to divide it into fragments, so that the MTU of the receiving network is fixed and is suited to this packet. To do this fragmentation, you have two fields, the ID and the offset. Different fragments should have the same ID field. Different fragments should have sequence of offset fields that tells the sequence of these fragments. So what if the last fragment of this packet is never sent? The router of the network receiving these packets will keep storing fragments and more fragments till it is overflow. That's maybe what the attacker is trying to do. What if overlapping offset numbers are sent? 1, then 2, then 4, then 1 again, which means that the offset numbers or the fragmentation offset numbers are not telling a sequence of fragments. This means that it wants the router to discard all the fragments it is receiving, because it will never be able to assemble once more the fragments of the original packet. About subnetting, consider who are on the same subnet with each other. One subnet is like the virtual LAN. One subnet is one broadcast domain. One subnet should convey the people talking to each other much more than people on other subnets. So consider who are on the same subnet. Do not put the attacker and the victim on the same subnet. You are making it easier for the attacker by this way. Consider netting, network address translation, and using private addressing. Remember that each IP address starting with the number 10, for example, is a private IP address. It cannot be published to the internet with its value. It needs some form of network address translation that uses one real IP to communicate a group of private IP addresses to the internet. This form of communication using the network address translation is more secure than exposing all of the IP addresses of your network to the internet. One subnet is a broadcast domain. It is the same as VLAN. Consider this, and consider that the attacker and the victim should not be on the same broadcast domain by any means. Now let us move to the UDP header. The UDP header is simple. It is just the source port, destination port, message length, and checksum. Why would you use the UDP traffic if you don't have either audio or video traffic in your network? Why would you allow UDP to be there? Is it for the sake of DNS? DNS can be used and can work over TCP. So, is it for the sake of NTP, Network Time Protocol, or for the BOOTP protocol? Consider this. Consider having UDP header from the very beginning on your network. UDP traffic can cause flooding. UDP traffic can overflow your network. The UDP port is the same concept port as the TCP. It is either a trusted port, which is less than 1024 in number, or it is ephemeral port, which is more than 1024. Port numbers less than 1024 is for servers. Port numbers that are ephemeral, that are used more than or greater than the number 1024, are for the ordinary machines that are not servers. Look at the TCP header. We have so many fields of the TCP header. Let's focus here on the flags of the TCP header. Let's recall here that we have FTP working on port number 21, Telnet on port number 23, SMTP port number 25, DNS port number 53, HTTP port number 80. Why would you allow traffic to talk to the HTTP server on a port that is not the port number 80, or DNS server on a port that is that's not the port number 53? Why would you allow this? Why would you allow destination port number in a packet which is greater than 1024 to enter your DMZ zone? Remember that the DMZ zone is composed of servers, so all the port numbers there should be less than 1024. Why would you allow anyone to talk to your server with a port number that is greater than 1024? Let's remember the flags once again: the acknowledgement, the SYN, the reset, the push, the FIN, and the flags that are used in the TCP header. And let's recall that we have three-way handshake between the client and the server at the beginning of the communication. It is used by a SYN packet with the SYN flag put to 1 and a sequence number, for example 100. The server replies with a SYN packet and ACK packet using the number 101. Remember that this acknowledgement 101 is because that the SYN was used with 100, so it is the SYN plus 1. And remember also that the client should acknowledge the server once more with an acknowledgement number 501. Why 501? Because the SYN synchronization number that was sent was 500. These three packets are the three-way handshake at the beginning of any session between two TCP machines. And the four arrows at the bottom are the four-way handshake used for finalizing and ending and termination of the TCP communication between two TCP machines. It starts with FIN with a sequence number, and then acknowledgement with an acknowledgement number, then a FIN from the same server with a sequence number, then acknowledgement with an acknowledgement number that equals to the sequence number plus 1. This is the ordinary and the normal three-way handshake and four-way handshake at the beginning and the ending of communication between two TCP machines. Why would you have SYN plus FIN? Why would you have ACK plus FIN? Why would you have SYN plus ACK without a SYN that is preceding it? Why would you have acknowledgement without SYN plus ACK? Why would you have reset with anything else? Why would you have a weird communication of flags inside your network? Why would you have a weird communication of combination of flags that do not follow the normal communication of three-way handshake and four-way handshake? If any of these combinations exist on your network, so this says that you have malicious traffic inside your network. Now, before ending this lecture, we would like to explore a tool that is very useful for the TCP IP traffic, which is called the Engage Packet Builder. Let's here start with the installation of Engage Packet Builder. This Engage Packet Builder is a tool to craft some packets with the values that you like, with whatever values that you like to craft, with whatever headers that you like to set. This Engage Packet Builder is free and can be downloaded from the internet easily. And how it looks like. You can see here that you can set any of the TCP flags with whatever value you like to set. You can set the source IP address, the destination IP address of the packet, the type of service field, the fragmentation fields, the protocol fields with whatever values that you can like. And you can at the end send the packet with these values that you have set. It can use the TCP, the UDP, the ICMP packets. You can use whatever protocol to craft a packet and choose even the number of packets you want to set or you want to send with this configuration, and send them to whatever destination IP address you would like to set. This is very helpful in understanding the TCP IP protocol headers. Thank you. This lecture we will talk about the port scanning and the tools used in this port scanning. The port scanning is a passive way of attacking the network. When you scan for the ports, and as we know, the port and the port number is a parameter that is defined in the transport layer, in layer 4. When you scan for open ports in a certain machine, so you are scanning for a backdoor on this machine, an open port with no reason, an open port with no service installed on it that is intended to be there, is a backdoor, is a vulnerability in this machine. Port scanning is an introduction to active attacks. Port scanning itself is a breach for the confidentiality. It can be used to identify the network and draw a map of this network that is not allowed for you to know about. So you can draw a map of the servers and the machines, and you can know the operating systems working on this network, the switches and the routers, and can know many things on this network through only port scanning. You can scan the ports of each machine starting from number 1 to 65,535. And you can scan each port twice, once for TCP connections and once for UDP connections. On the market, there are several and various tools that are used for port scanning. We will here try to use the Nmap. The Nmap and its GUI version that is called ZenMap, that works over Windows because it is easier and more friendly in usage. We will try these both tools to scan and practice the port scanning over the network. This is an output of Nmap for port scanning. Let's see what this output tells us. It says that it has scanned the machine having the IP address 10.10.10.5. It scanned the ports that are less than 1024 and scanned it for its state, either it is closed or open. We can see this machine as very vulnerable. It has many open ports that can be susceptible for attacks, that can be used by attackers to compromise this machine, to remotely administrate this machine, to know many things about this machine and copy and paste files from these machines. Whatever the attacking tool can do to this machine, it can be done through these open ports that are open for no reason. Port 21, 23, 25, 79, 98, 111, 113, 513, 514, 515, and each port of them is mentioned what the service should be there. It seems that this machine is an ordinary machine, that no service is supposed to be there. And despite of this, we can see a number of open ports for no reason existing on this machine, which means that this machine is vulnerable. Vulnerable to many types of attacks. The attacker can use several software tools to intrude and log in and check in inside this machine through one of its open ports. The port scanning types. There are several types of port scanning. Either you can ping the machine to know the open ports. This is called the ping scan. Either you can simulate a null connection with this machine through sending a SYN packet and receiving SYN ACK packet and then sending back an ACK packet. This is called a full open scan, which means that this port is fully open and vulnerable to any type of connection. It has achieved the three-way handshaking completely. Or you can use the half open scan that sends SYN packets and only receives the response. In this type of scanning, you do not need to achieve the three-way handshaking completely. You can achieve it partially. You can achieve part of it by sending SYN or ACK or FIN and receive one response. No need to receive the full response of the full open scan, so that's why it is called half open scan type. We need here, before completing about port scanning, to set our rule that applies on port scanning and on any tool that can be taught here in our course. The difference between a security administrator that we aim to graduate from this course and a hacker that it is not intended to be the aim of our course at all is permission. You can make port scanning with permission as security administrator, but you cannot make port scanning without permission, because at this point you are a hacker. You can sniff the network with permission, then you are security administrator. But if you sniff the network without permission, then you are a hacker. The difference between a security administrator in any action and a hacker is getting the permission. Getting the permission from the owner of the network, from the CEO of the organization, from the administrator, from the higher level, getting it published and known that you are achieving port scanning for security reasons, and you are not a hacker that is achieving port or performing port scanning for attacking reasons. Port scanning can be used for the identification of operating system. If you scan the open ports and send some packets to a certain machine and then receive the response, you can analyze the response and compares this response against the fingerprint of the responses of Windows, or the fingerprint of the responses of Linux, or the fingerprint of the responses of Mac. Then you can say, because I have sent this machine such packet and received such response, this machine should be Windows, this machine should be Linux, this machine should be Mac. And moreover, you can identify the version of the operating system, the servers up and running on this operating system. Either this operating system is up to date or not, is patched or not. You can develop so many fingerprints for this operating system and determine many information about this operating system only by port scanning and by sending it some packets and receiving the response and analyzing it. Nmap tool is a port scanning software. It can be used on Windows and Linux. Nmap is the GUI, the graphical user interface version of Nmap. It is easy and its interface is friendly, so that it can show the output of the port scanning operation. Now here we will try to install the nmap over this machine and see how is it installed. Very simple. After the installation, you will find that you can give this nmap the IP address, the target IP address that you want to scan, or the range of IP addresses that you want to scan, and it will show you each IP address with the open ports existing on it. Each port with its state either closed or open, and then you can have an imagination or an image or an idea about how this network works and how this network is operating and the types of machines and what are the server machines, what are the client machines, what are the switches on this network, and so on. Of course, nmap stands for network map. Here it is now installing, and it is helpful that we install it together online to see the steps of the installation and the steps of the setup, the steps of running such a tool. Very easy and very simple and very friendly. It needs no experience. And it is somehow educational, that can show so many helpful output. Now the installation has ended, and now we can start using nmap. Nmap is now installed on the desktop, and here we can determine the target IP address that needs to be scanned, and here we can define the type of scan. It can be more than one type of scan, can either be ping, quick scan plus, or any type of scan. And here we will have the output machines, and here we will have the list of the open ports on each machine. So this would how the output of nmap look like. It's very easy. You just determine here the IP address of the machine that you would like to scan and start pressing scan. Then the output will start showing on here, showing the open ports on this machine. I'm here scanning the local machine, and it here showed some open ports on my machine that are used for sharing and things like this. Let's now talk about sniffing and the tools used for sniffing. The word sniffing means that you are allowed to capture data as it is transmitted over the network. Sniffing can be used by network professionals and security officers to diagnose the network issues, to identify the malicious traffic, to identify the abnormal conditions that the network may be passing through. It is used also by malicious users to capture unencrypted data, such as usernames or any transmitted data over the network. Once again, sniffing is like port scanning. The difference between sniffing by a legitimate user and sniffing by an attacker is the permission. The permission is the way that you identify yourself, either as a security officer or an attacker. Sniffing is a way of passive attacking. It breaches the confidentiality of the data. It does not cause damage, direct damage to the integrity or the availability of data, but it breaches the confidentiality. Any passive attacking is always a way or an introduction to the active attacking that follows. So, any attacker starts by sniffing, by port scanning, by reconnaissance for the network, then it moves to active attacking by damaging or by denial of services or by losing data or other ways of active attacking. TCP dump is a software that is free to download from the internet. It's a very famous and well-known sniffer software. It is used with the libpcap packet capturing library. TCP dump has also been ported to Windows as WinDump. It's a simple protocol analyzer. It captures the packets and says that this is a TCP packet, this is UDP packet, this is DNS, this is SMTP. It can analyze the protocol used to send this packet. It tells you whether a DNS packet is a query to resolve an A record, I mean a website, for example, query from a client to resolve the name of a website into an IP address, or a name server response that sends the IP address to the same client that was requesting the domain name. The TCP dump is command line interface. This is the drawback sometimes, that some people do not use it much. You can request more packet information, more information about the sniffed packet with the switches -v, -v, or -v. If you use -v, then you are requesting a certain type of information. -v, more types of information and more quantity of information about this packet. And -v says that you are requesting more and more information about this packet. Information in terms of protocol, data, source IP, destination IP, source port number, destination port number, and such information. Let's have a look at an output of the TCP dump. We can see here a packet at the first line that is identified by the timestamp ending in the number 6, then the source host name, which is ping.net, then a greater than sign, then the destination host name, which is myhost.com, followed by colon, then the type of protocol used to reply to this packet, which is ICMP, which says that it is an echo request. This is an echo request packet sent from ping.net to myhost.com using the ICMP protocol and using the don't fragment flag. The next packet is the reply. It says that myhost.com is sending ping.net ICMP echo reply with don't fragment flag. The next is log.net sending syslog.com, log.net using port 3155 and syslog.com using 514. And this type of packet, the source is log.net, the destination is syslog.com, is UDP protocol, and the size is 101 bytes. The last one is sent from send.net from the port 32938 to mail.com on port 25 with the SYN flag and with initial sequence number, that is 248631, and end sequence number 248631, and with size 0 and with the win value 8760. These are the details that can be shown over the TCP dump for a certain packet. This is the header details of both the IP and the TCP protocols for such packet. The TCP dump by default only reads the first 68 bytes. This is by default, but it can be increased. How? You can specify the switch -s followed by the number of bytes you want TCP dump to read, which can be more than 68 bytes. You can say, for example, that you can TCP dump -s 1500 if you want to capture the entire packet, because most of the TCP packets range in size of 1500 bytes. This is another example of the TCP dump output. This is a complete port communication that starts by connection establishment, SYN, ACK, and data transfer, in the box in the middle, and then connection termination fin ACK. This is a sequence of communication happening between two machines, starting by the three-way handshake at the first box, then data transfer at the middle box, and then finally connection termination by the four-way handshake at the box at the bottom. Now we can have a look at the Wireshark. Wireshark is a very well-known packet sniffer. That's a sample of the output of Wireshark. Let's analyze it together. It starts at the left by the number of the packet number 1, 2, 3, 4, and so on. Then the timestamp of the packet, the time at which the packet was captured. Then the source IP address of the packet, 10.1.50.134, for example, for the first packet, and the destination IP, which is 64.12.26.36, and then the protocol used by this packet, and then some information about this packet, some data from inside this packet. We can see here a series of packets that were captured, that were displayed by the sequence number, the timestamp, the source, the destination, the protocol, and some information. In the middle box you can see some of the data from this packet that can be displayed, and in the last box you can see more data. In the middle box the data are related to the data link layer headers, the frame, the Ethernet, and such headers. And then at the end, the bottom box, you can see some of the binary data of the included message inside this packet. Before we end, we can have a look at how Wireshark is installed and how does it work. We can here try to install the Wireshark software on this machine and try to run it together to see how simple it is and how easily it can sniff some packets from the network. The installation is very easy and very straightforward. It does not need any sort of experience. And then we can move to the usage of this Wireshark. Wireshark is free to download. Wireshark is educational, very friendly, and very very simple GUI, geographical user interface, that can be used by anyone to sniff packets from any network. Wireshark can sniff packets among different machines and show their information, source IP, destination IP, source port, destination port number, size, and some information from the message included inside this packet. Let's keep recording the installation of this software and see how it is run on any machine that can download it. This is how the installation ends, and we can now run Wireshark. Here Wireshark is recognizing the cards and the wireless cards inside the laptop. It may ask to download some updates. This time may be depending on the speed of network you have. After Wireshark runs, we can here find an image like this that says that it has captured some packets by timestamp, source IP or domain name, destination IP or domain name, protocol information, and this would be the output of Wireshark. We can use Wireshark using a filter. For example, you can apply a filter that only captures the TCP packets or that only displays the DNS packets and so on. Wireshark has so many capabilities that can be used by professionals. Thank you. Welcome to this section about firewalls and honeypots. Let's start about asking a question: why using a firewall? What is the firewall? The firewall is one of the most effective and most common security tools. It protects the internal network from users inside the external network. The internal network could be the network of your enterprise, the network of your company, the network of your bank, and the external network is the internet, the vector of all the wicked people on the world. So you must protect your internal network from the external threats, from the attacks that might arrive to your network from all over the world, from people that may be intentionally or accidentally wanting to hack or attack or break the confidentiality or integrity or availability of your data. The firewall resides between these two networks, between the internal and the external. The firewall placement is between two or more networks to offer protection for one of them against the other. It offers the protection for your internal network from the external by residing between both, by acting as a gateway that inspects all the traffic arriving to your internal network from the external network. It controls the traffic between these networks, controls by inspection, controls by allowing and negating such traffic, controls by saying that this traffic is good, it can arrive to my network, and saying this traffic is not good, so it is forbidden to enter my network. This type of control is an art because it needs the firewall to be placed in a place that is a bottleneck, that is a gate for your network to be able to inspect and control all the traffic, not just some of it, all the traffic arriving to your internal network from the external network. The firewall is a very effective tool to prevent unauthorized access, to prevent breaking confidentiality, integrity, or availability, to prevent any unauthenticated reading, writing, modification, deletion for your important data inside the network. Once again, why do we use firewalls? Let's have a look at this diagram. The firewall is at the center, and we have so many P letters inside this diagram. Every P is a probability. You can see that there is a probability of indications and warning at the right side. That is probability of indication and warning of attack before it arrives to the firewall. And so let's this indication and warning be through the border router that has, for example, an access control list and residing between the firewall and the internet. It can indicate, it can send warning, it can even detect the attack and negate it and act as a wall and act as a something that makes the arrival of this traffic forbidden inside the network. So you have a probability of early detection, you have another probability of early negation, for example by the border router residing between the firewall and the internet that can detect and negate any malicious traffic from arriving to your network. When this malicious traffic bypasses this border router, arrives at the firewall, you have another probability of detection and negation. This time it is not an early detection or negation, this time it's common detection and negation by the firewall itself. If this traffic for a reason or another bypasses the firewall, enters your network, so you have another layer of defense inside your network that resides behind the firewall. Maybe this is the personal firewall on each device. Maybe this is the antivirus residing on each device or on each machine inside your network. So you have another probability of late detection and late negation. Why do we call this late? Because the traffic has already bypassed the firewall, has entered your network, maybe has caused some damage to your machines. So this detection and this negation is late. Of course, a good security officer, a good security specialist act as an engineer to maximize the probability of early detection, early negation, of detection and negation, and minimizes the probability of late detection and late negation as much as possible. It is not a very big problem that you detect or negate late. Of course, the big problem is that you do not detect at all or you do not negate at all. But try to work on the side of early detection and early negation, of detection and negation in common, but try to let it minimized, that you detect and negate late, that you depend on the host defense machines, the host firewall, the host antivirus to detect and negate the attacks arriving to your network. The benefits of the firewall are so many, because the firewall protects internal and external systems from your attack. The internal systems is the internal servers you have. External systems is the servers also you have that need to be broadcasted over the internet. Remember, we have the web server, the mail server, the DNS server needs to be protected and needs also to be exposed to the internet at the same side to act its functionality, because it needs to be a DNS server to receive queries and send responses, so it should be exposed to the internet. The firewall filters the communication based on content. It says that this packet is okay, it can pass. This packet is not okay, so it cannot pass. This type of filtering is based on the content, and we here mean by the content the header and the body of the packet itself. Based on the header, you can filter some communications. Based on the body of the packets, you can filter some other communications. And in all, the firewall should be able to detect and read to the most level of the packet to be able to filter the communication based on the content residing on it, either the header or the body. The firewall can perform the NAT by itself, the network address translation. It can act as the device intermediate between the internal network and the external internet. The device intermediate between the private IP addresses starting by 10 dot, for example, inside your internal network, and the external internet, which you must be represented on it through one real IP address. Some firewalls can perform this network address translation. This network address translation by itself is a means of protection, is a means of security. It can prevent the direct communication between external machines on the internet and internal machines on your network. This is some form of protection that saves a lot of effort by itself from letting the attacker communicate directly to your machine. The firewall has a very good advantage and a very good feature. It has the advantage and the feature of logging. Logging means recording. Logging means writing every packet that it has denied in its log file, which aids in intrusion detection, which aids to know who is the attacker through the source IP address of this denied packet. Who is the attacker and how is he attacking my network through the port number, for example, on this denied packet. And it is very helpful, this logging, in forensics, in going to the court and saying that this man, this attacker or this network is trying to breach the confidentiality or the integrity or the availability of my network. So it's very helpful in finding evidence, in recording evidence, and in detecting the attackers and asking for some help in defending them from the authorities. There are some shortcomings of the firewalls, and we insist on mentioning them because some of the security specialists think that the firewall is everything. Once you have placed your firewall, you are protected. This is not true. Firewall is never an everything, and there is not a single technique in security that is everything. Everything means everything. Everything means that you use all the possible techniques: encryption, passwords, antiviruses, firewalls, IDSs, IPSs, every possible technique for protection to protect your network and to protect your machines. So there are some shortcomings of firewalls that attacks at the application layer, at layer 7, layer 6, layer 5, or at layer 7 may sneak through because the firewall cannot detect the attacks inside the content body of the packet. If I will apply the rule on the firewall that it sneaks every bit and byte in the packet, it would lead to very slow performance of the network, because every packet will arrive needs to be inspected fully before passing inside the network. This would lead to a very slow network, and that's something that I do not need to do. So what's the alternative is to let the firewall only expect the header. That would be fine and leads to fast network and at the same time protected network. Some connections may bypass the firewall, like the dial-up connection from the telephone line, the virtual private network connections, the VPN, or the connections from my extranet. These can be some connections that bypassing the firewall and the firewall rules are not applied on them. Some organizations may let down their guard on other security areas, such as using passwords, patches, encryption. They let down their guards because they think firewall is enough. The firewall is there, it is expensive, it's working, it says that everything is good, so it is enough, so we can use weak passwords. We do not need to patch our systems, we do not need to apply encryption algorithms, and this is not true. If you apply such techniques like strong passwords, patching and updating the operating systems of the machines using encryption whenever possible, you will have better security and you will have much more better traffic inside your network than what would the firewall only lead to. Where to place the firewall? We have seen in previous lecture a placement of the firewall, single firewall between the internal network, the demilitarized zone, and the external network, which is the internet. Here we can see another example of the firewall placement. You can place two firewalls, one firewall between the internet and the demilitarized zone where your web server resides, another firewall between the demilitarized zone and your internal network where your data and precious servers resides. So you can have two firewalls acting as two layers of protection, acting as two layers of filtering the communications between the internet where all the evil lies and between your internal network where all the precious things and all the data and all your employees are working and all the things that you care for are residing. You now have two layers of protection, two layers of inspection for the traffic arriving from the internet to your internal network, and one of them is filtering the communications arriving to your demilitarized zone according to some rules. The other is filtering the communications arriving from the internet and from the demilitarized zone into your internal network according to other rules. This would lead to some form of security to your internal network from external attacks. Thank you. Hello, and let's talk here about the rules of the firewalls and how are they working. What do we mean by a rule in the firewall? The rule is the line that specifies for the firewall what to do with the packet. What is the decision that the firewall should take for an inspected packet or inspected series of packets in the traffic? The firewall, once established and once placed inside a network, needs to know what to allow and what to prevent, what type of traffic is good and what type of traffic is not good, what is wanted and what is unwanted. Not every traffic is good for good. Not every traffic is good here and good there. What might be good for a certain network might be bad for another. What might be bad for a certain network might be allowed for another. There is no good traffic for good. There is no bad traffic for good. Every organization and every security specialist responsible for the firewall should determine what is good and what is bad for his network according to the assets, according to the threats, according to the vulnerabilities, according to the functionality of this organization. Either it is educational, training, financial organization, or military, or something that is belonging to the security authority. Let's say that the firewall rule controls the decision of the firewall on inspected traffic, either to accept this traffic or to reject it, to allow it inside my network or to ban it from inside my network. The rule controls what happens when a packet does not match an existing rule. Which rule? This is exactly the default rule. By default, the firewall is either accepting traffic or rejecting traffic. If you by default will accept all traffic, then you should specify through the rules configuring this firewall what traffic to reject. And vice versa, if you will reject all the traffic, then you should specify through the rules of your firewall what traffic to accept. If you choose your default rule to be denied, then your firewall will be more restrictive, will be more cautious and more sensitive to any traffic. It will prevent all the traffic from entering your network and allow the traffic that are matching the rules below, the rules configuring this firewall. If you choose to be default allow as the default rule, then you will be more permissive, you will be more flexible. Then your firewall will accept all the traffic except what is matching the rules that are saying which packets and which traffic to reject. The default rule and its choice is very important. Why? Because the effect of the default rule is very efficient and very obvious on your security posture. If you choose to be default deny, this helps protect against previously unknown attacks or vulnerabilities. What does this mean? There are some types of attacks that are called zero-day attacks or zero-day vulnerabilities. These attacks that appeared today, that were invented today, that are striking the world today. So we don't know exactly as security officers the nature, the type of this attack, and what are the criteria we should put inside the configuration of the firewall to protect from this attack. So if you choose your firewall to be default deny, to be denying by default any traffic, then this would be very helpful for the zero-day attacks and zero-day vulnerabilities. Then you will be safe from this point of view. But it is not a golden rule to be default allow, or it is not a golden rule to be default deny. Why? I can give you an advice to be default allow, or your rule to be default allow if your organization is educational or training organization, because it needs to be flexible. Students inside your organization needs to be exposed to the traffic, to all the websites, to all the world on the internet, and needs to be restricted only to some things that are 100% evil, 100% unwanted. If your organization is security authority or a bank, then every attack would be of great damage, would be of great danger. So you would prefer your default rule to be default deny, to be protected from any unknown attack, from zero-day attacks and vulnerabilities, and to allow only what is good by 100%, to allow only what you are sure that it would not cause any damage, because any strike or any damage may be of great harm and of great impact on your network. Let's have an example of the firewall rules. An example here, it is a simple example written in the C code or in a code of the programming language that is called C, or you do not need to know C or Java or any programming language to understand this. It's very simple. It says that if the source IP equals 163.121.25.10 and the destination IP equals 163.121.11.12, these are inspected inside the header of the packet, in addition to the source port and destination port. If the source port equals 2050, the destination port equals 80, then accept this packet. So the firewall would have now a rule saying that if the source IP equals so and so, destination IP equals so and so, source port equals so and so, and destination port equals so and so, then you can accept this packet, allow it to enter from your external network to your internal network. Another rule might be contradicting this. You might think that if the source IP equals so and so, destination IP equals so and so, source port equals so and so, and destination ports equals so and so, then reject this packet. Do not allow this packet to enter from your external network to your internal network. These are two examples for, of course, they are not on the same firewall. Either this or that would exist on the firewall. These are two examples of a firewall rule to demonstrate what a rule means. It's a condition and an action, a criteria and a decision. If so and so, then take such decision. If so and so, then take the other decision. Let's here say that the action of the firewall is responsible of two types of traffic. The ingress traffic, which is the traffic that is entering your network. That is called the incoming traffic. That is entering your network coming from the internet. And this traffic may contain malicious and evil and unwanted packets, so you are responsible to allow only addresses that do not belong to the protected net or reserved range are allowed in onto the protected net, which means that it is unlogic that you allow a packet coming from the internet having a source IP belongs to your protected net. How come? Is it coming from outside or coming from inside? If it is coming from outside, why does it have the source IP address as an IP address belonging to the range of my protected net? It here should be malicious. It here should be something fake, something unreal, and something suspicious that should be banned from the network and should be avoided from our network and should allow and should be rejected and configure the firewall to reject it. The egress traffic, it's the outgoing traffic, and some security officers fall in a very big mistake. I'm responsible only, he says to himself that I'm responsible only of the ingress traffic, which is more important. No, the egress traffic is as important as the ingress. They are equally important. You are responsible as a security officer of protecting others from the intentional or accidental attacks that are happening inside your network and may affect the outside of your network. You should protect also your machines from the traffic generated from them going to the outside of the network. It could claim that your machines are infected, generating unwanted traffic, flooding the network with unwanted traffic, and it can say that you are infected by a virus or a worm. So for the egress or the outgoing traffic, you can say that only addresses that belong to the protected network are allowed out onto the internet. It has no meaning that you say I will allow this packet to get outside from my network to the internet and its source IP does not belong to my range. Why would you allow this? You may cause some damage, you may cause some problem to the outside of the network, or you may think that your inside machines are infected and are generated fake packets and fake traffic and unwanted traffic that you need to clean them, or you need to think again of the security posture of your network. This is how the firewall is in action and how the firewall is acting inside your network to protect the inside network from outside attackers and the outside network from the inside attackers. Let's have a look at the managed access. If we have a network that is composed of my protected net and the internet, you should think of allowing only connections on port 25 of type TCP to your mail servers. Allow connections only of type TCP and port number 80 as destination port to your web server. Allow connections either TCP or UDP and port number 53 to your DNS server. These are the only connections allowed into your demilitarized zone. Other connections can be banned and can be denied and rejected by the firewall if inspected arriving from the internet to your protected net. Thank you. Now let's talk about the filtering of the firewalls and classifying firewalls according to its filtering types. The packet filter firewalls is the first type of firewall we are going to explain. This type of firewall is low-end firewalls. It is not very secure. It does not offer the maximum security, but it offers the maximum speed. It's very fast. It can enhance the security, it can make it better, because it relies on the destination port on taking the decision about the traffic, on filtering the traffic. As you can see in the diagram, the firewall investigates the UDP dest port, which is the field that contains the destination port number of this UDP packet. According to this value of this field, the firewall decides whether to accept this packet or reject it, whether to allow it into your network or to ban it from your network. So this type of firewall checks only the header, checks only some fields related to the source IP, destination IP, source port number, destination port number, and takes the decision whether to accept this packet or reject this packet according to these fields only. So the data content inside this packet passes unchecked. The data content may contain some malicious code, may be dangerous, may be unwanted traffic. So this type of firewall will be susceptible to such types of attacks that depend on the content, because the content here passes unchecked. So let's have a look also at the NAT firewall, the Network Address Translation Firewall. This diagram describes how the NAT happens, how the network address translation happens. At the middle we have the NAT device. This device is facing the internet with an interface card that has a real IP address 128.38.1.1, and that has another, this device has another NIC card, network interface card, with a virtual IP address that is 172.16.1.1. Now this device has two faces, one with real IP facing the internet, another one with virtual IP facing the intranet. This intranet is your internal network, and it is filled with virtual IP addresses. It is filled with IP addresses that are not real. The machines having IP addresses 172.16.1.10 or 20 or 30 or 40 are your machines inside your network. All of these machines are seen by the internet as machines having the IP address 128.38.1.1. What is the advantage of this? Any machine on the internet would not be able to have direct access to any of the internal machines with 172.16.1.10, because this netting hides the internal network to be accessed directly from any machine on the internet. This NAT device acts as a firewall. It provides a single address outside our protected network, so it protects your internal network from any direct communication that could be malicious. The NAT device can contain a firewall with certain rules to allow some types of communication and to ban and to reject other types of communications to be done or to be communicated with your internal machines. This is the other type of firewalls. So we have packet filtering firewalls, NAT firewalls, and we have the third type, that is proxy firewalls. Proxy firewalls maintain complete TCP connection state and sequencing through two connections. The proxy firewall makes the connection itself to the destination server and makes another separate connection to the user inside your internal network. So it makes two separate communications, and in between these two separate communications it investigates the traffic arriving from the outside network to the inside network through a process table that manages to keep the connections straight, that gives the user the feeling that he is connecting to the internet directly through this process table. We have the opportunity to inspect every single bit and byte in the arriving traffic to this firewall and to take decision either to accept this packet, either to allow this traffic or to reject this traffic. This proxy firewall is the most secure form of the firewall, but it has the disadvantage of slower performance because it inspects every single packet and every single field inside this packet to take the decision either to allow or to reject. We had the two extremes, the packet filtering firewalls, which is very fast but low performance, the proxy firewall, which is very slow but high performance. We can have something intermediate, which is called the stateful inspection. It inspects traffic by group of packets, not by each single packet. It inspects packets maybe 5 by 5 or 10 by 10. It has dedicated proxies actually running the protocol, so the user machine inside your internal network is not in a direct communication with your server on the internet. So this stateful inspection cannot be fooled by using an unexpected destination port. It cannot be fooled by one malicious packet or a series of malicious packets. So this stateful inspection in the firewall allows it to detect the attack that is composed of a series of packets. An attack that is composed of a series of packets can pass through the packet filtering firewall because each packet in this series is good in itself. But by stateful inspection, you can discover that this packet, in addition to the following one, are forming an attack. Stateful inspection cannot be fooled by such type of attack. Stateful inspection provides a balance between packet filtering and proxies. It is not so slow, it is not so fast, and it is not so poor performance, and it is not the best performance, but it is an acceptable performance and is a good choice in most of the cases. We have also here the personal firewalls, the firewalls that are not separating two networks but are set on your machine as Windows or Unix machine to protect your machine from the network that it is connected to, from the traffic arriving to it from the network. The personal firewall can be just the packet filtering like the IP tables commands on the Linux, and can be stateful firewalls on Unix like Linux NetFilter and IPF and OpenBSDPF. The personal firewall can be the Windows firewall built inside any Windows machine right now, and can also be an application control firewall designed by a third-party program, just such as Zone Alarm or any other program, any other third-party company that has built or designed a firewall to be established and set up on the user machine to protect it from any malicious network connection. To summarize the firewalls, it can be a primary intrusion detection sensor. It can be your primary and first wall of defense. Firewalls provide a mix of capabilities to meet requirements. You can use packet filters in sometimes, stateful inspection at other times, application gateways at other times, proxy firewalls at maybe your border network, and packet filters inside your internal network, or on the contrary, use packet filters on the border and proxy inspections at the inside network. You can use a mixture of the capabilities of the firewalls and detect and design the security required by each of the firewalls installed on your network. Thank you. The honeypots. The honeypots is a advanced concept in the world of security that we need to know about. What is a honeypot? A honeypot is a trap, is a decoy machine, is something that is unreal, that is made inside your network to attract attackers. The goal of the presence of honeypot is to know more about the attacker, his identity, his way of attacking, to get some more evidence from him, to get some more forensics about him, and to be able to know him more, and consequently to be able to protect yourself in a better way from him. The honeypot can be a host trap or a network trap. For example, you can set a host inside your network to be a honeypot by running real services on a sacrificial computer or simulated instrumented services. For example, you can run the web servers on a computer that is not really containing web pages or containing HTML content, which means that it is a fake web server with empty content. Why do you do so? To attract attackers targeting your real web server to this server, and then to know more about them, to know how are they attacking, their IP addresses, their malicious software they are using, their techniques of attack, and to get evidence and forensics against them, to be able to face them in the court, for example, and to be able to know more and configure your defense devices more to be more defensive against them. The honeypot can be a network trap, a full network of fake machines that the intruder think they found a vulnerable organization, not only a machine. A vulnerable organization containing a fake web server, DNS server, mail server, and other machines. Some of the honeypot softwares or systems can do so, can convince the attacker that he has found a vulnerable organization and keep attacking him and keep collecting information about him. Then he would fall in this trap to be faced by his cyber crimes and by his attacks he's trying to do. Once more, the honeypot is a decoy. If a real machine comes hot or becomes a very hot target for the attackers, becomes attacked so many times per day or per week, you can think of changing the IP address and domain name of this real machine and put in a honeypot instead. Put in a fake machine acting the same service instead, but with no content. For example, a fake web server or something like this. So you have protected your machine, your real machine, by changing the IP address and name, and you have attracted the attacker to know more about this malicious software or this person trying to attack your network through this decoy machine or through this honeypot you have set up. DNS, mail servers, web servers make great honeypots on their unused ports. How you can do so? You can monitor the unused ports of the web server, the port numbers that are other than port number 80 can be monitored for persons who are trying to contact this web server on port number 20 or 21, for example. For example, you can know more about these attackers and why are they attacking this machine specifically on a port number that has no service instrumented on it, that has no service, real service on this port. And you can know their IP, their way of attacking, and then you can build a defensive system that is more efficient in facing them. When to use the honeypot? The firewall properly configured stops any type of attack trying to attack a machine on a port number that is not supposed to be active. But you cannot learn anything about the attacker at this time. So you can use the honeypot to attract the attacker to know more information about him, which might be fruitful and might be beneficial to build a better defensive system against his attacks. Why to use the honeypots? If you have mail servers or web servers or DNS servers that attract most of the fire on the internet, you can have their unused ports instrumented, as we have said. The end result could be to slow down the pace of the attacker and increase the arrests of the attacker. The honeypot is an advanced technique, and this is a very important sentence. This is a very important thing to keep in mind. The honeypot is an advanced technique. Either you set up a honeypot and you are 100% sure that it is fruitful and beneficial, or you give up the idea. You do not set up this honeypot at all. Do everything else before setting up the honeypot. Establish a firewall, configure it correctly, use encryption, use passwords, patch your systems, upgrade your operating systems, and do everything else. The best way to capture new worms for analysis is using a honeypot. You can have the risk of having attacker to use the honeypot if they break the controls. The honeypot is supposed to be a weak machine to attract attackers. So think of the risk you are having when setting up a honeypot. If it is not 100% safe, give up the idea and think of something else as a defensive technique other than the honeypot. Some of the well-known honeypots or honeypot products over history has been the Deception Toolkit, the Semantic Decoy Server, previously named as Mantrap, the HoneyNet or the HoneyD. These were some softwares intended to be honeypots that were installed on systems and sometimes installed on a full network to convince the attacker that there is a vulnerable machine or a vulnerable network here. Come and try your attacking techniques, and then you can collect evidence and you can know more about his attacking techniques. Thank you. Now let's know something about bypassing the firewalls and explore the Windows firewalls existing on each Windows machines and how can it be configured and how does it work. The peer-to-peer file sharing programs, the programs that are called torrent sometimes, the programs that are like Kazaa, iMesh and something like these programs may introduce security weaknesses inside your machine. It's a hole in a firewall because they are sometimes dynamic in using their port number, so the firewall cannot catch every traffic coming out from them or coming to them. They can change the port number they are communicating, and at the same time they can transfer data from machine inside the network to the internet, other machine in the internet. These programs can transfer any type of files: PDF files, MP3 files, MP4 files, audio files, video files, any type files that are existing on your hard disk inside the network to the internet. So you are giving away network information. You are giving away data from your machine to other machines. Sometimes you say to yourself that I'm giving away the data I want to do and I want to give away. This is not always correct. Sometimes such programs give away information accidentally that you did not mean to give away. These programs are most of the time security drawback or security hole inside your network, and they are sometimes not good for the security posture inside your defense systems, and they are a problem for your firewall facing all the time. So you are establishing a firewall, configuring firewall, and at the same time fighting it with such programs for file sharing, to share songs and movies and maybe PDF files or something like this. Anyhow, there is nothing that is good for all and there is nothing that is evil for all. If you need these programs, if you are aware of the type of ports and aware of the mechanisms they are using, and you are trusting them for the way they work, so welcome, you can use them. If it is not required that you transfer files through such ways, so take care that these programs may bypass your firewall and may be a security hole inside your organization. The modems. Take care of something as a security officer. The more you are restrictive, the more restrictive the site firewall policy, the more likely the employees will use modems. They will feel the firewall is fighting them. They will feel the firewall is standing between them and the internet, is forbidding or is preventing them from accessing so much websites that they need to do their work. So the more restrictive you do, the more slow your network is, the more likely your employees will use the ISP modem, the USB modem, to contact their internet service providers, to be connected to the internet through their ISPs and without passing through your firewall, to get more speed, maybe, to access more programs, maybe. So let's remember once again the balance between the access and the security. If you are restrictive, very restrictive, then it is more likely that your employees use these modems. If you achieve the balance, then it is less likely that your employees think of using these USB modems. Let's have now a look at the Windows firewall. This is how the Windows firewall looks. Let's say the configuration of the Windows firewalls and see here that you have some inbound rules for the incoming traffic and some outbound rules for the outgoing traffic. Let's see here what are the types of programs that can send data from your machine, and here what are the type of programs that your machine can receive data from. You can at any point of time configure a new rule for a program or a port number or a predefined rule or a custom rule, and then think of the type of rule that you are trying to configure. For example, if it is a port, so is it TCP port or UDP port? What are the type of the port you want to configure the rule for? And then you configure it, and what is the action that you want to be taken? What is the profile that you will give to this rule, and what is the name that you will give to this rule to be added to the rules of the Windows firewall? These are the rules that the Windows firewall are using on my machine here. These are the rules that the Windows firewall are applying to control the traffic coming out from my machine and arriving to my machine. If you double click on any of these rules, you will get more information about the type of the rule, the name, a brief text or a brief description about how the rule works, what type of connection does it allow, and the port numbers and the type of control it is applying on your machine. At a certain point of time, you can turn on or turn off your Windows firewall. If you turn off your Windows firewall, you should be aware that your machine is now fully exposed to the internet. Any type of communication can take place between machines on the internet and your machine, and then you are exposed to so many attackers on the internet that can attack your machine. It is always advised that you turn on your Windows firewall. It is always advised that you keep these radio buttons on. Never turn off your Windows firewall unless, and it is mentioned here that it is not recommended unless you are completely aware of what you are trying to do. You can also use some third-party programs to install more firewalls on your machine, just like the Zone Alarm or any third-party software that can act as personal firewall on your machine. You can explore the monitoring that your firewall is executing right now. You can explore the connection security rules. You can filter your rules inbound and outbound either by profile or by state or by group. You will have a lot of rules, as you can see on your Windows firewall. You do not need to understand every word and every rule, but generally I think by now you have known a brief idea, a broad idea about these rules, and you can take your time to explore it line by line and try to ask yourself, why this rule here? What is it doing and what do I gain from it? Is it necessary? Do I have to enable it or do I need to disable it for some times? Thank you. Welcome to the intrusion detection and intrusion prevention section. Let's start by defining what is IDS, Intrusion Detection System. What is intrusion detection? Intrusion detection can be host-based or network-based. Host-based is named HIDS, Host-Based Intrusion Detection System, which means that intrusion detection on the host level, detecting the intrusion that may happen to the machines level, to the operating system level. Network-based is in detecting the intrusion on the network level, on the traffic level, and that is what we are concerned about more. The intrusion detection reports attacks against monitored systems or networks. And here let us focus on the word reports. It does not defend, it does not take action, it just reports the attacks through generating alerts against the monitored systems that can be hosts, that can be machines, servers, and networks composed of several machines and composed of connecting devices, switches, routers, and such things. The intrusion detection system is an alarm system. It reports and produces and generates alerts. It's a mature technology that has significant utilization. It is an advanced technology that had been recently invading and spreading all over the world of cybersecurity. The IDS is not a replacement for the following. It's not a replacement for the firewall. It's not a replacement for strong security policies inside an organization. It's not a replacement for system hardening through upgrading the operating system and patching the operating system with the updates produced over the websites and the servers dedicated for such purpose. It is not a replacement for other defense in depth, DID techniques. It is part of the defense in depth, but not a total replacement for the defense in depth techniques. It's not a low maintenance tool. It requires trained analysts. It requires technicians and security engineers that takes care of the alerts being generated and act accordingly. It is not an inexpensive tool. It is expensive. It is expensive in terms of maintenance, in terms of taking care of, in terms of sometimes price if it is an appliance. It's expensive and advanced technology that you should think before placing in your system security. It's not a silver bullet. It is not a replacement for all other techniques, and nothing in security is a replacement for another thing. You should apply the IDS, apply the firewall, apply strong policies, apply system hardening, timely patch your systems, and all in all focus on building a defense in depth technique to be safe and to feel secure in the cyber world. Let's move to the IDS in action. Let's suppose that an attacker used Nmap or ZenMap to scan a host for open ports. And let's recall here that an open port for no reason is a vulnerability inside the system. If the attacker managed to scan and find the open ports already, the victim may use the Wireshark, the sniffer we have talked about before, to log the attacker's activity and to log the attacker's IP address. This is something that we need to know about the attacker. The IDS tool used, which is here the Wireshark, presented data to an analyst to take action. It is just a data presenter. It is just an alarm system, just something that said that so and so happened at 7 or 8 o'clock or something like this. It says that the attacker whose IP address is so and so has logged to your system at the time so and so, which means that you should act according to this alert. You should harden your system according to this alert. Alerts can be helpful to stop further advance of the attackers and to log some forensics against the attacker, to know more about the attacker and to act accordingly. The types of alerts. Alerts are generated from events of interest. Let's here imagine that the life of a security specialist is filled of reading events. Events that are good and events that are says that something has went wrong. Events that says that it is okay and events that says that something is not okay. So among the events that are generated from the antivirus, from the IDS, from the firewall, from the several security devices, we are looking for some events of interest, some events that says that we should take action, we should take care of this event. This event is interesting and needs intrusion from our side, not intrusion, not the bad intrusion of attackers, but needs to be addressed by our side. Rules specify which events generate alerts. Of course, the smart rules that you apply to the IDS says what are the alerts that should be generated according to what events. And we have several types of alerts. We have several types of alerts that can be generated and can be classified according to the importance and the priority of such event. So you specify rules, you set rules that says that this event, if happened, send me an alert, show me an alert. And this event, if happened, it does not need you as an IDS system to show an alert. This event is ordinary and this event is suspicious. What are the types of events? We have 4 types of events, and this is a very important definition that we should know. We have the true positive events, which means that the IDS has generated an alert, and this alert is true positive, and this alert is significant for an attack. We are always looking for true things, not false things, because we have true negative. True negative means that there is no alert, and really at the same time there is no attack. So both true positive and true negative needs to be maximized. We hope and we dream that every alerts are true positive and true negative, but unfortunately we have the false positive. False positive means that there is an alert that is generated and at the same time it does not signify real attack. It says that the door is just open or the window is just open and there is no attack. False positive means that the IDS system has screamed, has produced an alert for nothing, for no important reason. False negative means that the IDS system is sleeping while we are hacked. It is not generating any alerts, but at the same time the attacker is here and he is on our system. This is the two parts that are representing false positive and false negative we need to minimize. We are dreaming of having all true positive and all true negative alerts. You should consider which one is the worst to have on your network, because you may think that true negative is good and also false negative is not harmful, is not so harmful for my system. I can afford having some false negative, but and I cannot afford having a lot of false positive alerts. I do not have technicians and analysts enough to read all the false positive alerts I have. On the other hand, you may think the other way. You may say, I cannot afford to have false negative. I cannot afford having an attack on my system while the IDS is not generating any alert. It's a matter of your choice, but your decision should depend on how serious your attacks and how serious and how important are your information and are your assets to your system. The alerts can be just a line on the screen showing up on the screen that the IP address so and so has attacked your system, or a beep from the IDS server, or an email sent by the IDS server to the email address of the security specialist, or an SMS from the IDS system through the SIM card in the IDS system to the mobile phone of the security specialist, or a phone call, a real phone call at midnight you receive from the IDS system with a certain ring that says that there is an attack. Wake up, we are under attack. An important type of IDSs is the IDSs used by the HR, the human resources. It is a content monitoring system. The human resources inside the organization may use an IDS to monitor the content, to ethically spy on the employees, to know what they are exchanging, what type of information are they exchanging between each other, what type of chat, what type of emails, what type of information is passing between them. The HR IDS may monitor the web pages they are visiting, the instant messaging they are exchanging, the emails they are exchanging, and can monitor any confidential information leakage from the organization to the outside of the network. It helps to address any inside attacker who is trying to spread the confidential information of the organization to the internet, or sending inappropriate emails, or visiting unwanted websites, or sending chat messages that are unethical, or things like this. This needs investigation by the human resources department from the organization to take decision accordingly against this employee. It identifies, this IDS identifies violations against the company acceptable use policy. When you are given resources inside your company, this resources has an acceptable use policy. You are given an email address to use only for business. If you use this email address to send friendly emails, or to using the bandwidth of the company or the organization to visit websites and to visit websites for your own amusement and downloading songs and movies to watch, so you are violating the policy of acceptable use of the company, and this may need HR investigation. Thank you. Let's focus now on the Network Intrusion Detection System, the NIDS. The Network Intrusion Detection System is deployed as a passive sensor at the network aggregation points, at the points where all the traffic passes. For example, it can be set on or behind directly the border router, or directly behind the firewall. It can capture traffic like a sniffer and then compares this traffic to certain signatures. Does this traffic contain so and so as a signature? If yes, then generate an alert. This is how the Network Intrusion Detection System works. It detects events of interest on the network. And remember, we have a lot of events shown by a sniffer, shown by an antivirus, shown by a firewall, but we are interested in the events of interest on the network that shows something suspicious, something that could lead to an incident. So it uses the analysis of the signature of the anomaly traffic of application or protocol to say that this traffic is an event of interest and to generate an alert signifying that something wrong is going on, something that needs to be taken care of by the security administrator. The signature analysis is depending on the rules that indicating criteria in packet that represent the event of interest. Rules are applied to packets as they are received by the IDS. Alerts are created when matches are found in the following issues. Either the protocol, for example, we have caught a traffic that is UDP protocol, and this UDP protocol is unwanted on our network, so let's generate an alert. The IP address, we have caught a traffic that is from unwanted IP address or targeting unwanted port number, targeting payload content or containing payload content that is unwanted or that is not allowed inside the network. String matching, even the content itself of the web page can contain some words that are not allowed to enter our network. The traffic flow analysis, for example, it is not common or it is not natural in some organizations to find that the utilization of the bandwidth is 99% at 2 o'clock in the morning. This is not normal. This shows that something abnormal is happening, because at 2 o'clock in the morning there is no one inside the organization. So why is there traffic usage reaching 90% of our bandwidth at this time? Is there a server running? Maybe, or maybe not. So we should analyze such situation to reach a conclusion and to define what is normal and what is not. Some flags in protocol headers, such as the SYN plus FIN, ACK plus FIN in the TCP header, some flags that cannot be combined with each other in normal traffic or in healthy traffic, signifies that something wrong is going on inside this traffic that are flowing through the IDS. What will the IDS do? Generate an alert. Anomaly analysis flags anomalous condition in traffic on the network. For example, the traffic is fluctuating from 80% to 70% to 10% to 20%. This is not normal. Unexpected conditions are identified as suspicious. We need to know what normal is. We should know what is the normal conditions to say that we had some abnormal conditions on our network, and what is normal here can be abnormal there. What is normal for a hospital can be abnormal for a bank. The network here differs from the network there. The network here may be working 24/7. The network there is working only on the working hours inside the bank. So we need to know what is normal and what is acceptable for each network, and we need to know what can be flagged as suspicious. It is usually based on good traffic as baseline for future analysis. This anomaly analysis depends on targeting the network and observing the network for some time when we are sure that this traffic is good traffic and running at good times of the network at certain period of time. Then we set this as baseline. Usually an inclusive detection method. This is a very important condition that happens when you find that the traffic of the network itself has a problem, that the behavior of the traffic has a problem. So this is an inclusive detection method to use the network intrusion detection system to alert you against this type of abnormal condition. You can use the application protocol analysis. IDS has understanding of the logic for a specific application or protocol, understands how does it work and what protocol does it use and what headers does it use and what signals does it send. So it can use the application protocol analysis. Any protocol activity that is not known as normal is flagged. It is difficult. This type of analysis is difficult to implement because few protocol implementations are standard, and so many protocols that are used over the network are not standard. So you cannot define what is normal, what is abnormal due to the standard, because there is no standard to compare with. So you need to train your IDS system to know what is normal and what is abnormal for such protocol. It is usually an exclusive also detection method. The IDS is exclusive detection method for application and protocol analysis. By this, we hope that we have introduced some overview for the NIDS, Network Intrusion Detection System. Thank you. Now it's time to know about some of the challenges that will face the NIS, that will face the security administrator who will think of deploying the network intrusion detection system. One of the challenges is how to include deployment and access limitations to this network intrusion detection system. How would you face the shortage that you may face in the storage, in the processing of the machine running the network intrusion detection system, because it is not coping with all the size of the traffic it is receiving. Maybe the storage is not enough, the processing is not enough. So this would be a problem, and this would be something that would limit the performance of this network intrusion detection system. How would you analyze the encrypted traffic? How would you cope with some traffic that needs to be decrypted before being analyzed and before generating alerts related to it? Encrypted traffic that is of unknown or that is of hard decrypting protocol leads to poor performance and slow performance for the network intrusion detection system. How would you deal with the quantity versus the quality of signatures? Would you generate an alert for certain quantity of signatures or for some quality of signatures that signifies an attack? Would you generate an alert for 10 signatures for a certain type of traffic, or would you generate an attack for a certain one that is signifying a problem, a serious problem for such type of attack? You can do so and you can do so. You can follow this way or follow that way. It's a point of design. It's a point of your choice. So that's why we are presenting here some concepts that you can use in your design in deploying and using this technology that is used, that is called network intrusion detection system. It is very costly for proper management. It needs someone who dedicates his time to analyze the traffic, analyze the alerts, take care of what it is generating, and know how to react and know how to move and how to face the problems that are generated through the NIDS alerts. So we have deployment challenges, including also the access limitations. Sometimes over a switched network it is hard to generate access or to grant access for the NIDS to all of the traffic, because the switch is separate collision domains. So you cannot sniff over the switch, and a NIDS device that is deployed over the switch cannot have access to all of the traffic. So where to put this NIDS to be accessible for all the traffic and to reach all the traffic, to be easy for it to analyze? The deployment of this NIDS need trained people, trained security specialists to be able to deploy this NIDS, to set up this NIDS, to configure the rules, to specify what are the type of alerts for each rule, to categorize the alerts, to detect the events of interest, to know when do we need this NIDS device to scream and to say there is a big problem, and when do we need this NIDS to just show a line on the screen saying that we have a problem or we have something that is wrong. So the deployment and access limitations are something that composes a challenge facing this NIDS. So there are a lot of challenges or a lot of things that needs to be thought of and needs to be determined if you are going to use the NIDS technology in your network. You should think either to use the deep inspection or the shallow inspection. the shallow inspection is fast but provides little fidelity because it examines only the header information of each packet and examines some limited payload data, maybe the first 65 bytes or something like this. So it is fast because the examination is for small portion of the packet, only the header, but the security is somehow of little fidelity because the attack may reside in the data, not the payload data, I mean not the header. The attack may be sneaky, may be away of this shallow inspection, and may reach your network after such inspection. So if you are interested about speed, then you should think of shallow inspection. But if you are interested about fidelity, you should think of deep inspection. Deep inspection is slow. It requires stateful tracking of data. It stores and buffers the data by group, 1 or 2 or 3 packets by group, and then inspects them as a group, all fields including variable length fields, which is hard to do, and then takes the decision either to generate an alert for all of them or to let them pass without an alert, to detect them as malicious traffic or detect them as normal traffic. So this deep inspection takes time and consumes resources, but it leads to higher fidelity in the security. It leads to more security posture. And of course, if you are going to use the deep inspection, be prepared with the resources regarding the processing, the storage, and the network connection, and the of course the security specialist that will be responsible for observing the alerts, taking action, and reading the log files related to this needs to be and to benefit from all the features of this needs that you have used or decided to deploy as deep inspection needs. Let's have a look at this diagram and see where can I place the needs. In this diagram, we can say the intrusion detection probe is set into 2 points. In the traffic coming from the internet reaching the firewall, the input of the firewall from the internet is detected through the intrusion detection probe, and the output of the firewall to the demilitarized zone is detected through the intrusion detection probe. It is as if this intrusion detection probe is measuring the performance of the firewall. Is it acting good? Is there a difference between the input to the firewall and the output of the firewall, or this firewall needs more configuration and more enhancement? So we are analyzing the performance of this firewall through the intrusion detection probes that are placed to its input and placed to its output, and seemingly comparing both of them. In the same diagram, we may have an intrusion detection system in the internal network that is sampling and taking samples and generating alerts to the internal network traffic, which may be more important for us. So this intrusion detection system at the bottom, which is trying to detect any attacks on the internal network and generate alerts over this internal network, may be more important to us than the intrusion detection system that is above, because the alerts on the one at the bottom signifies that your internal network, your precious network, your valuable data, your servers are under attack. So you may prioritize your intrusion detection systems one over another. You may prioritize alerts over another. You may set priorities to the events of interest generated from this one and generated from the other one. So these are all points of design that needs some experience and some artistic touches of the security specialists handling these NIDS devices. Thank you. Let's have an example of an intrusion detection system that is well known, that is very commonly used in the cyber security, which is Snort. Snort is low cost, is lightweight intrusion detection system. It is suitable for monitoring multiple sites and multiple sensors for the IDS. That's why it is common. It is very popular. It is very educational as well and used for the training purposes. It has low false alarm rate. Most of the alarms are true, either positive or negative, and that is always the dream of the security specialist, to have low false alarm rate. It has low effort for reporting. It is easily can report and generate alerts, and can generate different formats of alerts that can be reported to the security specialist responsible for the IDS in many ways, and easily, and in a friendly way, in the way he wants and at the time he wants. Let's have a look at this snort capturing. It looks like to a great extent the capturing of a sniffer. But we have here RPC info query that is written between two asterisks, which means that this is a text written by the administrator to identify for himself what is this capturing telling. We have here the timestamp at the left, and then the source IP address 211.72.115.100, and the port number, the source port number is 623. Then an arrow, then the destination IP address or the destination domain name z.y.w.98, then the destination port number is 111. We have the TCP protocol that sends this packet. We have the TTL value that is 46, the type of service value, the ID value that is used for fragmentation, and the flag don't fragment is set. We have the ACK flag set, and the win flag is set, and we have the sequence number written in hexadecimal. We have some of the TCP options of the TCP fields of options that are written here and stated and mentioned here, their values in hexadecimal. So we have some good information about this packet that can be investigated and can be examined, either to generate an alert or to let this traffic pass as something that is event of no interest. So this is an example or a sample of what can snort capture. Let's here configure some snort rule and some basic snort rule. Let's say that the rule says alert me, send me an alert if traffic is sent by the TCP protocol from any source IP and any source port number, but for the destination IP address 192.168.1.0/24, which means that the whole subnetwork of this net ID, and the port number, destination port number is 80, and show on the screen a message that says inbound HTTP traffic. This is a rule that says that you as IDS should generate an alert if you find a traffic matching this condition. What could happen? The output is at the bottom, so we can say the message is here, inbound HTTP traffic is displayed, and we can see here the timestamp. The date is 9 February, for example, and the timestamp is generated, and the source IP is matching the source IP in the rule, which says any, so anything is matching, and the destination IP is matching the destination IP in the rule. The destination port number is 80, so exactly as the rule. The protocol is TCP, so this is matching our rule. The TTL value, the type of service value, the identification, and other values in this packet. So here we have a successful alert that matches the rule being configured by the security administrator. So the output tells some information about the packet that has been captured by the snort rule and shows that you have an alert here. You as the security administrator told me as an IDS to capture such packet with such rules, and here you have this alert on the screen. Let's have another example with advanced snort rule. Alert TCP any, which means that alert me if a packet is captured by the TCP protocol that was crafted by the TCP protocol with any source IP and any source port, but the destination IP or the destination network is 192.168.1.1.0/24, and the destination port number is 80. But here we are examining the content. The content must contain the word CGI bin bin/test.cgi. The message to be displayed is attempted CGI bin access. This is the message that will be displayed on the screen when such packet is captured. Let's see the output at the bottom. The output displays the message attempted CGI bin access and two exclamation marks. And then let's see that the source IP, source port number, destination IP, destination port number, all are matching the rule configured on Snort. So this is a successful also rule that, or a successful alert that has been generated according to the rule. And here we can say the message that displayed on the screen that should capture the eyesight of the security specialist to know that this is an attempted CGI bin access to your system. Maybe the one configuring the rule is not the same one reading the output, so he can read the text that says attempted CGI bin access and do not follow or complete reading the rest of the output, which may look complicated for him, so he can know the type of attack from just the message that has been displayed and act accordingly if required. Let's say some of the pros and cons of the NIDS, of the Network Intrusion Detection System. One of the pros is that it is fairly easy to set up. It does not need much effort to set up. It does not affect the speed of the network or add load to the system it monitors. This is very important, and this is, some of the networks are very sensitive to security appliances and security procedures that it leads the network to poor performance. The NIDS most of the time is not. The cons is sensors have limited speed. Sometimes sensors have limited speed, so they miss some packets and miss some traffic uninvestigated. Almost impossible to detect attacks not in the rule set. If there is no rule to detect the attacks, then the IDS will miss this attack and will pass this attack and will not generate an alert for this attack. It is very susceptible to low and slow attacks. Whenever the attacker is slow, whenever the attacker is patient, the attack is more likely to succeed, to bypass the firewall, the IDS, the antivirus, and other security and other defense appliances. NIDS, in conclusion, is an important part of a robust perimeter defense. It should be applied whenever needed, and it should be applied with the cost of it, which is the high maintenance, the taking care of the alerts being generated, and knowing exactly what and how does it work, and knowing exactly how to configure its rule set. Thank you. Let's know something about the intrusion prevention system, the IPS, which is the evolution of the IDS, the intrusion detection system. What is IPS? IPS stops attacks on systems and networks from being effective. And here we can say that the IPS is not just a passive monitor, just like the IDS. It's here an active element that can stop attack, that can face attack, that can eliminate the number of attacks and take actions according to alerts, and prevents the attacks from being effective and from damaging and from spreading across the network. It has two types of intrusion prevention. One of them is the network intrusion prevention system, and the other is the host-based intrusion prevention system. One of them is for the network traffic, and the other is for the host, for the machine and its operating system. One of them is concerned with the anomalous traffic, bad packets and such things, and the other is concerned with the attacks that are taking place inside the machine itself, which is the host-based intrusion prevention system. The IPS is a technology that is more recent than the IDS. That is the development and the evolution of the IDS. The IPS is very rapidly maturing, and it is day by day replacing the IDS, and day by day we can find more products and more appliances from the giant companies and the hardware vendors acting as IPS or intrusion prevention systems. The NIPS challenges, the network intrusion prevention system challenges, is mainly these points, starting the false positives. How much false positives can you afford? How can you afford the false positives or not? And here it is repeated here two times, the false positives, and another question that says, can you afford the false positives? Can you let the IPS record every single event on your network and generate an alert on it, and you as an analyst keep reading it and define what is of interest and what is not? This is the cost of affording false positives. The NIPS may support a limited suite of network applications. That's why the NIPS may miss some other applications because he don't know about their behavior. So it cannot know about what is normal, what is abnormal, what is good, and what is not good. So it can act only according to what is known for it, which can be a limited suite of network applications that has signatures and known types of packets transferred between them. It requires more system resources than the IDS because here it takes actions. So it requires more processing and storage and network bandwidth. And you should ask yourself, can you afford false positives or not, and accordingly assign the human resources that would be assigned for the network intrusion prevention system. If you cannot afford false positives, then you should assign much human resources, trained security specialists over this IPS, for this IPS to monitor and to take action according to the alerts being generated. Keeping up with the traffic demands. We all hope that the NIPS does not act as a bottleneck or as a slowing point for the traffic and do not miss any single packet on the network. This is our dream, but can the IPS do so with its limited resources? We hope so. Can it keep up with the traffic demands? Can it keep up with the gigabytes over the network keeping running and exploring every packet being transmitted over the network and taking the decision and generating alert if necessary? This is what we hope for the network intrusion prevention system. We tend to have less expensive rule base. We tend to have rule base that is acting at the critical situations only to take actions and to stop this traffic or this packet from being transmitted. So the rule base should be more accurate but less expensive than the rule base of the IDS. Some of the recommendations regarding the network intrusion prevention system is to put it on the network in a learning mode first, to know some things about the normal traffic before starting to face the abnormal traffic and taking actions accordingly. So what should it know about the normal traffic? It should know about the size of this traffic, the topology of the network, the architecture of the network, and things that look normal and things that are in good condition about the network, to be able to define that there has been a change in the traffic, has been a change in the topology or the architecture, and generate an alert accordingly so that the analyst also react accordingly. That should be the learning mode of the IPS, to know about traffic topology architecture, to know about the environment it is controlling and monitoring, and to know about the normal in this traffic and this topology and this architecture, to be able to detect the changes in any of them and generate alerts regarding any of them. The NIPS requires trained security specialists to be investigating and analyzing the alerts being generated by the network intrusion prevention system and determine the actions to be taken accordingly. It is not a replacement for a firewall. Nothing is a replacement for anything. So the IDS, the IPS, the firewall, the antivirus, the patching, the passwords, the security policy, everything should be there in a defense in-depth technique to be able to have a security posture. Nothing is a replacement for nothing, even if it is a mature technology, modern technology, more recent than the IDS, but it does not replace firewalls. What are the IPS products based on? It can be an IDS plus something that takes a decision according to alerts generated by the IDS, or a firewall plus something that takes decision according to the capture of the firewall. An antivirus plus something, this is the host-based IPS. An antivirus plus something that removes the virus detected by the antivirus. Or it just can be an extra widget acting over the network to detect malicious traffic or malicious traffic conditions or malicious packets or malicious headers or anything that is unwanted over the network and stops it from being effective and from damaging the network we are controlling. Thank you. Now let's explore the wired equivalent privacy, the WEP protocol. Sometimes it is misinterpreted as the wireless encryption protocol, but the exact interpretation is wired equivalent privacy. Let's review some of the concepts about the wireless network security. The wireless networks are more problematic regarding the security issues than the wired networks. Because of the open transmission media, the transmission media is the air, and the air is open for everyone to sniff, is open for everyone to capture the traffic and start attacking, is open for everyone in the area covered to send and receive messages through the air to the transmission and the connecting devices in a wireless network. So it is more problematic and more difficult, and let us say that most of the time of the security officer will be spent on two issues: securing the servers and securing the wireless network. Your headache as a security specialist will come from two sources: your servers, your demilitarized zone, especially the webmail DNS servers. Those will be the hot spots of your attack, and the wireless network that will convey and include most of the guests, most of the people that you are not controlling, most of the people that are visitors to your premises or to your organization, and you don't know much about them and about their security setup. So they will be a source of attack, and they will be something that you should take care of and isolate from your wired network. So this open transmission media is susceptible for sniffing. The wide area of coverage is not always an advantage for the wireless networks. Sometimes wide area of coverage leads to more problems in the wireless network. Sometimes people tend to buy more stronger antenna and try to let the coverage area be greater, as great as possible, and maximize the coverage area of the wireless network. This is not always in the advantage of security, because sometimes this area exceeds the limits of the premises itself, exceeds the limits of the organization of the building itself, and tends to be around the building itself to the cars and the people passing the street around the building itself. So you are not controlling who is accessing your access point, who is in reach of your wireless network. So this can be a point that you must take care of, and you must know for how distant your wireless network is reaching. The higher bit error rate, this is something by the nature of communications, of wireless communications. It has high bit error rate than the wired network. This is something that is unwanted, but it is accepted in regard to the flexibility and mobility and the so much advantages of the wired network. Sometimes you need to isolate your wireless network from your sensitive data. Isolate your wireless network from your servers, your precious servers, your sensitive data and information. This isolation is done through placing a firewall, for example, or placing some VLAN separation, or placing them through separate physical switches. And this isolation is needed because you need to separate a vector of attackers that may exist on the wireless network from your sensitive and precious information that are on your wired infrastructure. So you may need, as a security officer, to think of the way of separation that you will follow. Sometimes you require encryption in transient. In transient of transmission of the data is in the air. So how would you protect it? Sometimes you may think of encrypting the data. What is meant by encryption we will see in the next slide. But encryption makes the data, keeps the confidentiality of the data, makes the data hard to be read and to be captured and to be interpreted. It can be captured in an encrypted form, so it is useless. It looks like ciphertext, not plain text, and at the same time it is having the advantage of flexibility and mobility of the wireless network, and at the same time it is keeping its confidentiality. Let's have a look at the word encryption. What is meant by encryption? Encryption is the process of encoding a message of or information. What is encoding? Encoding is letting the message transfer from the form of plain text to the form of ciphertext. So only authorized parties can access this information. Why? Because only authorized parties can decrypt the data and return the data to its original form from ciphertext to plain text once again. There is a science, a very big science, that's called cryptography, where much mathematics is involved. That you can, cryptography is the way how to encrypt and how to decrypt and how to use the keys of encryption, decryption, and the ways. And this is a very big science that uses the binary mathematics and specifies the ways of encryption and decryption for the data. Decryption is the reverse process of encryption. Decryption is transferring the data once more from ciphertext that cannot be read into data. Let's have a look at this diagram. You can see the word hello. Hello, after being encrypted, is transferred in something in the middle that has no meaning, that if read by any person does not mean to him anything. But after passing again to the decryption key, it returns to the word hello. So the left is encryption and the right is the decryption, and in between we have just ciphertext that cannot be read by anyone. So only the authorized parties here, according to this diagram, has access to the right information and can read the word hello. We have encryption that transfers data into cipher, we have decryption that transfers cipher into data, and we have the key of encryption. The key of encryption can be a sequence of ones or zeros. The longer the key, the harder to be broken. The longer the key, the harder this encryption algorithm gets, and the harder this encryption algorithm is against breaking and against decryption as well. So the key can be a sequence of ones and zeros that can be, for example, 8 bits long or 16 bits long. That can be hard for guessing, and that can be used for encryption, and the same key sometimes is used for decryption if the encryption is symmetric or something like this. And some other times the key of encryption is different than the key of decryption in asymmetric encryption algorithms. This is a very brief introduction about the word encryption. Let's see here the wired equivalent privacy, the WEP, as an encryption protocol for wireless networks. It was built to suit the IEEE 800 and 2.11, which is the Wi-Fi standard. It was targeting preserving the confidentiality of data, not breaking the confidentiality of data. It used a key that is 10 to 26 hexadecimal digits, which means that it is 40 to 104 bits in length. So it is long enough to be good for some time. It included the methods for encryption data using a shared secret and the RC4 encryption algorithm. This is a very well-known encryption algorithm, a strong one that has been well known for a long time and that has been defending breaking and defending being broken by any attacker for a long time. But now it is not advisable to use the WEP. At one time the WEP was widely used. At some time WEP was the main encryption protocol for all the wireless networks until it has been broken and it has been announced superseded. We have some drawbacks of the WEP. Shared secrets that are used, the shared keys that are used, the shared secrets that are used in encryption and decryption do not remain secretive. It is shared among some people, so it may be shared among attackers as well. the WEP has inability to rotate the web keys. Rotating the web keys make the encryption algorithm stronger, and this inability makes the WEP stagnant. So produce the stagnant shared secret implementations has led the WEP to be easily broken and to be easily uh, intruded by attackers. Accelerated web cracking becoming common. So you can search the internet about cracking the WEP. You would reach many softwares and many videos on many websites that can explain step by step how can you break and read and access any wireless network using the WEP encryption algorithm to encrypt its data. So in 2003, the Wi-Fi Alliance announced that WEP had been superseded, and we here in this course advise and recommend you do not use WEP as your encryption algorithm. Even if it is existing among your options, eliminate it from your choices, eliminate it from your options, and do not use WEP as the encryption algorithm for wireless networks. We have other promising encryption algorithms for the wireless network that we are going to introduce in the coming slides. Thank you. Let's explore now the WPA and the AES algorithms for the encryption of wireless traffic traversing the air medium. The WPA stands for Wi-Fi Protected Access. It was announced by the Wi-Fi Alliance in 2003 as a successor for the WEP, which has been proven to be weak and been proven to be susceptible to breaking. It is a security standard for wireless internet connections, or for Wi-Fi, that is WPA. It has improved upon and replaced the wired equivalent privacy, WEP. It provides more sophisticated data encryption than WEP, more strong, more advanced encryption, more encryption that can face any attacking attempts. It offers a feature that was not there in the WPA, which is the user authentication. It authenticates the user sending the data so that you can check that the data has not been changed, and moreover the data is being sent by the authenticated user and not anyone else. WPA has generated two versions. WPA 1 in 2003, once the WEP has disappeared and been superseded in 2003, WPA1 has been produced, and a year later WPA2 in 2004, which is the current version of WPA, or the Wi-Fi Protected Access Protocol. WPA1 is the most common WPA configuration using WPA PSK, pre-shared key. So the most common configuration for this is this encryption protocol using the pre-shared key. The keys used by WPA are 256 bits. Remember, the longer the key, the stronger the encryption algorithm. So there is a significant increase over the 64-bit and 128 bits keys used in the WEP system. So there is an advancement. This is an evolution. This is an innovation. This is much harder in breaking than the WEP. It has a new feature also that checks the message integrity to determine if an attacker captured or altered packets between access point and client. This was not there in WEP, and this is a feature that was introduced by WPA1. The encryption algorithm used by WPA1 was called Temporal Key Integrity Protocol, or TKIP. It was known by the TKIP. This was the encryption algorithm that was known. TKIP employs a pair packet key system. Remember, WEP had many problems in its key that was stagnant, that was not a rotating key, and here we are trying to treat these problems through using a pair packet key system, which makes it harder to figure out this key, which makes it harder to break this encryption algorithm. It is radically more secure than fixed key used in the WEP system. So WPA had many advantages and many innovations and many advancements than the WEP. In spite of this, WPA1 had so many drawbacks because it's like its predecessor has been shown to be vulnerable to intrusion via the proof of concept. Theoretically, using research and papers, it has been vulnerable to intrusion. And applied public demonstrations also show that WPA1 is vulnerable to intrusion. The process by which WPA is breached is not direct attack on the algorithm, although such attacks have been successfully demonstrated. So, it has been successfully demonstrated that WPA is susceptible to attack. But the most common process for breaching WPA was not through attacking its algorithm. It was attacking on supplementary system that was rolled out by the with the WPA. This was the most common way or technique used to attack the WPA. The Wi-Fi protected setup, the WPS, designed to make it easy to link devices to modern access point. This was one of the steps to try to let the WPA live longer and stay longer in the market. The WPA2, as of 2006, has been officially superseded, or has been officially being the supersede of the WPA1. So WPA2 has appeared on the world in 2004, but in 2006 WPA1 has been superseded by WPA2 officially. The significant changes between WPA2 and WPA1 was the following. The mandatory use of advanced encryption standard AES algorithm, which is a very strong encryption algorithm that has not been proven to be attackable, proven to be broken easily. The introduction of CCMP, counter cipher mode with blockchaining message authentication code protocol. Very long name, but it is just a replacement for the TCP, the encryption algorithm that was used by WPA1. Anyhow, TCP is still preserved in WPA2 for the fallback system and for interoperability with the WPA1, to be interoperable with the devices using such encryption with the devices using the WPA2, to provide interoperability between both encryption algorithms, WPA1 and WPA2. Security implications of the known WPA2 vulnerabilities are limited, so it is still a good recommendation to use WPA2 with the AES algorithm, encryption algorithm. Specifically, the configuration using the AES is very strong and it is less susceptible to breaking. Let's recall here that there is no encryption algorithm that is perfect. There is no encryption algorithm that is 100% against breaking. There is no such thing. It is a matter of time. It is a matter of advancement in research and in technologies that makes an algorithm, encryption algorithm, stronger than its predecessor and makes an algorithm supersedes other algorithm. It's a matter of time until this current algorithm is being broken, then it is replaced by another one. So the WPA2 is recommended to be used on the wireless networks right now, and right now it is available by all wireless devices vendors. You can easily find in the market access points, wireless cards, so many wireless devices applying the WPA2 encryption algorithm among its options. So you can use this option to encrypt the traffic between your wireless card and access point, and between two wireless cards if it is an ad hoc network being established. So you can apply this algorithm safely and feel more safe, feel more confident that your data will not be broken and the confidentiality, integrity and availability of your data will not be broken through this encryption algorithm. Encryption algorithm focuses on the integrity and the confidentiality. It sometimes is not related to the availability of the data. Anyhow, WPA2 is a good recommendation for security officers to use on the wireless networks right now. Thank you. Let's discuss here some of the well-known misconceptions about the wireless security. Some of the general misconceptions are as follows. Some of the organizations think that they are not using wireless for sensitive data. So the wireless network is not in direct connection to the sensitive data. So we are safe. We do not need to worry about security. This is not true, because if your wireless network is part of your infrastructure, so it is connected to your sensitive data in some way, either direct or indirect. So consider isolation, consider separating both traffic, either through separate VLANs, either through placement of firewall, or by encrypting the traffic, or by controlling the traffic passing from the wireless network to the wired infrastructure. It is not enough to say that my wireless infrastructure does not contain any sensitive data, but it is connected to the wired. So think how it is connected. Think how the attacker may use your wireless network to access the wired infrastructure and to access the servers and reach your precious data and damage them. You should think of the traversing traffic between the wireless and the wired, and how to be controlled and how to be filtered. Some organizations say that we don't have any wireless, and often they discover that they have wireless network through some rogue access points. What is the meaning of rogue access point? It is an unauthorized access point deployed with little security or with no security at all, deployed by an employee who thought that he needs to access the network remotely, or to access the network from the corridor or from another room. So he, with good intentions, implemented an access point inside his registration Jack 45 connection or slot, and instead of placing his machine, he placed a rogue access point with no security at all. He managed to access the network through this rogue access point, but the problem is he allowed others to access your network even from outside the building or from outside his room. He allowed them and gave them access to your network through this rogue access point that contains no security at all. So he injected a security hole inside your network. He created a backdoor that you are not aware of. And there are some ways that you can use to identify and to discover the rogue access points existing in your building or in your premises, and start to think how were they created, and how to eliminate them, and how to remove them from your network. One more thing is, what about your ad hoc networks? What about the meeting rooms? What about the two employees who sit in the meeting room and establish ad hoc network between their laptops to transfer their data? This is a wireless network that is transferred, or that is established temporarily inside your building, that is transferring data that belongs to the laptops or the mobile phones of your employees. It may be sensitive data. It may be data that you do not want to exchange between laptops. So what about the ad hoc networks, and thinking about the ad hoc networks that may be established inside your premises and you are not aware of? How would you face this, and how would you control this? These are wireless networks that you do not know about and that are under your control, and accessing your sensitive information needs to be under your control and needs to be applied with security measures of your choice. Other misconceptions is that some organizations say we cloak our SSID, service set identifier. We cloak means that we hide, so people cannot join our wireless network. This is a good defense, that you cloak your SSID, but do not depend on this defense and say that it is impossible for anyone to know about this hidden SSID. No, it is possible because by passively listening to the network, an attacker can capture the network name by using any sniffer, by using a wireless sniffer to capture the wireless traffic, and analyzing this traffic you can know the network name, you can know the hidden service set identifier. There are some softwares that can show you the broadcasted service set identifiers SSIDs and the hidden service set identifiers, and they are free, like the NSS Insider, the Insider with double S. This is a software that is free and used, maybe set up on your laptop, and can show you the broadcasted SSIDs and the hidden SSIDs as well, with no effort from your side at all. You can say to yourself that I'm using MAC based access control that restricts access to authorized users. Yes, this is good, this is a good defense, but it is not 100% protecting your network, because an attacker can monitor the network to identify valid MAC addresses and spoof his MAC address with another valid MAC address and fools your MAC address control. You can say that WEP is safe, WEP is safe, and we have demonstrated through the lectures before that WEP is unsafe and it is superseded by WPA, which has been superseded also by WPA version 2. You can tell yourself that the DOS attack, the denial of service attacks, requires expensive hardware that is not easily accessible, and this is a misconception. This is not true. An attacker can launch DOS attack with a $10 wireless card, only $10 and maybe cheaper wireless card, and can jam your signal and can intrude your signal and can cause denial of service for your access point, and you can find that your machines are not reaching the access point and the access point is not communicating with your machines, so your machines are not connected to the wireless network, and there is a case that is denial of service with only $10 wireless card used by an attacker, with some readily available software on this wireless card that can jam signals and can produce signals that interfere with the wireless networks you have and prevent your signals from reaching the access point and the signals from the access point from reaching your machines, and by this you can cause a denial of service on your wireless network. This is possible, and this is one of the attacks that can be used on your wireless network, and of course it has a mitigation. So we should be aware of these misconceptions, and in general we do not depend totally on one defensive technique and say that it is 100% protecting my network. There is no such technique. You should build your defense in depth, DID, remember this term, defense in depth, and you should let the attacker suffer from one defensive technique to another until reaching your network, if he will reach it. You need to slow his pace, you need to make him suffer and take longer time until you can catch him and block him and know about him and enhance your security techniques before he can reach your precious network. Be aware of the zero-day attacks and of the vulnerabilities that appear at the same day you are working, because the zero-day attacks needs you to be alert and to be aware of the defensive techniques for this attack at the same day before it gets you down and it attacks you and it damages you totally. Thank you. It's time to talk about some of the very well-known wireless attacks and their mitigation. Attacks on specialized and dedicated for the wireless networks and the way of their mitigation. One of these attacks is the eavesdropping. It is something like sniffing and like knowing or capturing some of the traffic on the wireless network without being authenticated or without being um, permitted to do so. This type of attack is very well known because some of the coverage area of the wireless networks may lie outside of the building, outside of the premises, so you can sit in your car beside the building or the premises of this organization using the wireless network and can capture some of their traffic. This is called eavesdropping. Its mitigation is simple. Just use strong encryption. in the lowest layer protocol possible. You should use encryption to keep your confidentiality. Whatever the attacker can read, he cannot interpret or understand the nature or the information or the plain text of your data. He is just capturing ciphertext and cannot interpret it into plain text. Design your wireless network with caution and take care what is your coverage area. Minimize your coverage area. Design the wireless network so that it is not covering more area than controlled. It is not covering areas that are not under your sight, that are not the areas that you are not aware of. You are not covering with your wireless network areas that are designed for guests. Audit your network with a packet sniffer. Audit your wireless network with a packet sniffer and determine what can an attacker see. What is the type of the traffic that the attacker can see? Try to be the first to see this traffic before the attacker himself, because when you audit your network, you will be able to see the vulnerabilities, the drawbacks, the backdoors that the attacker can sneak through into your network. So you can be the first one to close these backdoors and mitigate these vulnerabilities. Masquerading and its mitigation. Masquerading happens when an attacker spoofs his identity as a legitimate node or access point. He tricks unsuspecting users to giving up sensitive information. It is something like you are putting a mask on your face and pretending to be someone else, someone trusted for the victim, so that he gives up some sensitive information to your side. You can trick a node or an access point so that it thinks that you are an authenticated user, but in fact you are a malicious user, and you need to know some of the traffic that is passing through this network and that is traversing through this network, and you are trying to access it without permission. Sometimes the mitigation is the use of mutual authentication wireless protocols like PEEP or TTLS, or any other protocols that are more recent than PEEP or TTLS, that uses mutual authentication, that authenticates both the sender and the receiver sides to be sure that the sender is the rightful sender, the right sender is sending the data, and the rightful receiver is receiving the data, and no one else has been intruding or capturing the data in between. You can use SSL TLS for passing sensitive information to web applications, so you can be sure that sensitive information for web applications are also safe and are also being protected by such protection techniques. The DOS. The DOS is the denial of service. The DOS is making your wireless network appear that it is not there, rendering your wireless network as it is closed or as it is not working in the right way. So there are many ways that you can cause DOS attack on your wireless network. You can jam the signals of the wireless network, you can stop the access points from working, you can do many things to render the network to be stopped or to be appearing as a denial of service. What can you do as a mitigation for this DOS attack? You can upgrade the firmware of faulty Wi-Fi cards. Just keep all your firmware of your access points, of your Wi-Fi cards, of any wireless device, keep it upgraded and up to date, because every patch appears, or every patch is developed by the vendor of this wireless card, targets the security as the first target and targets the security at the first place, and every patch is more secure than the preceding one. The patch of today is more secure than the patch of yesterday. So patching and upgrading the firmware is a very good, helpful method for keeping the security up to date. You should also understand the impact of a DOS attack against your environment. What if a DOS attack is successful? What would it prevent? What would it hide? What would it prevent from access, what would it make it impossible to access, and what is affordable for me and what is not affordable for me if this happens as security specialist. So I should know and understand the impact of a DOS attack, and I should not be 100% sure that DOS attack is impossible. No, it is possible, and you should consider and imagine, if it happens, what would be its impact on my network. Think of using wireless intrusion detection system. Remember that the intrusion detection system is an alarm system producing alerts, so you need to produce maybe a sniffer to sniff the wireless traffic and set some criteria on it. If you find a packet with so and so address and so port number, just show me an alert through a line on the screen or a beep, or send me an email or send me an SMS. This would be a good defensive technique for your wireless network. Prepare a response strategy. Just be prepared if there is an attack. Imagine that this attack or that attack has happened. What would you do? And do this beforehand that the attack takes place, because the worst time you think at is the time you are under attack. You should think while you are relaxed. You should take your decisions and prepare your plans while you are relaxed, not while you are under attack. While you are under attack, your mind is not clear and your thinking is not the right thinking at all. Rogue access point is a very well-known attack for the wireless network. It is unauthorized access point connected to a private network, often installed with default settings and without security at all, without password, without encryption, even without upgraded firmware, without anything at all. So it permits full access to a network for an unauthorized user. So you can perform rogue access point detection. It's very simple. Just carry your wireless card and move through the place and try to detect and see what is the wireless signals it is catching and it is receiving. You can find rogue access points inside some rooms and corridors that were not meant to be there and that were not planned to be there and that you did not put there by your hand. So these are rogue access points and need to be removed by yourself. Use mutual authentication wireless protocols such as PIP or TLS to avoid rogue access points. Deploy wireless intrusion detections as well, and deploy a strong wireless LAN. This would look strange, but if your wireless LAN is strong, no one will think of implementing rogue access point in any place. They will depend on your strong wireless LAN. They are covered everywhere. They are covered in all the places they are supposed to be covered in. Then no one will think of deploying rogue access point, and you will save yourself some effort. Thank you. Now we can move to the secure wireless network design. We need to apply security from the point of design of the network. So the design itself, how can it be secure while applying the wireless networks and while merging the wireless network with the wired ones? Let's have a look at this diagram. This diagram is just a modification of the preceding diagram that contained no wireless networks. We have just added and amended here the wireless network section. So let's have a look at the internet that is connected to the network of the organization through a border router and then through a multi-homed firewall. The section at the right is the same section we have seen before. Switches that are connected to servers. Some of them may be the demilitarized zone, some of them may be the internal network of the organization, and some of them can contain the workstations inside the internal network of the organizations, the workstations where the employees can work. So this the section at the right is pretty well known to us. The section at the left of the firewall is the new section. We can see that we have several wireless access points, WAP wireless access points, that are connected to a segregated switch, a separate switch from all the other network that is communicating all the wireless access points together. So we can see some features of security here in this design that can be demonstrated through, first, installing all the wireless access points on a segregated switch. Then this segregated switch is connected to the internal network through the firewall, and not directly connected to the wired network. So by these two security features, you can have some guarantee and some safe precautions that your wireless traffic will not sneak through to the wired network and wired infrastructure uninvestigated. It will be investigated first, it will be checked by the firewall first, and the firewall will decide either to accept or reject this traffic. And one more thing, if it happened that an attacker tries to access your network through this wireless section, so it will be accessing the segregated switch. If it happened that this switch get compromised, so it will only keep compromised by itself, and it will not move the attack to other switches because it is separated and segregated from other switches, and the traffic passing from it to other switches is checked and investigated by the firewall. Let's observe here also that the wireless devices having a separate switch that contains no wire devices at the same time, so it looks like a separate network that is connected to another network without any merging between them. All the traffic passing from the wireless network to the wired network is investigated and checked by the firewall, as you can see. So this is a point of design. This is a point that you can take into consideration while designing your network with its both wired sections and wireless sections. Let's summarize here some points about the wireless security. You should consider design at all layers of the OSI model, at the physical layer, at the data link layer. At the physical layer, you should minimize the coverage area. You should know about the coverage area of your wireless network. At the data link layer, you should secure your access point because it's a device working at layer 2. At layer 3, you should have a look at the routers and the access control lists they are applying on this layer between the wired and the wireless. So at every layer of the ISO OSI model 7 layers, you have some measure and some action and some procedure of security that you can apply. You need to identify specific areas of coverage that is under control and that is not extending to outside your premises. You should audit your wireless LANs for rogue and unauthorized clients and rogue unauthorized access points that has been installed without your permission as security specialist inside the place. You should consider deploying wireless intrusion detection system. You should consider setting up a wireless IDS such as a sniffer or something that has some rules to generate alerts upon. You should migrate to WPA version 2 because it is the current and the unbroken so far encryption algorithm used by the wireless networks, and keep in mind the AES or the Advanced Encryption Standard, which is a component inside the WPA2. Now let's have a look at a tool, a software tool that is used to locate access points and determine their SSIDs. Determine and show me on its screen their SSIDs, even if it is hidden SSIDs. So it shows me the SSIDs both broadcasted and hidden. It shows also the MAC addresses of the access point itself, which is the hardware address of the device network adapter. It shows the SSID as 32 character ID that acts like a password on a wireless LAN if it is hidden. The name of the access point if it is available, if it is set. The channel that the access point is using, the channel, remember the channels, and the bandwidth used divided into several channels, and there is a guard band between each of them, and some access point use channels 1, some access points use channels 7, 5, 11 and so on to keep the interference between the access point as low as possible. It shows the vendor of the access point. It shows that this access point is of brand so and so. It shows the encryption algorithm used inside this access point, whether it is WEP or another algorithm. So it shows some useful information about this access point. And remember, this tool can be used by security officer to know about his wireless network with permission, and can be used also by an attacker to know about the wireless network of someone else without permission. The difference between using this software by a security officer or by an attacker is the permission. The word permission should be a keyword inside our head. This is a sample of the output of the insider software. Now you can see the MAC address of the access point, the SSID, service set and the identifier of the network it is running, the name of the access point, the channel used, and here it is 666 for all, the vendor of the access point and the company that has produced this access point. The type AP is access point, the encryption whether it is WEP or other encryption algorithm. We are focusing on the weakness of WEP, that it is easily broken and can be easily broadcasted through this access point. You can find at the left side of this diagram some of the access points displayed with channels, SSIDs and filters and things like this. You can use insider software that has so many softwares that can work with the same way. You can use this insider to draw a map of the wireless network inside your organization and know much more information about them inside your organization while setting up this software on your laptop and moving freely inside the organization. It's lightweight and it can draw a map for your network easily, and it needs no much experience to be set up and to be run inside your network. Thank you. Now it's time to talk about the physical security. Physical security objectives and how it is related to the objective of our course and the subject of our course, which is the network security. Is there a relation? Yes, there is a relation. The physical security describes security measures that are designed to deny unauthorized access to the following: to facilities, to equipment, to resources. So, the building, the equipment inside the building, the software, the hardware resources inside any equipment are all a target for the physical security measures to deny unauthorized access to any of them. Physical security is of a great importance, and sometimes you design a very sophisticated firewall, very strong firewall and very costly one with very good rule set, and you forget to hide its power appliance. So the attacker will easily detach its power appliance and cause it to be denial of service for the firewall, and leaves your network exposed, totally exposed to attacks. This is a very simple and very easy attack to be done, but very dangerous and very effective and of high impact on your network. Suppose that your firewall is exposed in a corridor with no access card. Suppose that your firewall is beside a window that is exposed to very high temperature. Your firewall can be easily denied of service by some physical attacks that you did not take into consideration, that you have forgotten to put your security measures. So importance of the physical security lies mainly that it is very easy to be attacked through and very dangerous and of high impact if attacked through. The importance of physical security is that it protects personnel, and let's focus on this word. First of all, you should protect your personnel and property from damage or harm. Secondly, you can protect your property from damage or harm, but first comes the personnel. The physical security should be implicit in every logical security control. If you apply firewall, then keep it safe. If you put an access control list on the router, then keep the router in a safe place, away from being detached, away from high temperature, away from any physical security attack that may cause denial of service of it. You may have a very expensive router, very speedy, very good, very well configured through the access control list, and once it is damaged through some water during the cleaning, for example, and you can see that your router, your very dear router and very sophisticated router is attacked by denial of service attack. The importance of the physical security is that it is usually based on assumptions. What if cleaning is not done in the proper way? What if the temperature rises? What if the air condition falls or fails to protect your or to adjust the temperature in your room? What if something goes in fire? Okay, so it is usually based on assumptions, and accordingly you design your security measures in the physical security plan and physical security essence. The importance of the physical security is that it is sometimes overlooked and sometimes it is forgotten. You, as a security specialist, sometimes concentrate and focus highly on the logic and the firewall and the configuration and the IDS and the IPS and on the router access control list and so many things, and you overlook who is entering your facility. Where does he go inside your facility? Is there some access card? Is there some surveillance cameras to record and to have any documentation for his movement inside your building? How does he enter a room? And is he escorted inside the building, or does he have the freedom to roam inside the building without any escorting? So many things could happen, could affect your security plan or policy, and could cause you a high damage because of very simple acts that you have forgotten, because you have overlooked physical security. The objectives once more is safety, and remember that personnel, human beings, the souls of human beings is number one. Personnel is more important than servers, than information, than data, than anything inside the building, than any equipment, than anything inside the building, however expensive it is. The personnel, the human being, is more valuable, is more expensive, and should be protected first. If the building goes in fire, so we should keep the personnel safe as the first priority, and then move to the information and data and the patents inside the building and the equipment and other things. But keep in your mind that personnel is number one to be safe if any physical security attack happens. The objectives of the physical security is safeguarding information, secondly, equipment, infrastructure, facilities, other company assets, after personnel. Okay, information, equipment, and infrastructure and facilities, other company assets may be a target for the physical security attacks and may be exposed to physical security attacks, and safeguarding them by so many physical security measures is your target when you design your physical security plan or you design your physical security tools and technologies that you are going to use to protect your information and equipment and infrastructure. You are targeting providing authorized access and only authorized access, keeping confidentiality, keeping integrity, keeping availability, keeping the CIA is the meaning of authorized access. Only authorized access to the data, that is confidentiality. Only authorized access by modification, by keeping integrity. Only authorized access that should be kept, this is by keeping the availability of the data. Remember the CIA, remember that authorized access is the target of any security measure that you are taking and should be implied of any security measure that you are taking, including the physical security. What if physical security is overlooked? Suppose that you are using very strong passwords with very good encryption algorithm, but it can be easily overlooked if the attacker can physically sit in front of the server or of the laptop and use a boot CD. Any password, however strong, will be bypassed, will have no value at this time. Encryption is another security measure that you can apply on your data, but suppose that physically there is a keylogger, a piece of hardware that can be attached between your keyboard and your case, or between your keyboard internally and the motherboard of your laptop. This keylogger can log and can record every keystroke you are doing or you are executing. The keylogger can be a software, a hidden software on your laptop as well. So what would be the keylogs you will type after typing your username for your email account, for example? It should be the password. Then the keylogger will know or will and can transmit the password through a wireless transmission at the spot to the attacker, overlooking all your encryption algorithms or all your measures that you have taken in choosing your password by through a simple keylogger that is $1 in price and can be installed in a hidden place between the keyboard and the main case, or a software that are running hidden to transmit every keylog you are striking. The viruses, if you are setting up the best antivirus in the world, but you are allowing flash memory, CDs and DVDs to be inserted physically in your machines, what could your antivirus do? Sometimes it will fall with zero-day attacks and zero-day viruses. It would save you much effort and much cost and much licenses for the antivirus software and much updating and upgrading for the antivirus. It should be done, I know, but it could be much easier task for the antivirus that is good and updated and upgraded to keep your data away from viruses if you ban and restrict using the flash memories and CDs and DVDs to your machine, and entering even your facility or your premises with such equipment like the flash memories and CDs and DVDs. Consider redundancy as a physical security measure. Consider using multiple servers. Consider using mirrors, which is real-time copies that are running for the servers. Consider using RAID 5, for example, or any RAID version for the redundancy of hard disks to avoid the loss of data whenever a hard disk is not working, malfunctioning, is out of power, or is having any physical attack that may affect it. So redundancy is a good physical security measure that could be applied that can save much data whenever there is a physical security malfunctioning in the place. Thank you. Let's detail here in this lecture the physical security threats and its mitigation one by one. Let's recall here that safety is number one, and safety of humans is number one inside this number one. The safety of humans is the top priority of the physical security policy that should be existing in any enterprise or in any organization. The safety threats can be something that has been put in fire, some smoke due to fire or due to other that is affecting or spreading over the whole premises, toxins, water flooding that could be due to some water flooding of rains or some water flooding of malfunctioning of some of the water devices inside the premises, or water flooding due to cleaning in a wrong way inside the premises that has raised the level of the water inside the room containing servers, so that the water has entered or has affected the server's hardware. Remember always that electronics do not like water. Electronics do not love water and do not like to cooperate with water. Water could be killing sometimes. And take care of how do you clean your facility, how do you use water in cleaning, and how do people using water in cleaning use it in cleaning your facility. The temperature extremes is another threat for the safety. Very high temperature and very low temperature. The high temperature of course is more dangerous, and the problem of high temperature is sometimes that your room is glass room and the temperature is very high inside, and you see it from outside as ordinary. You do not know what is the temperature inside the room until you enter this room. The power loss is another threat, and the repeated power loss is a very big threat, and it can cause very high damage to your devices, and it can cause data loss, and it can cause total failure of some devices. It can cause a lot of problems to your devices. So take care of power loss and of the repeated power loss in specific. So how do you mitigate such threats? First of all, you should use sensors. If you want to be a good specialist in the field of security, be the first one to know about any attack, and especially the physical security attacks. Use sensors for the level of water, for the temperature, for the smoke, for fire, for any of such threats in the previous slides. Use sensors to set alarms. Use sensors to tell you, to be the first one to know that there is fire, there is water flooding, there is high temperature or very low temperature in some places. You should use sensors to tell you so, and you should use devices to respond. Firefighting system, uninterrupted power supply or UPS, air conditioning or HVAC system, heat, ventilation, air conditioning systems. These are the devices that can respond firefighting for fire, uninterrupted power supply for the power loss or the repeated power loss. It can hold the devices working for up to several days if it is something that is a brand and expensive. The air conditioning and the HVAC systems can cause the temperature to be adjusted on a certain temperature, but keep in mind that high temperature inside a glass room cannot be detected unless there is a good sensor inside, or unless you enter the room by itself. Sometimes you look from outside the room to the glass room of the servers and the data center, and you can feel that everything is okay, while the temperature there has reached 40 degrees centigrade, which is somehow dangerous for your devices. Use signs, and this is a very good and very easy and very important security threat mitigation. For example, you can say that this room is for staff only, and then if you find someone who is not belonging to the staff inside this room, you can escort him outside of this room. Remember, you need to escort him and do not tell him go out. You need to escort him, you need to be with him while going out, because he can go out and return after some while to the same room. Use signs that staff only, this room is this room is a server room, this room is for employees only, and such signs, such written signs, can save you much time and effort for the people doing mistakes unintentionally. You can help them by these signs to know what is correct and what is not correct. If they make a mistake accidentally, it would be once or twice or something like this, and you keep your time and effort, and you save your mind for people doing wicked things, harming your devices, trying to attack your devices intentionally, and they know exactly what they are doing. And of course, you should set procedures to respond. You should have your security policy. You should have something written that is given to the employee at his first day of work that says that your access card allows you to enter such room, and do not enter such room. Your job is allowing you to use such servers, and do not enter such servers, or do not access such servers. Your job requires so and so, and your job is restricted to so and so, and such actions are not allowed for your job to be done. He should know, and he should sign on this security policy, and he should read it as a written document from the first day and from the very beginning of his job days, because after this you will remind him that on page 5 in the security policy book it is written so and so, and you have violated such rule. You can be forgiven for the first time, but the second time you must be punished. You must face, and you must be aware of what you are doing in the violation of the security policy. This can save much time and effort for you as security officer inside the place. This can save many unintentional attacks, and you should focus on the intentional attacks or the accidental attacks only. The unauthorized physical access can be controlled through some devices like the locks, physical locks. The man traps. The man trap is two doors that keeping the person between them. He cannot, after entering the first door, either he can enter the second door or keep locked inside the man trap until he enters the second door, or he keep in his place until someone from the security team comes to free him. This helps people who are trying passwords and who are guessing some ways of accessing unauthorized access that they get trapped. Either you use the right way to access the room or you get trapped, and this would make him think twice and would make him consider using this man trap if he is not authorized to enter or to access the resource he is heading to. Use fences, for example, to prevent your wireless coverage area from extending outside your premises, and to limit and to control who is entering your building and can be able to record this movement. Use contraband checks, X-ray scanners, metal detectors to control the devices entering and leaving your premises, to control the flash memories, CDs, DVDs, portable hard disks, and portable devices entering and leaving your place, and to be able, for example, to ban them, to prevent them from entering or leaving your premises if your security policy requires so, or if your security policy is designed to do so. You can use bag inspection, personal bags inspection, to also prevent such devices from entering and leaving your place. The portable devices, the flash memories, the CDs, the external hard disks, portable hard disks, and such devices can be the real threat to your organization after you have set the firewall, the IDS, the access cards, and everything else. Use video surveillance cameras and set them in the right places to detect every movement, and use trained people in front of these video cameras, trained people who know what exactly to do if so and so happens. Use video cameras whenever possible, and keep some trained people in front of the screens, and use video servers to record the output of these cameras daily to be able to use it as reference if an incident takes place in your premises. The mitigation of any unauthorized physical access to a place is escorting from restricted area. Let me say it again, escorting, and do not tell him, just tell him get out of the place. He will get out of the place and he will return, but escorting him will be the real prevention from accessing this place physically again. Thank you. One of the well-known terminologies in the world of network security and cyber security in general is the term defense in depth. You will find and you will meet this term in many references and textbooks and presentations talking about the cyber security, the network security, telling you that you should apply the defense in depth technique and sometimes the abbreviation DID. What do we mean by defense in depth? Look at this diagram. You will find that the main target for any attack is the information. The information is at the center, at the core of this diagram. The information is accessed and manipulated through an application by the users. And this application resides in a host, which is a machine having an operating system. And it can be a laptop, it can be a server, it can be even a mobile phone. This host is connected to other machines through a network. So it is a shell inside another, inside another, inside another, and every shell of these, every circle of these has its own security measures that applies on it by itself and not on any other else. The information has its own ways of protection. Application is the same, host is the same, and the network is the same. And finally, you need to make the attacker suffer from passing by the network with its defense techniques, then the host with its defense techniques, then the application with its defense techniques, then the information with its defense techniques. You let him suffer. You let him pass through the defense in depth. You let him pass by so many layers of defense so that he get bored, or he get caught, or he get objected, or he get prevented by some means of prevention in any of these layers. Do not put all your security technology techniques or security technologies in one basket. Do not put all your eggs in one basket. Once fired or once attacked or compromised, then your castle is down. No, you should apply this defense in depth technique. Put your security in layers. Apply whenever you find a security technology, either encryption or a firewall or intrusion detection or password or access control or physical security or physical security, by the way, lies here. Physical security is a shell including all this, the network and the host and the application and the information. Physical security lies here and has a role here. So apply every single security technology you know about whenever needed, whenever possible. Keep in mind the balance between security and access. Do not buy a safe that cost you $1,000 to keep inside it $10. You would be insane if you do so. Do not spend much effort for protecting information that has no problem if compromised or if lost. So apply the security techniques here and make the attacker suffer, and after all, be aware and be sure that you are still vulnerable for the zero-day attacks, for the new viruses and worms. And so if I'm still vulnerable, why do I have to apply all these techniques? This is a good question. The answer is, if you will be vulnerable, you will be vulnerable to a certain extent. The zero-day attacks, the new attacks, will not get you to 0% or will not cause you 100% losses or damages. It will cause limited damages and harms if you are applying the defense in depth, and if you are applying the security technologies one by one in each layer of your system. So the information, how it is protected through encryption. For example, using an encryption algorithm for the information residing on hard disks can protect this information from being theft, from being read, from being transported through portable devices, from being modified, from being deleted. Okay, using applications, licensed applications, updated applications, trusted applications. Okay, applications that are concerned mainly with the security, for example, that allows the accessing of information through a username and password and checks the identity, keeps the confidentiality and integrity and availability. Using such applications is some sort of security and is a security defense in depth technique, so that you are not exposing your information to be read or to be modified or to be deleted through your application using it. You try to use licensed software, because the licensed software is up to date, and up to date from the point of view of security. So try to be upgrading your software application, updating your software application by all the patches that are available for it to apply the security on the application layer. Try to use upgraded and updated operating systems on your host. Okay, try to use secure version of your operating system on your host. Try to apply personal firewall or host-based firewall on your host. Try to close unused ports on your host so that you can apply the defense in-depth technique on the host level. On the network level, you have a lot of technologies and all our courses about the network security. So you know about the firewall, the IDS, the access control list on the router. You can now mention a lot of things that you can use to apply the network security on your network. These are technologies, common technologies that came first to your mind if you are going to apply the defense in depth technique. Use each of these technologies in its corresponding layer to be sure that you are applying defense in depth, that your attacker is suffering, is facing one technique, then another, he gets bored or he gets caught, or he reaches at least the least amount of information possible for him to be read or to be deleted or to be modified. This is a very good concept that is commonly applied in security nowadays, which is called defense in depth, and that's why we were very keen to introduce it in our course. Thank you. Now let's get introduced to some of the terminologies related to incident handling. Let's define what is an incident, and let's start by defining what is an event. Let's agree first that if you are going to pursue your career as security specialist, most of your time during your job would be reading events. Events are the lines, output lines from the security devices in your organization or in your company, such as the lines produced by the antivirus, by the IDS, by the firewall. All of these are logging some events on their log files, and your job would be to read these events, analyze them, and correlate them and act accordingly to these events. What is an event? An event is any observable occurrence in a system and or a network, such as rebooting of a system is an event if it is repeated. Crashing of the system is an event if it is repeated or if it has no observable reasons. Packet flooding within a network, generating unwanted packets within a network, is an event. It may be due to normal reasons for increased traffic, and it may be due to attack of a virus of a worm over your network. So the event itself can be due to an incident or can be due to normal reasons, normal increase on traffic. So all incidents are composed of events, but we cannot be fooled to say not all events are incidents. The system reboots, the system crashes, the packet flooding within a network, these are events that are observable to us, but it has some normal reasons, some acceptable reasons, so they are not incidents inside our organization. We should focus on a certain type of events that are the events of interest, EOI, the event of interest which are remarkable, which seems to be abnormal, which seems to have malicious software as contribution in it, which seems to be a sign of an attack or something. These are the events of interest, and the experienced security specialist detects by first sight what is an event that is normal and what is an event that is an event of interest. To say that this event is an incident, you should determine the cause and the effect. You should determine the attacker and the victim. You should determine the malware and the system attack to say that this event is an incident. Signs of an incident. The incident has many signs. That could be that an IDS has generated an alert, some unexplained entries in a log file, failed events that is repeated, bad logon events that are repeated for Windows, for email account, for any web account, unexplained new accounts, who created those accounts and for whom are those accounts created. So these are signs of an incident that say that something is wrong and something is not correct going on. The system reboots if it is not due to power failure or due to power failure that is repeated, so the system reboots. So we should take care of this sign and determine the cause and the effect to define the complete incident. Poor performance. So the poor performance, the network is slow, the web server is heavy, The email accounts are not logging easily. So these are all signs of an incident that could be for normal reasons. So it is a normal event, not an incident, or could be due to attack or malicious software, virus, worm, or malware. So it is here can be defined as an incident. Let's have examples of incidents. Which of the following is an incident? An attacker running NetBIOS scans against a Unix system. An attacker exploiting send mail on a Unix system. A backup tape containing sensitive information is missing. The first two, we here say an attacker explicitly and determining the type of the scan, determining the type of the attack. It's in the first, it is NetBIOS scans. It's in the second, it's exploiting send mail, and we are determining the victim. Here in both lines, it is a Unix system that is being attacked by an attacker through some way, some known technique of attack. So the first two are clear to be incidents and should be addressed, and you should, as a security specialist, take your defensive techniques against them. But the third one, a backup tape containing sensitive information is missing. You here have a probability that this backup tape is being used, is being restored, is being legitimately used by the system administrator to restore the information inside it. So it can be an incident, it cannot be an incident, it could be, it couldn't be. So it is not an incident, or it cannot be defined clearly, explicitly as an incident yet. You should determine the cause of the missing of this tape. Why it is missing? Is it missing by, or is it now under the control of legitimate user, or is it now under the control of illegitimate users? If illegitimate, then it is an incident. If it is under the control of legitimate user, then it is a normal action of restoring some information from this backup tape. By this, we hope that we are ready now to know about the incident handling steps in the next lecture. Thank you. It's time for the incident handling. Incident handling is a very big subject. Incident handling could be a separate course, and one of the specializations inside the cybersecurity or the incident security is incident handling specialist. We are here briefing the steps of the incident handling in a condensed form. So the incident handling steps can be said briefly as the preparation for incident handling. Number one, identification of the incident, containment of the incident, eradication of the effect of the incident, recovery from the incident, and then establishing a meeting for the lessons learned and to know more about how did this incident affect us and to enhance our security posture than before. The preparation, the first step. If you prepare, if you fail to prepare, then prepare to fail. Planning is everything. You should set your policy. You should determine and announce and make it published and documented and signed what are the allowed operations inside your company or your premises and what are the forbidden ones. Your employees should know this, should sign on a written policy on the first day of their work, and should be updated if this policy is updated. This is very important. This is very important to avoid the accidental, the unintentional attacks, and to focus on the intentional ones, and to set your defenses to be ready for such attacks only, and to save much time and effort for the mistakes that some employees do because they don't know about the policy. They do not know about the policy update. They did not get aware that the things that they are doing is not correct. Obtain your management support. You should tell your manager, you should tell your CEO that once we are under attack, I should gain so and so privileges. I should have access to servers. I should have access to the server room. I should be able to call the administrators even if they are on vacation. I should be maybe the manager of the whole place until this attack passes. Maybe this is the solution. So let the management be aware that we are susceptible to incidents. We may be under attack anytime by a zero-day attack, for example. So as an incident handler, I will be in charge. I will be able to direct some people that are not in my team or not in my department and ask them for passwords, for example, ask them to do certain tasks to recover from this incident. Select your team members. Your team members may include the developers, the server administrators, the physical security personnel. Select your team members that may differ due to the nature of the incident. Identify contacts in other organizations. You should be aware about the legal and the law enforcement procedures inside your country, inside your region, about the cyber crimes, about the incidents, whom to go to complain that you have been attacked by so and so, whom to go to show him your forensics and your evidences of the attack, and what are the actions that he or she as an organization, legal organization or law enforcement organization, can take against your attacker. You should update your disaster recovery plan, and on the first place you should create a disaster recovery plan to be ready when there is an incident and to be able to recover from this incident. You should provide checklists and procedures, and checklists, for example, for the servers, for the passwords, for the accounts, and procedures to do this checklist, which means that to assign this checklist to certain staff to do this checklist and to report to you the output of it. You should have emergency communications plan. You should have numbers, phone numbers, email addresses, and even the number of rooms, extensions of the emergency people that you may need at any time you are under attack or at any time you need an incident. This should be prepared. This should be known beforehand, not prepared at the time of the incident, but before any incident happens. You should have your trained staff. You should have a staff that is aware of the cyber security and network security principles, that has studied and that has been taught the concepts and principles, or that has been graduated from our course, for example. Identification. How to identify an incident. Complete identification should include the cause and the effect. Be willing to alert early, but do not jump to a conclusion. You may say that we are under attack, we are having a problem, but do not jump a conclusion that there is an attacker and the attacker is so, or that we have been infected by the malware or the virus that is named so. Do not jump to a conclusion. You may alert early that there is something wrong in the server or on the network. Be very cautious when notifying, because you should notify the correct people. The correct people should not include, by all means, any potential attacker. The attacker may be an insider and he may be among the list you are notifying, so he may change his method of attacking by your notification. This is not correct. Notify the correct people, the relevant people, the responsible people who are completely willing to help, and avoid any potential attacker from your list of notification. Utilize the help desk. The help desk may tell you that the system that is reporting has been rebooting since 1 week ago, and there has been trouble tickets to track this problem. This would be very helpful. Utilize the help desk to know the history of this incident. You may reach the conclusions faster by this way. Assign a primary handler. Who would be the principal or the primary incident handler for this incident? It should be assigned, it should be known, and it should be given the relevant and the appropriate privileges. Determine whether an event is an incident. You should define here that the cause is so and so and the effect is so and so. So this is not a normal event, it's an incident, and there is something wrong that has went. It is not something abnormal due to abnormal traffic or abnormal conditions we are having right now. It is something wrong. It is something that has effect of that has a cause of an attack by software or an human attack or a human attacker or something like this. Identify possible witnesses and evidence. Try to know who has witnessed the system while rebooting and what is the evidence that the system is rebooting. Try to identify who are your eyewitnesses. Eyewitnesses is more reliable than the logs in the machines of the antivirus or the firewall or so and so. And the evidence could be taken afterwards from the logs of the antivirus or the firewall, but eyewitnesses are more reliable. Make a clean backup of the system. Clean backup. Do not fall in the trap of making a compromised backup of the system. Make a clean backup of the system to be restored in the recovery process coming forward. Containment. Containment is to stop the bleeding. If you have a bleeding person in front of you, you do not start by treating him, you stop the bleeding first. So you secure the area, make a clean backup, possibly pull the system off the network to prevent the infection and the transfer of the worm through the network to other systems. Possibly this would be the solution and possibly not. Change passwords to prevent and to avoid the access of the attacker to your system. Maybe the attacker has gained the access through brute forcing the password. So change the password to prevent him from re-accessing while you are containing the incident. He might be re-accessing and doing things that are still unwanted on your system. Eradication. Eradication is fixing the problem, and it should be before putting back online. Do not rush putting back online the system. Determine the cause and symptom during the eradication. Improve your defenses. And then perform vulnerability analysis using any software during the eradication to be sure that the malware, the virus, or the attacker is not there right now before putting back the system online. Be sure that you have the cause and symptom, the right cause and symptom. Improve your defenses. Improve the defenses to be better than the case that you have been while being attacked. The recovery. Recovery means that you are restoring, you are returning to the case where you had been before being attacked. Recovery is rendering the clean system again. So make sure you do not restore compromised code. Validate your system using some software that says that there is no backdoor still existing, there is no viruses or there are no viruses or malwares that are there. Validate the system before rushing into putting back online. Decide when to restore operations and do not rush. Just restore the operations at the point you are sure that the system is clean, the system is back, the system can be fully running without problems and cannot be reinfected again. Monitor the system for some time. Is it acting in a normal way? Is it acting in the way you are looking for? Is it acting in such a way that it has been acting before? Or there is something abnormal, there is something unwanted. So try to monitor the system for some time that it is acting in the normal way. The lessons learned. The lessons learned is a very important step, so you should develop a report and do not point with accusation to someone. Just point the accusation to some reason, not to persons. This would be better. Try to get consensus on the report, and we here say try to get consensus. In some cases you may not get the full consensus among the team members on your report, so you are trying to get the most consensus you can get on the developed report. Conduct a lessons learned meeting. Conduct a meeting that you can say that we have missed in our security systems so and so, and we should add these systems to our security policy, or we should add such technology, we should update such systems, we should upgrade such devices, and so on. Send your recommendations to the management. The management should be aware of what happened and what needs to be done. They should be in the picture. They should be with you. And it is sometimes a layer of defense that you need a firewall. For example, if this is the recommendation, if there is no firewall, you are still susceptible for attack, and the management should be aware of this and accepting the risk. Make follow-up meetings. What have we done since our last meeting? Did we enhance? Did we conduct or execute the recommendations? Is it possible? Is it impossible to have such recommendations in hand? So we should know the output of the follow-up meeting to know where we are now, because some recommendations may be sent to the management and then sent to nowhere without notifying you even. Some of the key mistakes in incident handling is failure to report or ask for help. You tend always to say that everything is okay, everything is good, so you fail to report or ask for help. No, do not do this. If there is a problem, report that there is a problem, ask for help that there is a problem. This would save much effort and time and cost sometimes than failing to report. You may mishandle or destroy the evidence. The evidence may be of good use after the recovery and after the lessons learned to go to court, to go to the law enforcement organizations and ask for your rights. You may fail to create working backups. The backup is there, but it is not working. The backup is there, but it is compromised. So you may fail to create such type of backup. You may fail to contain or eradicate. You may fail to know which are the appropriate virus removal tools or which are the appropriate antivirus to remove this malware. This could be your failure. You may fail to prevent the reinfection. You may fail to enhance your security posture to be able to avoid the reinfection of the virus. So this would be your failure. Or you may fail or forget or ignore applying the lessons learned meeting. This is very dangerous if you do so, because if you fail to apply this lessons learned meeting, you are still susceptible for the reinfection, and the virus or the malware or the attacker may visit your premises once again. Thank you. Once again, we need to know more about the CIA, the confidentiality, integrity, and availability in the world of cyber and network security. Here is the very well-known triangle. Confidentiality. Confidentiality is protecting data from being read, from reading it by someone who is not authorized to read it. Integrity is protecting it from modification, from changing, from alerting, altering, from being changed by someone who is not authorized to do so. Availability is protecting information from being deleted, from being destroyed, and keeping it available for the legitimate and authorized access all the time. The ways to access control to protect this CIA are generally three ways. Is it to authenticate someone based on something he knows, like the password, or based on something he has, like an access card to access a physical room, for example, or a token that changes password every 60 seconds. This changing password is on a screen on this token, and you are standing holding this token in front of the server and typing the password that are appearing on the token on the screen of the server, which means that the attacker, to attack this server, needs to have the token itself and stand in front of the server the same second he is typing the password appearing on the screen of the token. So you are making it hard for him. If this token is stolen by itself, it is not problem. He has to be in front of the server at the same second. Sometimes you gain or you give access control according to something he is. The one you are trying to authenticate is having, for example, such fingerprint, such voice print, or eye signature or retina signature. It is based on this that you are authenticating him and telling that he is the person allowed to access this system. Passwords, and there is a lot to be said about passwords. Passwords should be mandatory for all accounts. No accounts should be allowed to be with no passwords. Passwords need to change every 60 days. 60 days is a point of design. Sometimes you can be more restrictive and change it every 30 days. Sometimes you can be more flexible and change it every 90 days. Accounts must be locked after 3 failed attempts, and 3 here is a point of design also. It can locked out after 1 or 5. All passwords must contain alphanumeric and special characters to be a good password and strong password, and it should be of minimum length. Let's say 6 characters. Sometimes people say that it should be of minimum length of 8 characters. This is also a point of design. You cannot allow the reuse of previous 3 passwords or 5 passwords. You should keep the password history to enforce the man changing this password to change it, really change it, and do not fool the system by typing the old password as a new one. Passwords should not contain birthdays, names, sport teams, or any related information to the password owner. His wife, his children, names, uh, his country, any name that can, or any name that is included in the dictionary, the English dictionary or the dictionary of his language. It should be a word that has no meaning in any dictionary. An example of a strong password is this password: WLSMTLS exclamation mark at hash dollar sign percentage 5T. So this is an example of a strong password, mixing alphanumeric special characters, capital and small letters, and this could be an example of a good password that is hard for cracking. Not impossible for cracking, but just hard for cracking. Let's have a look at the biometric that can be used for access control. It can be the hand geometry, it can be the retina, it can be the iris, the voice print, the mannerisms. So how it works is written right here. The hand geometry measures the hand in 3 dimensions. The retina scans the blood vessels on the retina. But make sure that the retina is not affected by diabetes or pregnancy. It is affected in women by pregnancy and in old people by diabetes. The iris scans the iris patterns. It's more safe and it has no comments so far. The voice print sometimes can be fooled by a recording, and sometimes your voice print changes by illness or by your psychological circumstances. Samples a user repeating a phrase and compares it to an earlier recording. This is how the voice print works. Mannerisms is something like the handwriting or the keystrokes. It compares your handwriting, stride, etc. to samples on the file. It can change due to stress or injury or limp or tendonitis can cause false rejects. So there is no solution that is 100% safe, 100% working, 100% accurate. There is no such method. Even biometrics can act and can have problems and can act in a wrong way. Thank you. Let's recall again some important definitions about cybersecurity or network security, which are the assets, threats, and vulnerabilities. What is the meaning of each of these important terminologies in the world of cybersecurity? Assets means everything that have value for an organization or impact on its business continuity. Assets may include the personnel, the hardware, the software, the physical devices owned by this organization. Some documents owned by these organizations are all assets for these organizations. Assets should be identified to create information security system. A security specialist should ask and should know precisely what he is trying to protect. What is the most precious thing in this organization that you are trying to protect and that you fear to get lost or to get breached by the CIA confidentiality, integrity, or availability. It should be clear what are your assets. Assets may differ from one place to another. The assets of the hospital is the medical records of the patients. The assets of a telecommunication operator is the accounts of the users. The assets of the bank is the bank accounts of the clients, and so on. Every organization has its own assets and has its own priorities in protecting its asset. An asset is what we are trying to protect. That's why we should know as security specialists what are the assets exactly. The threats may be person, thing, event, or idea which poses danger to an asset. The threat in terms of that breaks the asset's confidentiality, integrity, or availability, or causes some malfunctioning in the legitimate use of such asset. So it may cause denial of service on using such asset. So the threat is something trying to harm or damage one of your assets. A possible means by which a security policy may be breached is loss of integrity or confidentiality. This is a threat. Anything that can exploit a vulnerability intentionally or accidentally and obtain damage or destroy an asset is a threat. So it can be potential, it can be possible that this threat breaks the CIA confidentiality, integrity, availability of an asset. So it must be considered as threat, and it must be thought of how to face it, how to eliminate it, and how to get rid of it. A threat is what we are trying to protect against. Vulnerability, this is the weakness, this is the backdoor, this is the hole in our system. Weakness or absence of safeguards, this is the gap in the security program. It can be exploited by threats to gain unauthorized access to an asset. This is the danger of the vulnerability. When the vulnerability meets the threat, then risk exists. High vulnerability, high threat means high risk. If the vulnerability is low, the threat is high. If the vulnerability is high and the threat is low, so the risk may be low. But it is very dangerous to let the vulnerability go high and the threat go high, so your risk will be very high and it needs addressing at once. A vulnerability is a weakness or gap in our protection efforts. There is always a vulnerability in your system. Your duty is to explore your systems against vulnerability, strengthen, patch your systems, and try to let your vulnerability meets no threats at the same time, to minimize or to eliminate risk as much as possible. Thank you. Now let's define the risk and know more about the network intrusion techniques. The risk is what security deals with. The risk is the goal of security to be minimized. Security deals with managing risk to your critical assets. Security is basically an exercise in loss reduction, in risk elimination. It's impossible to totally eliminate risk, but you are practicing and applying your security technologies to make risk as minimum as possible. The risk assessment is a branch and a very well known section in the cybersecurity that you can be specialized into, and your goal would be to determine the sources of risk and to minimize them or eliminate them as much as you can. Risk is the probability of a threat crossing or touching a vulnerability. Risk is when the threat meets the vulnerability, and then both of them, if of high probability, then the risk is of high probability. Let's have a look at this formula. Risk equals threat multiplied by vulnerabilities multiplied by impact. Sometimes it is threat multiplied by vulnerabilities only, but here we are introducing the complete formula. If the threat is high, the vulnerabilities are high, then the risk would be very high. You have very high risk, and you should address and you should know how to eliminate. For example, the threat may be an attacker who is good at password guessing. The vulnerability may be some users that are not good at choosing their passwords. If both meet, then the probability of cracking the passwords would be very high. If one of them is existing and the other is not there, I mean if the attacker is there but users are using strong passwords, so the risk is less, the risk is smaller, and the risk can be handled in easier way. But if both are high, so it is something that we should take care of, and we should try to minimize either the threat or minimize the vulnerability. What about the impact? The impact is the third element that affects the risk. We can imagine at our example, if there is an attacker who is trying to guess a password for an account that has no value, that is useless, and at the same time the vulnerability is there because the user creating this account has used a weak password. You will imagine that the attacker can guess the password easily, but the impact of this password guessing and the impact of this loss of this account is small. So it is not of a big importance, it's not of a big deal. So the impact of losing this account is small, so this leads to a very small risk at the end. What are the intrusion detection techniques and what are the risks of intrusion detection? We can have some information theft. Breaking into computer to obtain confidential information means breaking the confidentiality of the information. Information can be used or sold for various purposes according to this theft. Data loss and manipulation, breaking onto a computer to destroy or alter data records, which means destroying means breaking the availability and altering means breaking the integrity of the data records. Identity theft, you may think first of stealing the username and password of someone before accessing his account and destroying his information. For example, personal information is stolen for the purpose of taking over someone's identity. Using this information, anyone can obtain legal documents, can apply for credits, and make authorized online activities. So, identity theft is the first step towards information theft. Identity theft is not a goal by itself, but it can be a step towards more dangerous attacks. Disruption of service or denial of service is preventing legitimate users from accessing services to which they should be entitled, which means breaking the availability of the service. Something that is very dangerous, of very high impact, and can be caused sometimes very easily by taking off the power supply of this router or of this server to cause this website to be down for some time. So the disruption of service is some risk of network intrusion. If you take off the power of the access point, the router, the switch, the whole network will be down. These are examples of some network intrusion, and here is a diagram that shows some hacker trying to hack from an external network the internal network that contains his victim through the internet. So by now we have introduced the meaning of risk and the possibilities and the risks of network intrusion. Thank you. Now let's know some of the common attacks in the cybersecurity and network security world. The social engineering. The social engineering is the ability of something or someone to influence the behavior of a group of people. It is related to fooling someone to give away some information that he is not supposed to give, like a username or password or a network map or some information that he is not supposed to tell you about as an attacker. Here in this diagram you can call for example, the employee of the technical support, telling him about a problem that is not existing, and out of his courtesy is trying to help you. So he may tell you the user ID of someone you need to know to attack, or the password, or something like this. Social engineering is a step towards more dangerous attacks, and it is very commonly used as a component of the attacks. Phishing. Phishing is some form of social engineering. The phisher pretends to represent a legitimate from outside the organization. The phisher tells the unsuspecting customer that he is maybe his bank, and he needs to know about his bank account and password to check his accounts. This is some sort of phishing. It can be over the phone, can be over email, can be by any means of communication that you are sending someone to fool him and to let him be your victim and tell you or give you some of his assets to be used. Let's know the difference between viruses, worms, and Trojan horses. Viruses are programs that run and spreads by modifying other programs or files. Viruses are always contained in one PC. A virus cannot start by itself. It needs to be activated. Once activated, a virus may do nothing more than replicate itself and spread, fill the hard disk, or damage some files, delete some files, or do something that is harmful to your data. Worms is just like viruses. They are harmful programs, but they have an advantage over viruses that can spread and copy itself to any connected host on the network, can run independently and spread quickly, need to attach itself to an existing program, do not necessarily require activation or human intervention. It can activate itself and run itself. What about Trojan horses? It's a non-self-replicating program. It is just a backdoor that is, or a rootkit that is installed on a certain system to give the attacker information or access to this system. It is a non-self-replicating program that is written to appear like a legitimate program when in fact it is an attack tool. It relies upon its legitimate appearance to deceive the victim into initiating the program. Once initiated, it's a backdoor. Once initiated, it gives the attacker access to this system. It may be relatively harmless, the software itself, or can contain code that can damage the contents of the computer's hard drive. But Trojans can also create a backdoor into a system, allowing hackers to gain access. The Trojan horse itself as a software may be harmless, but its harm is that it opens a backdoor. It allows an attacker from outside the host to access the host, to read the files, to delete the files, to copy the files, or to do anything to the binaries inside this host. The DOS and DDoS, denial of service and distributed denial of service. DOS attacks are aggressive attacks on an individual computer or groups of computers with the intent to deny services to intended users. You can launch a DOS attack like the diagram on the right on a web server to let this server down, to let the server inaccessible for its legitimate users. DOS attacks can target end user systems, servers, routers, and network links to let them down, to let them useless, to let them unaccessible for the legitimate users, as if the server is not there, the router is not there, or the network is not connected. The denial of service can be denial of service or distributed denial of service. The distributed denial of service is more sophisticated and potentially damaging from the form of the DOS attack. It is designed to saturate and overwhelm network links with useless data. The DDoS is a DOS attack that is distributed among so many attackers that may overwhelm or flood the network with useless data so that the network is down, so that all the servers, all the users on the network feel that there is no network and are denied their services. DOS and DDoS are very common attacks nowadays too, and sometimes very sophisticated to attack and to maybe launch launch some ransom acquisition against organizations. Brute force, spyware, and cookies. Brute force is done by a fast computer that is used to try to guess passwords. The attacker tries a large number of possibilities in rapid succession, possibilities of passwords, of course, in rapid succession to gain access to crack the code of the password, to guess the right password of an email account or Active Directory account, Windows account, or any type of account. Brute force attacks can cause a denial of service due to excessive traffic because it is repeated so many times to guess the right password, and it can lock out the user account. The attacker can cause this account to be locked out and not accessible by the legitimate account owner. The spyware is a program that gathers personal information from your computer without your permission or knowledge. This information is sent to advertisers or others on the internet and can include passwords and account numbers. It can include passwords, account numbers, and it can cause some damage and some harm for your accounts or banking accounts I mean on the systems, on the Windows and so on, or the banking accounts, and it is something that may cause some illegitimate access to such accounts, and it is something that we must take care of. Tracking cookies, a form of spyware, but are not always bad because they are used to record information about the internet user when they visit websites. You visit a website, tracking cookie on the code of the website tracks some of your information, your age, your gender, your country, your place of residence, in order to help advertising you with the right products that may interest you according to age, gender, and um, place of residence. The spam. The spam is a serious network threat that can overload ISPs or internet service providers, email servers, and individual and user systems. A person or organization responsible for sending spam is called a spammer. Spamming means sending so many emails or so many communication messages to so many recipients that are not related to each other, telling them something. Spammers often make use of unsecured email servers to forward email. Spammers can use hacking techniques to take control of home computers such as viruses, worms, Trojan horse. Spammers send an email with an attachment containing viruses or worms or Trojan horses to 1 million users, for example. 10 of them may open this attachment, may download and install this program, so the spammer by this way has gained access to these computers that were fooled by his attachment, and now it is under his control. Thank you. The journey has come to an end. Let's have some security recommendations and summarize some of the main recommendations that we can advise as security specialists to be made on the network. Let's have an idea about the malware propagation techniques. It is sometimes through the removable media, like the flash, CD, DVD, or something like this, flash memories or flash drives. The email attachments. Web browsing can be a propagation technique for some malware. Social networks can be also a propagation technique. The network vulnerabilities can cause the malware to spread over the network. Instant messaging applications can spread malware either through the chatting itself or through the attachment and files being transferred. The peer-to-peer networks, all of these are malware propagation techniques and should be taken care of, and we should be aware of all these, and we should put in mind how to defend against malware propagation through any of these techniques or any of these networks. It is recommended that you define a security policy always, and wherever you are responsible for security, ask for the policy. If not, then take it as your duty to define the security policy for the place. Use upgraded operating system. Use the most recent version of Windows or Linux, and update it with the patches of the Windows or Linux being published every now and then. It is always related to security, and it is always rendering to a more secure operating system. Enforce strong passwords, complex passwords that change every now and then, and that causes the account to log out after 3 or 4 bad login attempts, and that are not repeated and that are kept in the history. So enforce strong passwords. This is very helpful. Implement firewall. You should implement firewall to protect your network traffic from malicious traffic, and to protect your devices and internal network and demilitarized zone from malicious and wicked connections and attacks that may come through the internet or even from inside attackers. Isolate both of the DMZ and wireless networks through separate switches, through the firewall, or through any defensive technique that isolate your internal network with precious assets from both of the demilitarized zone that is exposed to the internet and the wireless network that is exposed to guests. Deploy antivirus on every single machine, maybe on the network, maybe. So deploy antivirus to protect your machines, to protect your systems from the viruses and malwares. Utilize IDS and IPS. IDS is very good tool and very good technology in security. IPS is also very good but is very advanced. Whenever they are necessary, go ahead and utilize them, but take care of utilizing IPS, namely because it may cause some problems, it takes some decisions, so you should be trained and you should be a good security specialist understanding what IPS does before using it. Consider honeypot if necessary. Consider deploying honeypot inside your network. If necessary, it may give you more and more information about your attackers and their attacking techniques and give you evidence and forensics about them. Upgrade and update the firmware of the switches, the routers, of the mobile devices, of any device that is running through a firmware. Upgrade and update the firmware always and whenever possible, because this upgrading and updating leads to better security for sure. Physically secure servers and network equipment, and consider the physical security of the servers, the network equipment, the machines, even the people themselves. The physical security is a very component and very effective component of the security posture of the organization, and it has the advantage of being simple in attacking and very effective in its impact on your network. Set login and file access permissions. It is always good to give the permission the same size the the same size that is needed, or the same size the employee or the legitimate users needs, not more permissions. Do not give the right permission for someone who only needs to read the files, or delete permissions for someone who only needs to read and write the files. Change permissive default settings, default passwords for switches, routers, access points for the Windows devices or Linux devices. Think of the default settings as a weak point, as a vulnerability, as a backdoor for your security, and consider changing them if they are permissive. Never leave any default setting unchanged unless it is necessary and essential. Run antivirus and anti-spyware on the machines. Update antivirus software files. These are two recommendations related once more to the antiviruses. Antivirus and anti-spyware are good, will protect the machines and may protect the network. Update the antivirus, keep the antivirus updated, and of course use licensed versions of the software to be able to update it. Activate the browser tools like the pop-up stoppers, anti-phishing, the plugin monitors, and so and so. All these browser tools may protect your host machine from being broken by confidentiality, integrity, or availability, from being giving away confidential information without your permission or without even your knowledge. Thank you.